It's time to find a little bit more about me. Well, what do you want to know about me? My name's Guy VACCARO. There's a picture of me looking rather dashing. I've been training for over 15 years now. I do classroom training, computer-based training, and manual writing. Obviously, I know quite a bit about Microsoft Excel. Don't claim to know everything, but I do know a large amount, and that's the basis of the premise for this particular title. I also do training in the rest of Microsoft Office Suite and in web and database design. Now, I like to tell people a little bit about me during this about the author thing. Something hopefully that you may not know, that VACCARO, my surname, actually means cowboy, which conjures up an image of the Wild West, riding for days on end, rounding up cattle. Actually, if we go further back in my heritage, it actually stands more for peasant cow herder, not the Wild West. So I will have been collecting 1 or 2 cows up in a small rural community. But the name still stands, cowboy. Hope you've enjoyed this title. If you feel you need to contact me, please feel free to send any queries, comments, or questions at all to my email address, training@nybytes.co.uk. And enjoy! As always, we supply a set of working files available with this training title. Those files, once installed on your desktop, will then have a separate chapter for each of the chapters of the actual title. Within each chapter, there are then some working files. So we see chapter 1 there, which is effectively the introductory chapter, has no working files. Chapter 2 has 3 working files. Now, in some cases, obviously some chapters have more than others. Some chapters will have the same named working file as other chapters. So you really need to make sure you're using the correct file from the correct chapter, just in case the setup or some of the data or some of the columns are not quite the same. Some of the chapters contain a results file. So we see here this one, contact summary _ charts result. The results file is what effectively you're aiming for at the end of the lesson. So I give you the end file as well as the starting file. So some of the chapters will have a lot of files. So for example here, chapter 6 has dynamic ranges and then dynamic ranges _ result. Sales data charts _ result. So obviously in that particular chapter, there is a lesson that uses the sales data file to create a chart, and this results file is what you will see at the end. Some chapters even contain non-Excel files. Chapter 9, for example, has a MP3 perspectives and then population.earth.mp4. So it has other files within the folder, but obviously they're mentioned inside the particular lesson that they refer to. Welcome to this Excel training title that is going to cover how to use Excel with data. This title really is quite intensive and starts at the beginning. So our agenda is going to allow us to look at data manipulation, data cleansing, tables, pivot tables and charts on their own, not as part of pivot tables, then some seriously powerful tools in Power Query, Power Map and Power Pivot. We also then look at Goal Seek and Solver, and a number of the data analysis tools. So there's quite a lot of meat in this particular title to get through. Now in the basic data manipulation, we're going to look at fixing the data headings on the screen, but also when you print, how to sort and how to filter data, and how to create charts in really a split second. We then look at data cleansing, pre-requirements of data cleansing, how to remove duplicates from your data, a few text replacement tricks, taking out non-printing and special characters that you sometimes get when you import data from other sources, changing case so that you can control the consistency of presentation of your data, how we can alter the appearance and the placement of various columns and rows within your data, and then splitting and merging various data values. We explore tables, why even use tables, why have tables even been added into Excel, how they can aid in quick formatting, how you can have total rows and columns created for you with a tick of a button, how you can even add in your own calculating columns, and then how tables help you with sorting and filtering, data entry using a form into your table, and then creating a quick chart using your table data. We then move on from tables to pivot tables, the new recommended pivot option, controlling the data summary calculation. So what effectively happens in the middle of a pivot table? Sorting and filtering of your pivot table result, drilling down into the data that is presented to you in your pivot table, controlling your grand totals and your subtotals, making use of the data slicer, and then even connecting your pivot table to SQL Server. After pivot tables and a quick exploration into pivot charts, we then explore normal charts, so those that don't involve a pivot table, and look at a few tips and tricks, adding and managing trend lines within your charts, how you can have a dynamic range for a chart, so if the range increases, the chart knows about this new range, and then exploring the new forecast worksheet. Then we get down to some real power, looking at Power Query, that actually from Excel 2016 onwards is called Get and Transform. We explore various data sources that you can get data from, be that locally, be that the web, be that external databases. We then have a look at Power Map, which is a great tool add-in for Excel, allowing you to create 3D maps, and we explore how you can add data to your maps, use layers and scenes and filters within your map, and then how to export that 3D map so that you can perhaps place it on YouTube for people to have a look at, or add it to a PowerPoint presentation, for example. Then we get to the real power in Power Pivot, which effectively is pivot tables on speed. We explore how we can connect Power Pivot to external resources, how we can join tables within Power Pivot, even tables that really effectively aren't connected, and then how we can use that data to create a Power Pivot table or a Power Pivot chart, even adding in our own calculated fields to the Power Pivot data. We explore GoalSeek, which is a very simple tool for trying to obtain a target value of a cell. Where that falls over in its lacking, we can then look at Solver. So firstly, that has to be installed. We have to create a Solver solution, and we look at how we can add constraints and make use of scenarios within Solver. And then the final stage of this whole data title is looking at some of the data analysis tools, how to install the analysis toolpack. Just as an example of some of the options in there, because there are quite a few, we look at descriptive statistics, creating a moving average, and how to create a histogram with a bell curve. Hopefully, you're going to enjoy and learn quite a lot from this particular title, especially if you use Excel for data crunching. Now, if you have any queries, questions, or comments at all regarding this particular title, then you can direct any of these to me using my email address, training@nybytes.co.uk. Enjoy!
Greetings and welcome to your O'Reilly training course. This movie is going to help you find and easily access your working files for your O'Reilly course. The working files are designed to allow you to work alongside the author as they're teaching the course material, and in most cases, the author will announce whenever they have provided a working file. Please note that the courses seen in this video may not be the same as the course you are currently learning. This video is meant only to demonstrate how to get your working files. If you are a subscriber to our learning library, you will see a Download Working Files button once you get into the details of the course. To download the working files, simply left-click on the Download Working Files button and your browser will automatically download the working files as a zip file. Once the working files have finished downloading, you can simply extract the downloaded zip file and place them directly onto your desktop. It's as easy as that. If you have downloaded this course from our website, then you will have gone to a download page that looks like this, and you may see that the working files are a separate download file. Once you have downloaded the working files, you can extract the downloaded zip files and place them directly onto your desktop. From the player, you will see a menu bar located up here with various buttons just above the video. From the player menu bar, look for this button. When you move your mouse over it, a label will show up that reads Open Working Files. Left-click on this icon and a window will open up to show you where the files are located. You may see multiple files as the working files are organized within them. To make things easier for yourself, we suggest copying all of these working files to the desktop of your computer. Please note that if you downloaded the working files separately, as we mentioned earlier, you will not see them here. However, you should already know where they are, as you should have extracted them and placed them somewhere on your computer, well, like the desktop. If you are watching this from the DVD, there are a couple of ways to access the working files directory so you can open up your files. Now, you will only be able to open these files from the DVD. If you make some changes and would like to save them, you will need to save them onto your computer. Copy the working files to the desktop, as we have shown earlier from the player. This way you can find them quickly and easily because they are located on your desktop, and you can open and save any changes as you work along with the lessons. You can also find the working files by going directly into the Files folder. To get to this folder from your DVD on your PC, go into your computer, find your DVD drive with the disk in it, and select it. You will see that there will be a Working Files folder on the disk that you can drag and drop to your desktop. You can also copy this to your desktop by right-clicking on the folder and selecting Copy, then right-clicking on your desktop and selecting Paste. If you are on a Mac, click on the DVD icon for the disk on your desktop. A window will open and show you all the files on the disk. You can then drag and drop the working files to your desktop. You can also copy this to your desktop by right-clicking on the folder and selecting Copy, then right-clicking on your desktop and selecting Paste.
It's important when working with data in Excel that we have a grasp of the basics before we then move on and add in much more complicated features that Excel can manage. With that in mind, the first thing we're going to have a look at is being able to freeze or fix headers or columns on the screen at the same time and freeze them when you print, because it's actually two different settings. So if we take our contacts file, which has a lot of information within it, there are a lot of rows here, and as you scroll down, you lose the top row which has the column headings in. And when you scroll to the right, you lose the names of the people. So what we should be able to do is freeze this top row so we keep the headings, and we do that from the View ribbon, Freeze Panes, and we have a number of options. One is to freeze the top row, which is effectively what we want to do. And when we choose that option, the top row is then frozen on the screen at all times. Freeze Panes and Unfreeze Panes then brings it back loose. Be careful with this Freeze Panes, Freeze Top Row, because it freezes the top visible row, not the top row. So if I'm actually down the bit and I go, oh, I need to see the top row, I can't go freeze top row because it freezes this row here, the top visible row. So you have to make sure, on Freeze Panes, that you're actually at the top of the sheet when you ask to freeze the top row. Alternatively, we could freeze the first column, and that will freeze the customer ID. So we move to the right. Customer ID is on the screen at all times, so we know what this education and occupation information refers to. But notice it hasn't frozen the top row, because using the two quick options of freeze top row and freeze first column, it's either one or the other. If we need both frozen, or even more than two rows or two columns frozen, then we need to use this top option, which is available once we unfreeze the panes. You then see Freeze Panes. Now with Freeze Panes, it matters where your cursor is. So if I want to freeze the top row, and then let's go for first three columns, because the title is pretty much empty, then I need to make sure my cursor is here, in D2. The point my cursor is at is where any rows above there will be frozen, and any columns to the left will be frozen. If I now go Freeze Panes, freezes above and to the left. So I can scroll down, and the top row quite happily stays there. I can scroll to the right, and the first three columns stay there. So I can see the ID and the surname of all the rest of the information I'm visiting over here. So that's Freeze Panes. Only works on the screen. Bear in mind these two are great for quick freezing, but don't always do what you want them to do. If I want to freeze both columns and rows, I have to go with the top option, which I have to unfreeze first, and it will freeze every row above and every column to the left of where you currently have the cursor. If you want to freeze the top row or even a column in print, so if we go to File and Print, Show Print Preview, we can see the titles are on there, but as soon as we go to the second page, we lose those titles. In order to fix those, we have to be in Page Layout, completely different area, and Print Titles. One click, here's my option to repeat any rows that I want to be repeated on every page, or any columns that I want to be repeated on every page. So if I want the top row, I click into here, I then click the top row, and you can see it puts $1, $1, so it's effectively fixing the top row. Straight to Print Preview from here to see if that works. Page 1 will always work, but what about the subsequent pages? Page 2, page 3, page 4, all have the column headings on them. So that's Page Layout, Page Setup, Print Titles, rows to repeat at top. And should you want any columns to be repeating on the left-hand side of every page, then I can go Columns to repeat at left and highlight the column or columns that I would like to be repeated. So every page will have the headings across the top, and every page will have the customer ID, the title and the first name on the left. That will obviously create a lot more paper, 26,445 pieces for our data, but you get the idea. I'll have to scroll quite a way through. There you can see customer ID, title and first name are on every page, and here we are on the page that only has room for the age column. That's actually the last column in the data. Back a little bit further, you can see the first 3 columns and then numbers of cars owned and day birth. Choosing to have 3 columns repeated on every page doesn't leave much more space in our portrait layout for additional columns. You're in charge, you have it how you like. That's print titles for controlling what gets repeated in the print version. If you don't want any columns, you just delete the options that are in there. Okay, but view and freeze panes for controlling what gets frozen on the screen, hence the name really. So those are 2 different options, effectively doing the same thing, but one for the screen and one for the print version. Let's take our contacts working file and explore the second most important thing when you've got a set of data, and that is the ability to sort that data. Now, Excel will sort data very quickly. You simply place your cursor in the column you would like to sort by, say for example, last name. On the home ribbon, here's our A to Z sort. In the little drop down, we have 2 options, either A to Z or Z to A. Very quick and easy. One click here, sort A to Z, will sort all of my data into alphabetical order of last name. So we see all the Adamses are at the beginning, and as it scrolls down, we eventually leave the Adamses and we hit the Alexanders. Likewise, we can go same little icon, Z to A, and then there will be backwards sorted by the column that you're currently in. So now we have the Zs at the top. Doing this without actually highlighting any of your data works in Excel as long as you have column headings on every column. Here we see suffix doesn't actually have any data. There probably is some a bit further down, but having the column heading means that all of my data stays together. If, for example, I had a totally blank column in here, let's insert a blank column, then what happens if we then try to sort by last name? Keep your eye on these phone numbers and email addresses. We go sort A to Z, I'm in the last name column, so we'll sort the last name. It doesn't sort any of this. See how Jake is still here and hasn't moved, but we do have the Adamses at the top. That's because Excel sees this totally blank column as a gap, as a sort of end to the data set. And all it would need is a little label in there for it not to do that. So now I've mixed my data up, which can be disastrous at the least, really. Let's do an undo before we get any further in, and then remove this column. So your data must be continuous. Not necessarily something in every cell, but certainly a heading label all the way across will ensure that none of your data gets mismatched. That way you can then pick any column and be happy that when you sort by it, it doesn't just sort by that column, it keeps all the row information together. Now all my Aarons are at the beginning, but we still have the correct last name, phone number, email address, customer ID, etc. So I go back to customer ID and I can put these effectively into their initial order, which was of customer ID number. That's great, but what happens when you want to sort by 2 columns? So I want them in last name order, but then where the last name repeats, I want them in first name order. That doesn't happen with the quick icons here. What we need to do instead is go to the drop down and choose custom sort, in which case I will get this dialog box. Shows me the current sort, which is by customer ID, smallest to largest. I need to make sure this tick is in because my data does have headers. Now Excel spotted that on its own. Sometimes it doesn't, and you need to put the tick in manually. With the tick in, the columns to sort by are actually labeled rather than A, B, C, D, E, F, G. Now I can choose to go by last name. Then as a secondary sort, I can add a level and choose first name. So it will firstly sort them by last name. Where there is repetition of the last name, I can then sort by first name. Where there is repetition of first name, I could perhaps then sort by customer ID. Notice we have sort on values or cell color, font color, cell icon. So we have other options in there. We're sticking with the data for the moment, so that's the values. And then the order is A to Z or Z to A. And here we have in customer ID, smallest to largest and largest to smallest, which effectively is A to Z and Z to A. But because Excel spots their numbers, it changes the terminology. So it becomes smallest to largest rather than A to Z. Let's see if this works. Okay. So all the Adamses are at the beginning. Where there is repetition of the surname, and there are quite a few Adams, it then goes by first name. Then we see all the Aarons, all the Adams, all the Alex, Alexandra, Alison. Where there is repetition of first name, which in our data there is, so the surname repeats and the first name repeats, then they should be in customer ID order. In fact, that's repeating as well, so we'd have to assume that they are in customer ID order. So that's where you need a sort that is more than just picking on one of the columns. You need to go into custom sort, choose the correct order for your sorting, and then OK. Back in this dialog box, we can remove any levels. So if I don't want to sort by the customer ID, I can delete that level. I can delete this level, and I can even delete the last level, so we don't have any sort in place whatsoever, and the data doesn't change. If I want to go back how I was, well, I remember I was in ID order, then I need to do ID order. I explicitly have to tell it the order I want to sort things by. Being able to sort your data makes life a little bit easier before you then trying to look at manipulating your data. As well as using our large data file here, contacts, for sorting, we're going to use it for exploring the other great tool within data manipulation, and that's filtering. If you have a lot of data, you don't want all of that data, you need to be able to filter some of that data away, and then you can deal with the actual relevant data that's left. Filtering in Excel requires the activation of the filter tool, and we do that by going to the same little icon, sort and filter, but in the drop-down we choose filter. That then gives us these little drop-down arrows at the top of each of our columns. With these little drop-down arrows, if we choose one, let's go for the last name one, you can see we can actually sort within here, but then below there is where the filtering takes place. Now in the list, you will see one option for each of the unique values. And the simplest form of selection is to actually just remove the ticks. If I don't want some of these people, I can just remove their ticks. If there are a lot, then sometimes it's actually easier to choose the select all, so it deselects all, and then handpick the ones you do want. I've just chosen 4 surnames there, so when I say OK, that filter is applied and I only see those 4 surnames. Down in the status bar here, we see I've got 844 records out of the original 74,032. The row numbers remain the same, but they go blue, so that is your indication that the rows have been filtered, plus the filter icon gets a little filter on it. So instead of just being a drop-down arrow, it gets a filter with a drop-down arrow. So you know which column is having an effect on the filtering, which one is reducing the size of your record set. So in here, I've chosen a number of the surnames. So we're only filtering to see these 4 surnames. I could even then add in an additional filter. So perhaps going to the first name, remove all of them by saying select all, so that all the ticks go, and just choose a couple of these. And then my result set is filtered down even further. I'm now down to 20 records. Again, they stay blue, and I have 2 little icons in place to show which of the columns are doing the filtering. That's straightforward filtering, where you simply select from the values within the data. Let's bring all of those back and do the same with the last name. Let's bring all of those back. Now, no filtering is taking place. The row numbers are back to black. As well as being able to just simply select values that exist, we can come down to text filters and choose one of the comparison options. So equals, does not equal, begins with, ends with, contains, does not contain. Say I wanted all of the surnames that began with A, I could choose begins with and choose A. There is an option here for adding in an additional filter at the same time. So here we're choosing last name begins with A. Okay. And then all of these people have a surname beginning with A. There's nothing to stop me going back into there and saying begins with A or begins with B, and I could have everybody that begins with A and B. So we see Alvarez and Bennett, so we can see that that's working. Now if I wanted a range, then I could clear this filter, come back into text filters and choose custom filter, because there's no between option here. And in here what I can do is say is greater than or equal to A and is less than or equal to F. And that will give me everybody whose surname is greater than A, anybody whose surname begins with A effectively, or B, or C, or D, or E, because they're all greater than A, but less than or equal to F. Well, nobody's surname is actually just F, so it would be everybody up to the E's. Okay, and we see 15,292 records. So although, strictly speaking, it's not a between comparison filter, you can use it with text, in this case where we said more than. Have a look in there, custom, greater than or equal to A, but less than or equal to F. It's effectively between A and E. You'll find that those comparisons are slightly different. If we were to look at this field, for example, which is a number field, you see that we get a lot more. We get top 10, above average, below average. all the less than, more than, greater than, even the between option here is available because we're dealing with numeric values. So the filter comparisons you get provided to you do differ depending on the data type of the actual column. But despite that, the same option exists for selecting manually, picking from the unique values within the list, or choosing one of the comparison options and then entering your values. All the ones with 3 dots require values. Don't forget also that filters compound. So we have a filter in place here on last name that is between A and E. If I then went to the customer ID and said customer ID is greater than 20,000, then that filter will be applied on top of the A to E filter. So we're now looking at customers whose surname begins between A and E, and their ID is greater than 20,000, and the numbers have dropped to 7,804. So all filters compound on top of each other to reduce the amount of data you've got then to work with to do whatever you wish to do. If at any point you want to remove all the filters, you don't need to go finding all the little icons with filters on. We can simply go back to sort and filter, choose the filter option here to effectively remove it, and that takes the little drop arrows off the top of each column and removes any filtering that is occurring. So all of your data is then returned back to you. And the row numbers are black instead of blue. That is your big indicator that the data is not filtered. So that's filtering, a very useful tool when you're dealing with large sets of data in Excel. The last tool that we want to experiment with at this stage in proceedings is the ability to create charts in what can only be described as a second. We do explore charts a lot later on and in much more depth, but for the moment we're dealing with how to do them really very quickly, because the chart really can tell a very quick story. If we take our contact summary file, which is our contacts data but with a summary sheet within it, and you can see it has 2 summaries in here. One is the total number of sales by country, and the other is the total sales by any given month and year. So for example, we go June 2003 and we have 4.7 million. Both of these would graph very nicely, and to create a graph in a jiffy, we simply click into the data. So it's a bit like sorting and filtering. We don't need to highlight anything, as long as there are no gaps in the presentation that would stop something from being graphed. So we click into our first set of data, which is the countries and the total sales, and then one single keyboard shortcut of F11 will create a very quick chart, which is a simple column chart, but it does what we've asked it to do, which is to create a graph. We could then change its chart type here to any of the other given chart types that might make sense, and this information will look quite good in a pie. And then you have a set of predefined templates for this particular style that you could choose from that apply different bits of labels and information depending on which one you choose. And then you could go a step further and actually add, edit, or remove any individual chart elements. But I do quite like that one pre-built option there. It's a 3D pie, gives me the percentage breakdown, and I can see each of the countries. Maybe I want the labels on there. That one option gives me that one. And this one here just gives me percentages in white on a dark color. Whichever option I go for, the data is untouched. This is presenting the same information, just in slightly different ways. So that was a quick chart, F11. We can do exactly the same with this data. Now this is slightly different in that I want to highlight that bit to be graphed. If I just click in and do a quick chart, it will try and graph the 1 to 12 as well, which is only being used to pull the data through. So I've got the years, the actual data values, and then the months of the year. Same keyboard shortcut, F11. Creates from the same style of chart, the column chart. That again might not be the right type of chart for your particular job. Change the chart type. This could look quite good as a line. Okay. And you see we then get one line for each of the years. And then January to December is along the bottom. So effectively it's a time graph of our sales within each year. So the green one will start to go up and then seriously drop and then slowly go up again. That's 2003. The purple really go up quite well to halfway through the year. Then they drop right down to nothing. 2001, they start at nothing but shoot up and then slowly climb. And then probably the best year is 2002, where we had a climb and then a little dip in the second half. Then it slowly climbs up again. Select your data, or don't select your data if you want all of it in the chart anyway. And then F11, probably the most used key after Control S for save, obviously, that you will ever need in Excel. There are times when dealing with data in Excel that there is a requirement to clean that data. Now, by cleaning the data, we mean quite a number of things, really. The data may have arrived from a web page, from another database, from somebody having just typed the information into Excel for you. But however it got there, there is a chance that it will need some kind of tidying up. So when it comes to data cleansing, there are a number of steps to follow through. You take your data. The very first step is to then create a backup of that data, should you happen to break anything during the cleansing process. And then the steps for cleansing are really straightforward. Firstly, we will start with a spell check, just to make sure that there's no misspellings in the data, particularly if the data contains notes or information. We can then remove duplicate rows. We can then look at finding and replacing particular text values, changing the case of text. This helps to maintain consistency of presentation of your data. Removing spaces and non-printing characters, very important if you're then wishing to manipulate this data further down the line. We can look then at fixing numbers and number signs so that things are either positive or negative, fixing dates and time formats so that you don't have inconsistency of use of those throughout your data, merging particular data values, so 2 or 3 columns may be merged into one, or splitting columns. One column may be split into 2 or 3 columns, depending on what you need to use the data for. Rearranging where columns and rows appear in your data, and then even reconciling multiple data extracts that you may have by joining or matching them to other sets of data. So there's quite a few things that we can do within Excel with data that we've extracted from another source, be that typed in from the web or exported from an external database. If we take our working file, Contacts 2015, we can carry out the first 2 important steps, which is to create a backup copy of the data and run a spell check. Now we can carry out the backup in one of 2 ways. We can either create a copy of the whole file and leave that untouched, or if the data is within a single sheet and a single workbook, you want to keep everything there, we could simply just copy the sheet. So I could take this sheet here, move or copy, create a copy, and we end up with a second copy that completely replicates the first. And I will just rename this as backup. So this sheet does not get touched with any of the work that I'm going to carry out, whether that's removing duplicates, spell checking, changing the case, removing non-printing spaces, altering the date and time formats. Everything that we're going to do does not happen to this backup. I've broken everything. Let's revert back to where we started from. The contacts one is then where I do all the work. And the first bit of that work is to run the spell check. Now the spell check command is on the review ribbon, and it's the first little icon there. One click, and it will step through your Excel data. Now sometimes when you're dealing with data that has been extracted, there's a lot of things that will not be in your dictionary, but they're not spelt wrong. For example, here we've found Sino, which is actually the name of a street. So I'm sure that a lot of the time with your spell checker, you will be doing ignore all. So every time it sees Sino in this data, it will ignore it. Same with Brookview, Oliveira, Raji, Osram Wazenzi, Wikarfun. A suggestion now is not actually to run the spell checker as we've done here, which is on the whole set of data. The chances are that every single surname will cause a problem. Every single street will cause a problem. What I would suggest is that you don't run the spell checker on the whole sheet, or you could just be there all day checking the spelling, is just to select any column that might contain text or descriptions. Say, for example, these 2 here. With those highlighted, then run the spell checker, and it will only want to run the spell checker on the 2 highlighted columns. And it actually says spell check is good to go. Thank you. Nothing is spelt wrong as far as Excel is concerned in those 2 columns. And that saves you running through the spell checker on all these names that are likely to cause a spell check to fall over, or on street names that are likely to cause a spell checker to fall over. You highlight the column or columns that you think potentially there could be spell checks needed, and this will be description columns, information columns, and only run the spell checker on those columns. If it finds anything, it will pop up, make the change if required, and continue till it's finished. Not on surname fields and street fields and town fields, where it is likely to come up against a lot of spelling mistakes, as it would be classed as, but they're not mistakes. They just happen to be from that locality. That's the basics of data cleansing. We take a copy so that we don't break the original data, and we can always go back to that at some point, and then we start off on our little process of data cleansing. The first of those steps is running the spell checker. Amongst the tools Excel has in its armory for helping you deal with cleansing your data is the ability to remove duplicate records. Now, the duplicate records removal tool does exactly that. So before actually using it on any set of data, I would certainly recommend backing that data up. Here we're going to take the Contacts 2016 working file, which has a lot of records, and in fact, a lot of them are duplicated. So we click into our data, we go to Data, we choose Remove Duplicates. I'm just going to resize the box. Now in here, we have to decide which of the fields must be duplicated for the row to be counted as a duplicate. If I leave all of them ticked, it will only count records as duplicated if absolutely every single value on that line is the same as every single value on line B, for example. That even includes the customer ID. So if that is repeated in here, I certainly have got duplications. I'm going to leave them all selected for the moment and say, okay, let's see what happens. And it finds 55,524 duplicate values, and they've been removed. There's no, are you sure you want to remove them? They have now gone. It's going to leave me with 18,508 unique values remaining. And by unique values, it means by using all the columns of every row, they are different. Okay. That's why I suggested you take a backup of any data before you run the Remove Duplicates tool. Ideally, what it ought to do is say, I found this many, do you want to proceed? But it doesn't. It takes them away. So you then need to go back to your backup record. Now, you don't need to use all the columns when you're looking for duplicates. If I go back into Remove Duplicates, I choose Unselect All. That unselects all of my columns. Perhaps I'm just looking for duplicate email addresses. Okay. It says 24 duplicates were found and removed. 18,484 unique values remain. Now, that's fine, but it's taken 24 records away, and I don't know if any one of those was actually the right one. It's just kept the first one it found. So I say, okay, those 24 are gone, but luckily there's an undo. Just going to undo the first one, remove duplicates. Now I know there are 24 duplicated email addresses. What I could do instead of using that tool is let's insert a column here. I'm going to put DUP at the top, which is the abbreviation for duplicate. And I'm going to count how many times that email address appears in the email column. So equals count if, open brackets. The range is column I. Now I don't really know how far down the records go. I could highlight the cells, or we can just go with the whole column. Remember, you can only use full column references from 2013 onwards. If you're on an older version of Excel, you will have to use the whole range. So I2 to I wherever it gets to, somewhere in the 18,000 mark, I believe. Comma, and then the value I'm checking for in the range is actually that first one there, I2. Close brackets, return, and it says it appears once. Now, before I replicate this, I just need to make sure that I fix column I. Now, it won't move the column because it's the whole range, but just to be on the safe side, we'll put our dollar marks in. That's F4 while the range is selected. Put the dollars in. And then I can replicate this. Because there are so many records, 18,000 plus, it will just take a little while to copy the formula down and then run the calculation so that it can work them all out. Once that reaches 100%, we'll then be able to check which of the email addresses are duplicated. It might be that there's just one duplicated 24 times, or it could be 12 duplicated twice each. Once that is complete, I will then need to sort by my duplicating column, sort Z to A, so that the highest numbers are at the top. And again, we have that perceptible pause because of the quantity of data. Obviously, the more RAM you've got, the faster that process will be. And then when it gets to the end, we find all the ones that have a 2 effectively. So it looks like it's actually quite a few records repeated twice. There we are. So a lot of email addresses that are repeated twice. Then I can decide which of these 2 I wish to keep. It's the same name, same phone number, same email address. The difference is its shipping and home address are different. So I then need to decide which one of those I wanted to keep. Potentially I want to keep both. And the same for the next duplication, and the next, and the next, and the next. This gives you that little bit more control than just doing a blanket remove duplicates. Sometimes the blanket remove duplicates is what you're after. I know there's a lot of duplicates in here. I accidentally downloaded the same data twice or 3 times, for example. Then remove duplicates is fantastic. Here, when we got to looking at the email addresses, it was perhaps a bit too indiscriminatory, so we added in our own little function where we were actually checking. So using the countif, we were able to check how many times that particular email address appeared in the email address list, and then we sorted by descending order to get the most frequently occurring at the top. Then we can manually go through and decide which of our records, if any, we then want to keep in our final result. That's the Remove Duplicates tool. Great little tool, used many times. Just for those times when it's perhaps a little overzealous, we have the ability to use a function, here we've used countif, to count how many times a value occurs, and that way we can manually check which of those records we want to keep or not want to keep. We've seen how we can remove duplicates. Let's have a look at how we would go about changing the case, therefore starting to manipulate the data ourselves. Now, for this, we're going to use a smaller working file. This is the contacts extract A. And instead of having the 18,000 or the 70-something thousand records, it simply has 100. That way we can easily get to the end and check what we're doing. There we are, 101 rows, which is 100 records. Now, changing the case involves a two-step process. Firstly, we need to do the backup, as we're trying to force ourselves to remember. Now, in this particular case, we have contacts extract A. I'm going to save that whole file as a backup file, so I can always go back to it. Save as, which I've used the keyboard shortcut for, which is F12, contacts extract, and then a little hyphen for backup. And then I can close that and reopen the extract A. This is the file I'm now going to work with. I have my backup file, which I'm keeping. As I look down the last name, I can see there's a mismatch on the case. Some are in uppercase, some are in title case, and one is actually in camel case, where it has the lowercase and then uppercase characters. What we're going to do here with the changing case option is what we will do with a lot of the other functions that change things. We'll create a new column, use the function to make the change, and then copy and paste the value back on top of the range. We want to change the last name, so we insert another column to the right here, and then I can use a function working on the last name that changes its case. Now there are three case functions: equals, upper of that cell, return, shows me that value, in this case the value of E2, in totally uppercase, so that's cook. And if I double click there to replicate the formula, I then see all the surnames in uppercase. I'm going to put a column header on there, uppercase. Ordinarily, you wouldn't do all three cases in one go, but this is more of a demonstration. I'm going to insert two more columns, and we'll header one up lowercase and one title case. To get the lowercase last name, if that's what I'm trying to achieve, then we put equals lower, open brackets, of E2, and you can see it's all in lowercase, and then replicate that formula, and I see all the surnames in lowercase. And then the final case option here is title case, which is equals, and it's not equals title, which would be a nice guess, it's actually equals proper, open brackets, select the particular cell, again E2, return, and I get cook in title case, or proper case as Excel wants to call it. Let's replicate the formula, and then all of my surnames are in title case. Jackson was in uppercase in the original data, is now in title case, and the one that was in camel case there, Raji, is now Raji in title case. Now, depending on which one of these you want to retain, because they're all just formulas based on the last name column, say for example I would like uppercase, we can take the uppercase values, I select all of those, all 100, I then copy, so I've got my little marching ants, I then go across to the start point, which is cook in the data, come to paste, but don't just choose the big button, choose a little drop down, and then I want to paste the values, because I don't want to paste the function, which is what's in these cells, I want to paste the value of these functions back onto the last name column. Paste values, and then all of the last names are now uppercase characters. And you can see if you enter, it's actually got the word Hayes as opposed to a formula telling you to uppercase E9. If you're happy that's what you're after, then these three columns now no longer are needed. They've done their job, which was to alter the appearance of the text into the case that I wanted. And then I used the one that I wanted, which was uppercase, to then paste special back on last name. So I can delete those. And I know I'm not going to lose any specific data. That can be done with any of the columns that you wish in your data. Maybe you want to do the same to the state province name. We insert a column. It doesn't have to be to the right, but for some reason I always insert to the right. The formula for the case that I would like, and the choices are upper, lower, or proper. Let's go with upper again for the province name. Copy that down using the fill handle. Shows me all the values now in uppercase. Don't forget that's just a formula. I can copy that back onto the state province name, paste special. This one here in the middle is the paste value, and the uppercase values then get pasted back into the original cells. So I now no longer need this column here. This is just effectively a working column. Once it's done its work, it's used the formula to create the value that I'm after, and I then do paste values back on top of the original data, and my original state province names are now uppercase, and my surnames are uppercase. Now that's quite useful, like here where we've done a mass change of everything to a different layout, in this case uppercase, but it's also quite useful for doing a mass change where the data is a bit mishmashed, where you might have some in uppercase, some in lowercase, some in title case, where you want to make them all consistent. That's one of the points of your data cleansing, is to bring in some kind of consistency in your formatting and your presentation. Here we've seen how we can change the case into upper, lower, or title case using the three functions upper, lower, or proper. Another great cleansing tool that is extremely useful is the ability to replace parts of the text of the data that you have. Now there are really two methods for doing this. One is to use Excel's commands, and one is to use Excel's functions. We're going to take the contacts extract backup file that we've created and save it with the new name so that we can do our new work on it. Save as, and having no imagination, I'm going to call it contacts extract B. In this B file, it doesn't matter what I do because I can always go back to the backup. The two ways of doing replacements of individual characters or strings within your data are firstly to go through Excel's commands or to use Excel's functions. Let's look how we could use the commands. The commands work by looking for a value you've asked for and replacing it with something else. It may be that here in the phone column we've got a lot of these open and closed brackets, and I want to replace those with a different symbol. The first stage is to highlight just that column, so that the replacements that we carry out are only taking place down that column. If it needs to happen to more than one column, then simply highlight more than one column. But if you highlight nothing, it will occur on the whole of the data, so every single column and every single row. I then need to bring up the Find and Replace dialog box. We can go through the menus. Here we have Find and Select, and there's Replace. It's much quicker to just do Control H. That way we have a Find What and Replace with What option, and it will only apply to the highlighted column. So in that highlighted column, I'd like to find all the open brackets and replace them with speech marks. Now if I click Replace, it will replace the first occurrence within that column. If I click Replace All, it will just do them all. And if I'm happy that's what I want, then that's the quickest method. I know we're dealing with an extract here that only has 100 rows, but we could have been dealing with the original data of 75,000 rows or 100,000 rows or 500,000 rows. If we're confident about the replacement, just go Replace All. Don't forget, you've always got your backup to go back to. So Replace All. And it tells me 51 replacements were made, which is pretty much half the records. I then want to do the same column, so I keep it selected, replace the closed bracket with the speech marks, and Replace All, and again 51 replacements are made. And I can see in the data I now have speech marks where there were open and closed brackets. That's the straightforward Find and Replace tool. Now if we want to use it on another column, for example the address line 1 here, I might want to sort out these abbreviated road names. I highlight address line 1, bring up the Replace dialog box, Control H, and I want to replace RD with road. Now in the extra options, you can force this to match the case, in which case it would only be looking for uppercase R, lowercase d. If you don't match the case, it will find R and D in that address line 1. I'm going to leave match case off for the moment and just condense the options there. Before I click Replace All, just watch this VACCARO there. The reason I'm asking you to watch that is because it has an R and a D in it, which is what I'm replacing. So Replace All done, we've made 9 replacements. And you can see the RD in VACCARO appears to have disappeared. That's just because the column's not wide enough. And we can see in the middle it's put the word road. This is a good reason for having a backup. Although, because I've just done it, I can do undo. Make sure I go back and make the replacement undo. There we are, Cardona. This is where you need to be a little bit more careful. I'm going to go into the replace again. This time, I'm going to tell it to match the case. It has to be an uppercase R and a lowercase d, which should leave my via Cardona alone. Replace all. Okay, only 4 replacements this time. That is a major difference between 11 and 4, which means that there were 7 replacements in the middle of words where R and D appeared, and not the RD that's at the end. Be very careful when using find and replace. Particularly here, we had 100 rows, we could tell something wasn't quite right. But when you're doing this on hundreds of thousands of rows, if it finds 50,000 replacements, do you know it's made them all correctly? So be a little bit careful with the data that you're playing with. So the same, I'm going to leave the match case on and change CT full stop into caught, replace all, nothing to match. Because I've put C and a capital T, and it should be a lowercase t, replace all, 7 replacements. Need to widen that slightly, and I can see caught there. And then we would continue with avenue, again keeping the match case, AVE full stop, and then street, ST, there'll be lots of those. ST replaced with street, replace all, 13 replacements. The find and replace dialog box is a great way of making mass changes. The caveats really are to make sure you highlight the column that you want the change to be made in, and then be careful about what you say you want to replace with what, and do you need it to match the case. As you've seen here, we tried RD without matching the case, and it ended up changing 7 data values wrongly. So you could end up with worse data than you want to have. So you're trying to tidy things up, and you're actually making it worse. Be a little bit careful, but it is a great tool. It saves you going through every single record and rewriting DR to DRIVE, the next DR to DRIVE, because we simply come into our find and replace dialog box, we've highlighted the correct column, we type in exactly what we want to replace, gone for match case again, so it has to be D uppercase, R lowercase, and then full stop, and we replace that with the word drive, replace all, and 8 replacements are made. Remember, that's 8 out of 100, so that's 8% of your data. So if you had 100,000 records, 1,000,000 records, that is a lot of replacements that are done in a jiffy, save you manually going through each one. So that's method number 1, the find and replace commands within Excel itself. We've seen one method of replacing text within your data. Another method is to actually use formulas. So rather than use the find and replace tools within Excel, we can use formulas to do what essentially is pretty much a similar thing. If, for example, in our email address here, we'd like to change the @ symbol into a different symbol completely, then we can use a formula called replace. If we insert a new column, and this new column is the one we're going to do our work in, then we can use the replace function equals replace, open brackets, which is the string we'd like to replace. Well, that's currently the value in the H column. I'm down in row 66, that's H66, comma. Start num is at which character within our string do we want to start replacing the text. So I've got to figure out where the @ symbol is. So Jesse 15 @ is 1, 2, 3, 4, 5, 6, 7, the 8th character, comma. And how many characters am I wanting to replace? Well, just 1, comma. And what do I want to replace it with? That's what is the new text. Inside speech marks, I put my new text values, which is actually a less than and a more than symbol, and then close speech marks and close brackets. Although I'm only replacing a single character, I can replace that single character with as many characters as I want. I'm going to go into this cell value here, Jesse15 at adventure-works.com, and replace character 8 with just one character from character 8. So instead of take me to character 8 and replace 2 characters, which would be the @ and the A, I'm replacing just the @ with a less than and more than symbol. And when I press return, hey presto, you see that it works. Jesse15, less than more than adventure-works.com. Now that's great, but I can't actually replicate that formula because the @ symbol appears in a different position every time. So I need a way of finding out what position the @ symbol is at. That's easy. I can use the find function. In the cell below, let's just try out the find function, which is equals find. Find text is what am I looking for? That needs to go in speech marks as well, comma, within what text? Let's try the cell next to us. That's H67. And then there's an optional parameter there of start num. So that's the character within the string you would like to start at. If I leave it empty, which I'm going to do, then it will start at the first character. But you could ask it to start at the 5th, the 6th, the 10th, the 11th, wherever you want it to start at. And when I press return, I'll be given an integer value of 9, which tells me at what position within this string the @ symbol occurs. If I replicate that down just for a few lines, you can see the @ symbol is appearing in different locations. Position number 8, 7, 10, 11, 9. So now that I have the find function, I could actually use that, if I cut that from there, inside my replace function. Equals replace, open brackets. What's my old text? Well, it's H67, comma, what's my start point? Well, the start point is where the @ symbol is. So if I paste back the find function, that will tell me the character that the @ symbol is at, then comma, number of characters. Again, it's only 1. I'm replacing it with 2. So they go in speech marks and close brackets for the replace function and return. And you can see it then says Amanda 53. Now, when I replicate this downwards, because we're now using a function to locate the actual position of the @ symbol, each of these, even though there is a different length for each mailbox name, it finds the @ symbol as appropriate and replaces it with the less than and the more than symbol. The only problem with this formula is it has a little drawback if there is no @ symbol. So if I go on to the next one, for example, and let's just get rid of that @ symbol and replace it with a decimal place, and then try replicating this formula downwards, we get hash value. The reason I get hash value is because it cannot find, it's got nothing to do with the replace function, it's the find function that's falling over. It cannot find the @ symbol. So what I need to do is effectively encompass this in one of the possible error functions. So if error would be the easiest. If running this replace and find function together causes an error, then we'll just output a bit of text that says no @ close round brackets for the if error and return. And then we get our little error message of no @ because there is no @. We've had to use 3 functions in there. The replace function, which is actually doing the work of replacing the character with characters. The find function that is locating whereabouts in the string that symbol occurs, in this case the @ symbol. And then a third one of if error, just in case the @ symbol doesn't exist. I'm sort of covering that base by using if error on this particular function, and we'll actually like to see no @. That's my final function. So that's the one that ideally needs to go in the very first line up here, paste, and then I can replicate that down the whole column. Now it will actually stop at where I did the work. There, and then I need to replicate it to the bottom of the data. Bottom right hand corner, double click, and then all of my entries now have the new email address, which obviously isn't really an email address because it doesn't have the @ symbol. If this is the final result that I'm after, then we would copy the whole column of data, go back over the top of the email addresses and do a paste values special. So we've then replaced all of these with the new values. My functions in this right hand column are now saying there's no @ symbol because I've just replaced them. And we can get rid of that column because it's done its job. So that's method 2. The first one was that file and replace option. This time we've gone through using formulas and we've had to use 3. The replace function for making the actual replacement, the find function for finding the location within the string where the character is we want it to replace, and then an if error around that whole double function, just in case the symbol doesn't exist. And then we can put out an appropriate error message. When you're importing data from external databases, or even being sent the information in Excel, but it has originated from an external database, you sometimes find yourself with text that has extra spaces within it. Now, those extra spaces might be between words, they might be at the beginning or the end of words. If it were as simple as these are extra spaces, then you wouldn't be needing this lesson. A lot of these extra spaces are actually non-printing characters that are not visible to Excel, hence the reason why they look like a space, and when you try to replace the spaces, they don't go. Before we look at the tools that we can use, it's worth exploring on the second tab here called char, 2 very useful functions that will help put things in context. First of those functions is called char, and that will give you the actual character represented by a number. Now, in the ASCII number character set, any number from 0 to 255 will produce a letter, a number, or some crazy shape. So 103, see here, I'm using the function here, char b2, is a lowercase g. If I then went for 156, I find that that's a OE symbol. If I go for 67, I find that's an uppercase C. Now, this is a little bit of experimentation unless you happen to have an ASCII table sat next to you. Alternatively, we can use the code function, which we have here in A4, where the code function will tell you what the ASCII number is for a given letter or shape. So over here, where I've put a capital G, if I put a lowercase g, we find that the ASCII number is 103. And I know that because up here, I had 103 and it gave me a lowercase g. I can put any character I like in here. What about an uppercase P? Well, that's 80. Lowercase p, that's 112. So in the ASCII table, I can find out what character is represented by what number, or if I have the number, I can find what character that represents. Hopefully that's a little bit of background for you. In our data, for cleansing purposes, we then have three very useful functions. The first of those is called clean, and it's certainly worth running on any strings of text that look like they have some spaces within them. If I say equals clean, open brackets, pick on the cell, close brackets, return, and then replicate that down all four of these, and just widen. What the clean does, it removes all the ASCII non-printing characters with the numbers 0 to 31. So if any of those have been imported with your data, they have now been cleaned out. And you can see here that guy simple had a space at the beginning and a space at the end, still has a space at the beginning and at the end. Simple guy, and very simple guy. Very simple guy has lost this big space at the front there because of the clean function. That's the first step. Clean removes the non-printing characters located in the ASCII table between 0 and 31. Now, it hasn't taken away all the spaces, as we can see. That's the clean function. Let's put that at the top of the column. If we use the clean function in conjunction with another one, which is trim, so I do the clean and then I do the trim. Obviously, in the real case scenario, you would do one embedded inside the other. This is just to show what takes away what. So equals trim of the already cleansed data, and then replicate. We can then see that guy simple does get the leading space removed. Simple guy, again, there's probably a space at the end there. There is there. And the only way to find out if there is there is to do a copy and paste special. Let's copy that, paste special it down here, paste special for the values and have a look. Inside it still contains the space at the end, but having done the trim, we then copy that, paste special it down here for the values. We find the space at the end has gone. So trim has been very helpful for us on those two values, not unfortunately on the third one down, and then the trim here, well, effectively that was already cleaned up by the clean function. So we've had clean to remove all the non-printing characters that fall in the ASCII table between 0 and 31, and then trim to remove any leading and trailing spaces, which actually happens to be the ASCII character number 32. But it doesn't remove any spaces between words. It only removes any that occur before the text starts and after the text finishes. But that leaves us with a slight problem here on the third option. Simple guy still has a space at the front, even after running the clean function and after running the trim function. So what is happening to this one guy? I hear you shout. Well, what's happening is a different ASCII character has been used here. A non-printing space has been used, which is actually a different character to a space. A non-printing space is character 160, and it is quite common, particularly if the data has been stored in HTML at any point. So how do we get rid of the character 160? Well, we could use the substitute. And what we'll do with the substitute command is replace, if it's there, character 160, with character 32 that our trim can then get rid of. We'll do it for the whole set. Equals substitute, which is the text value we want to deal with. We'll go back to the source one here, A2. What is the old text? Well, the old text is char 160, comma, what is the new text? Char 32. And then we can close the brackets because we don't want the optional parameter of instance of the number. Close brackets, return. Now what we should find, if we replicate this down, is things don't actually look any different. These look the same as those because the non-printing space to Excel looks exactly the same. But what now will happen, if we now run our trim and our clean, let's run them together on our new result, then effectively our finished result should see us without any leading or trailing spaces whatsoever. What we then do is take our final entries there and do a paste special to get the values back, just as we've done before when we've used functions. And these then now become our final values. Ideally, in a real data set, we would have pasted those over the top of these entries and got rid of any of the working columns. You could do all of those working columns in one place. I've amalgamated trim and clean here, but I've made a separate column for the substitute. Ideally, you would put that in the same function. So everything would happen in the same cell, replicate that down the column, and then you have your new values that have taken away char 160, which is the non-breaking space, trim to take away any leading or trailing char 32s, which is a normal space, which we've already replaced the char 160 with, and then clean to remove any of the non-printing characters that fall into the character sets 0 to 31. Trust that that makes absolute sense. And for those of you that have been dealing with imported data with spaces, trailing spaces, end spaces that you haven't been able to get rid of just by doing find and replace, this is your method for getting rid of all those spaces. So the non-printing characters that effectively you can't see in Excel, but they look like spaces, can now be removed using the clean function. That annoying little non-breaking space needs the use of the substitute to swap it for a normal space, which you can then remove using the trim function. Quite often when dealing with imported data, you'll find that your numbers do not behave as numbers, because in fact they are being treated as text. For whatever reason, in the source data, when they come into Excel, they're not spotted as numbers and they end up being treated as text values. Now, if you need them to be treated as numeric values, which if you're likely to need to have to do mathematical formulas or any kind of sorting you will want to, then there has to be a way of converting these back into a number so that Excel can work with them. Sorting is an issue between numbers and being treated as text when your numbers have a different number of digits. For example, here, if we wanted to sort, it would sort by the first characters within here because they're treated as text rather than actual numeric value. Now, you will find that Excel will spot if a set of cells look like numeric values but are being treated as text and place you this little green marker to the top left of each cell. When you click into the cell, you get the information symbol and it says this number is stored as text. And we even have an option to convert to number. So I could just click that and it will convert to number. But if you've got 100,000 rows of these, you don't want to be doing that one at a time. If you can multiple select all of the cells that have the same problem, text stored as a number, so you highlight them all, then you'll find you'll get one pop-out symbol up here at the top, and you can convert to number, and all of them will be converted in one go. So that's quite a quick way of doing things. There are other methods. If we undo, and again, one traditional method that I have seen used and have used myself actually, is to just take the value of that cell, so equals that cell, and multiply it by 1. If Excel is able to multiply the cell by 1, then it realizes that it's a number and actually converts the result into a number value. If I return, you can see that Excel now thinks that's a number because it's left a line. That's the biggest giveaway. And I can then replicate and I have my set of numbers. So that was sort of the old-fashioned way. Or you could run a function, that function being value. So equals the value of that cell there, return and then replicate, and I get a set of numbers. Now, bear in mind that doing it this way or this way, your result is just the result of a formula. If you then want those numbers, you'll have to do the copy and paste special. So I want all of these as actual values. Then I select them all, copy, come across to where I want the result, and paste special using the paste values option, not the function. And then I just need to widen because some of them went into scientific. Now that I have my set of numbers as numbers, I can go ahead and use any of the Excel formatting that works. So I can go number, currency, accounting, go into number, go into specific, custom options. I'm totally in control of the number side of things now. That's converting what appears into Excel as text, but it's actually numbers, into numbers that Excel can then manipulate and format and calculate and sort correctly. Now there is a flip side. Now that they are numbers, we can carry out all of Excel's formatting, not a problem. The problem comes if you formatted a cell, quite prettily perhaps we went with currency format, and then I tried to take this data into another application, it will just appear as the raw numbers. So if I were to copy and paste this information into a non-Microsoft program, it wouldn't appear as $25,255,517. It would appear as the raw number there. If I want to take formatted numbers into another program, I need to effectively carry out that formatting, not using the formatting commands here, but using functions. And there are a number of functions. I'm going to put them at the top of columns here. Let's have a little gap. There is a function to format your numbers into a dollar style. So equals dollar, open brackets, take my raw number, which is there, and then an optional parameter of the number of decimals. I'm going to put a 0 in there because there's no sense. And then I can replicate and just widen, because all of my numbers are now actually text values, but they are formatted as dollars so that I can copy and paste them and use them in other applications. Now there are other clever functions that do this kind of formatting. There is a fixed function, so I can say equals fixed. Again, point it at the number cell, which is there, with two optional parameters. How many decimal places? I'm going to go with 0 again. And then, do you want commas at the 1,000 and the million mark? Well, actually I do. Let's go for true. And we haven't got any. No commas. It's a backwards question. So true means I don't want any commas. False means I do want some commas. And then replicate. And then I have the commas at the 1,000 and the million marks. So that's dollar and fixed. Two great formatting options for numeric cells so that you can then use that formatting outside of Excel. Now there is a third, which actually I use quite frequently, which is called text, equals text. And what this does is it can actually do what the dollar and the fixed does, but with more flexibility. And we take our numeric cell, comma, and then inside a set of speech marks, we can put the number formatting that we wish to see. And these number formatting styles come from the number format box. If you're not sure what you want, you can have a look in there and then replicate in here. I'm going to go with 0,000.00. And that gets me formatted with the comma mark and 2 decimal places. And then I can replicate that. So 3 clever formatting functions: dollar, fixed, and then text, which gives you really a massive amount of flexibility because you control the formatting here within the speech marks to tell it to format the number how you want it to be displayed. If you then copy and paste these new formatted numbers into a new location in another application, they will go with the formatting. If you just copy them from Excel using Excel's formatting, as we have here, then the only thing you take is the raw number. You can see here in the formula bar what you're going to take. You're going to take those actual digits. Whereas here, you're going to take the digits and the commas and the decimal places. Because if I say copy and paste values, we do like that command, don't we? We see the commas and the decimal places. So it's those values that then get pasted into the external application. We've seen how we can standardize numbers and control those numbers that have been brought in from a data import, but now we need to tackle dates and time, which really, for want of a single word to describe it, can only be the word nightmare. Before we look at the tools that we have to manipulate dates, we just need to understand how Excel deals with dates. Now, effectively, in Excel's world, dates are just numbers, and you can get behind the date and find the serial number that refers to that date or time very easily by simply stripping the format away. So if we take this dates data file, you can see in cell 1 we have 11/1900, and if I simply choose that cell and choose general, it strips away all the date formatting, and I'm left with the serial number of 1. The reason I have 11/1900 in that cell A1 and it's showing serial number 1 is because that is the first day in Excel's world on Windows. What you'll find on a Mac is that Excel's first date is actually January the 2nd, 1904. Both versions of Excel do deal slightly differently with dates, as in what's the starting point, and the starting point is a slightly different place. Now this isn't an issue until you start trying to link between workbooks that have been created with different date start point systems. Now you can change your workbook between the two systems. So at the moment we're in a Windows situation and the default is 1900. That's why when I remove the formatting from there, I get 1. If I remove the formatting from here, you see I get 1463. So if I put the formatting back on both those cells and then go into File, Options, Advanced, scroll right down the advanced options until I get to Calculating, and here's the option to move from one date system to another. It's not advisable on a workbook that already has an amass of data within it, but for our purposes it's good to demonstrate. So we put a tick in, OK. Now what you will notice is these two dates have changed. So I had dates in those two cells. Those dates then had serial numbers behind them. Now that I've changed the date system, those dates have actually changed. The serial numbers remain the same, but the dates have changed that get displayed. So you can see the potential here for problems when moving one workbook to another system and then changing its date system. So be a little bit careful, that's the main thing, particularly if you try to link to another workbook that has a different date system within it. As far as Excel is concerned, behind those two cells, there are two raw numbers. That is raw number 1, and the other one is 1463. Now, because we've changed date systems, the actual date changes to the 1904 date system, where January the 2nd, 1904 is date 1, and our 1463 happens to be January the 3rd, 1908. So let's go back and change it back round, so advanced, all the way down to Calculating, and remove that 1904 tick. OK, and my dates revert back to where they were. Now, it's not such a headache as it would quite seem, as long as you don't change the year system when you inherit a workbook or link to a workbook, then everything will be fine. The dates will be the same. If, however, you do need to change the date system because you want to work with an existing workbook, then you will need to make sure you either subtract 1462 from all your dates or add 1462 to all your dates to get them to be the same date as they were in the other system. What a nightmare. The other thing to be aware of when dealing with dates is the 2-digit year assumption. So if we come down to this little cell here, and I type a date in, what about 1225? And then I want to put a year in, but I don't put the century value. Let's put 16, return. Excel assumes 2016. If, however, we move forward in time, and I put 1225, 30, and return, Excel then assumes 1930 rather than 2030. The decision it makes is actually driven by the operating system, not by Excel, and currently the choice is at that 30 mark, which is why I went for 30. So at 30 up to 99, the assumption is 1900. From 00 to 29, the assumption is 2000. Now, obviously, if you're not too aware of the assumption being made, then the safest option is always to type 4-digit years. So that's a good habit to get into. Or you can go into the Windows regional settings and change that dividing mark. So it doesn't have to be 30. You could perhaps move it forward to 40, perhaps move it forward to 50. You're completely in control. Obviously, when you're in Excel and working away, you need to know it's making the right decision. To make sure it's making the right decision, always type a 4-digit year. So then I could actually get in to type 1225, 2030, and it will take the 2030. It's not a problem. It's just when I put 30 in, the assumption was 19. A little minor headache to be aware of. Now, when dealing with time, as we have two time options here, time is just a proportion of a day. So in decimal terms, 12 hours there is half a day, so that would be 0.5. 1800 hours is 3/4 of a day, so that would be 0.75. We can prove that that's the case by again removing the formatting by going to General, and you see a 0.5 and 0.75. I then put the formatting back on to give me my time back. It then goes haywire because it wasn't a default format, so let's do undo and undo as the quickest option of returning my date values. Now we can actually convert decimal values to actual date values rather than use the formatting, because formatting is just formatting. If I tried to copy and paste this elsewhere, it might not work. So if I turn that back into decimal values and I physically want to see time rather than change the formatting, then I can use the text function, which we have used previously, if you do recall. So it's text of that cell there, comma, and then in speech marks, how do I want to see the 0.5? Well, I want to see it in hours and minutes. Close brackets, return, and I get my 12:00. I want to do the same to 0.75. Well, it's in the same relative position, so I can just copy and paste the function, and I get my 1800s. So the text function there extremely useful for formatting the decimal value to display the time value. Now, vice versa, it's a little more tricky. If I want, for example, to change 11 hours 30 minutes into 11.5 hours, then I need to do a little bit of cleverness here. Equals, open brackets, cell with the date in, take away integer value of the cell with the date in, close round brackets for my integer function, close round brackets for BODMAS. So it does this takeaway first before times in by 24, which is obviously the number of hours in a day, and then I get 11.5. So the same will happen with 745. Let's replicate that formula. It becomes 7.75 in decimal terms. So we can do the vice versa here. We can format decimals into time portions, and we can format time portions into decimal portions. Quite useful if you're wanting to manipulate the data that you're importing. And then the last clever bit here I'd like to explore, when it comes to data you've imported, if we go to the Import tab, sometimes dates will come in from external systems like this. There's no divider between the month, the day, and the year. So it's not immediately obvious to Excel what to do with the date, the month, and the year. We could do some clever string manipulation. Say, okay, let's take the first two characters, and let's take the third and the fourth character, and let's take the fifth and the sixth character. They're my date parts, so my month, my day, and my year. Let's stick them together and convert them into a date. Now that's all possible, and we could do that, or we can do the quick method, which is to highlight the values, go to data. You will like this. Text to columns. We're going with delimited, although there's no delimiter because the numbers are just next to each other. Next, make sure there's no delimiters chosen. Next, and here's the clever bit, the column data format. If I choose date, make sure I choose it in the right format. So I've got MDY there, which is month, day, year. That's good. It could be any of these. You need to watch how the date is and determine how it's coming in. Now it's coming in as month, day, year. That's the only change I make. So there's nothing in the delimited option. I make the change here to date, MDY, and then I finish. And hey presto, I might need to widen because of the hashes. Those numbers have all been converted into date values that I can now manipulate in Excel. So that's a clever little way of importing what effectively looks like a set of raw numbers and not having to do some text string manipulation to then build my date up from 3 little bits into a single date. I've simply used the import text to columns option to convert what it sees before it into month, day, year. And then it can display that formatted as month, day, year. So this has been a few tools for helping to deal with date and time on imported data. Sometimes when you have sets of data, you may wish to merge a number of the data columns, or conversely, you may wish to split one of the data columns into more than one column. Here in our working file contacts extract D, we can do both of those things. First is to look at merging 2 columns to get one new column. So the first stage is to add a new column. Let's go up here, insert a new column. That new column's title is going to be full name, and then the full name is going to consist of the first name and the surname. So in the full name column under B2, I could use 2 methods really. I could use the concatenate function. So that's equals concatenate, open brackets, that cell, comma, a space. I need to put space in speech marks, comma, that cell. You can see here in the function it's going to take whatever the contents of D2 are, which is Amanda, then a space, and then whatever the contents of F2 are, which is Cook. Close the round brackets, return, and I get Amanda Cook. And then I can replicate that function to get everybody's name. May need to slightly widen the column to see everybody's name. Some people have got quite long names. So that's one method. If I insert, there is another. We'll call that full name 2. Now, essentially, it is just concatenating, but without the long named function. We just say equals that cell there, the ampersand symbol, speech marks, space, speech marks, ampersand. So that's my sticking the space between, and then Cook. Return, and I get exactly the same result. Obviously a much shorter function. That's E2 ampersand speech marks around the space so that I physically get the space between the 2 bits of text, which happen to be the first name and the surname, ampersand G2. Once I have my function working, if I then want that to be normal data, I would do as we've done previously, copy, and then paste back on top of the functions the values. So these are now actual text values. So I can do whatever I want to them, further work, remove these columns because I'm now no longer referencing them. I actually have the text of the full name. So that's sticking together, and you can stick together as many bits of data as you require to build whatever you're trying to build. It may be that you want to stick together 3 parts of a date to create a date. That's all possible. Ampersand symbol for sticking together the cell contents you wish, or the concatenate function as we used here, which simply has a comma between each of the actual text, in the case of the speech marks for the space, or the cells that you want to stick together. Now, splitting apart isn't much more difficult than that. Let's go into context 2, for example, where we see we have the full name. But it may be in this set of data, what I'd actually like is the first name and the surname separated. So a little bit like the sticking together, with the splitting apart, I need to make somewhere for the splitting aparts to go. So I need to insert 2 columns. Now, splitting apart actually has a few ways of being achieved. The first of those is to highlight everything that I've got here, so all of my full names, then go to Data, Text to Columns. Is my data fixed width or delimited? Well, it's not fixed width. Everybody's name is a different length, so it's delimited. Next, how is it delimited? It's delimited by a space. So there is a space between the first name and the surname. And you can see in the preview, it splits my data into 2 columns. There is then the option to go next and actually look at not importing any columns or formatting any dates. But if that's not required, then you can actually just go straight for the finish button here. Now, unfortunately, what I didn't do is tell it where to go, and it's going to appear back on top of itself, which is not what I want. I'm going to click cancel. I want it to go here and here. So we go back to text to columns. It's still delimited. It has a space. And in the next box, you can see there the destination B2. That's not where I want it to go. I want it to start in C2 so that I retain the full names. First name and the last name will then be split into these 2 cells. So all I need to give it is the starting point, C2. Back in and then finish. There's already data here. Okay, let's try out and see what happens. Okay, and we'll look down column. Information. It's always worth checking to make sure you haven't actually overwritten everything. That seems okay. What I would tend to personally do when you're splitting things like this is actually not insert 2 blank columns, but insert 4 blank columns. Just in case, because I'm delimiting by space, what happens if there was an extra space in here, or somebody had a middle name or a double surname? Then that would actually overwrite the phone number or the email address. So in that case, I've broken my data. So put more blank columns than you think you're going to need. If you don't need them in the end, you can delete them. It's not a problem. But if you have them, at least you won't lose any of your existing data. So that was text to columns, and that's done the job. It's split my name into first name and surname. I'm quite happy with that. Let's undo. There are other methods. We could use functions. In here, if I want the first name, I could use the left function, which you may have seen already. Equals left, open brackets. I want to take some of the left characters off of Amanda Cook. But what it needs to know is how many characters do I need to take? Well, I need it to take as many characters as there are until it gets to the first space. So I can use the find function, which we have seen previously, to find a space. I need to put speech marks, space, speech marks, comma. Where am I looking for this space? Well, I'm looking in B2 as well. Close brackets for the find, close brackets for the left. So the find will return the character position for the space in Amanda Cook, and that's where I'm telling the left function to end. When I press return, I get Amanda, and if I replicate, I get everybody's first name. Now the first name is easier than the last name. Last name, you can use the mid function, because I don't want to start from the beginning, I want to start part way through. So mid of which cell? Well, it's that cell there, comma. How do I know where to start in the function now? How far through? Well, that's finding the space again. Find space within B2. Then I need to add 1 on, plus 1. Otherwise, it will start with the space because it finds the space, but I don't want the space. I want the next character after the space. So that's plus 1, comma. But then how many characters does it know to get? How many more characters are there in that string? Well, firstly, I could figure out the length. So len of B2. And then I could take away from the length the position that I'm starting from, which is find space within B2 plus 1. Close brackets for the mid, return, and I get Cook. And if I replicate, I get everybody's surname. So we could use text to columns, or we could use text manipulation functions where we've used left here and find, and for the surname we've used mid and find and len. So that was a little bit more winded than text to columns, but it still does the job if the data matches what you're looking for. Let's undo and demonstrate the last method, which has got to be the best and the fastest really. We have our 2 blank columns ready to go. We have Amanda Cook that we want to split into 2. So what we do is we put Amanda in there and Cook into there. So we've done the split ourselves. We've looked, we've said, oh, the split is Amanda and Cook. Having done the split for the first one, we can then highlight Amanda and Cook, go to the data ribbon, and I want to choose flash fill. But you can see how it's grayed out because flash fill only works on 1 column at a time. Okay, let's go to Amanda and try flash fill. And without any text to columns or any clever functions, Excel has spotted that I want the first name from all of that lot, and it's done it. What about Cook? Can it manage that? I go to Cook, flash fill, and it again has spotted that I've taken the surname off of all of those values, and it's placed them in for me. So this is the actual surname and the actual first name. There's no functions involved, so I don't have to do copy and paste special to get the values out of the function. It's just spotted the pattern I was trying to achieve and made the split for me. That flash fill is absolutely fantastic. Just watch in action up here. If I insert another column here, what I'm trying to do here is split out the Amanda 3 and the Lauren 24, so the prefix on the email address. So if I do the first one, Amanda 3, and then go to flash fill, it realizes what I've tried to do and goes and pulls out everything before the @ symbol all the way down. Ideally, we should really have gone with flash fill first, and I'm sure in real life situation you will. Now you know and can see how powerful it is. The backup is then your find and left and mid and len functions that will help you split strings up, or text to columns, where if there's a delimiting value, it can quite easily split a large column of data into multiple columns. We've seen a number of tools and ways and tips for dealing with cleansing your data, having imported it into Excel. Once you've got things tidied up, you might just need to move things around a little. They might not be in the location that you want them to be in. Now we can move columns in Excel pretty easily. We can select the column. You see you get this little green border around it. If you move your mouse near that, you'll get a 4-headed arrow, and then we can click and drag. And wherever we drop that column, which was the last name, it will want to replace the column that you're dropping it on. That's not what I was trying to achieve. So cancel. What I would like to do is actually move this last name to be before the first name, not on top and therefore replace it, but sort of drop between the title and the first name and budge everything else along. Well, the steps are pretty similar. We select the column, we move our cursor to the edge, so we get the 4-headed arrow. At that point, hold down the Shift key and then click and hold. And what you'll find is it now wants to move that column and not drop it on top of the column you get to, but place it between. You can see the big vertical green line. That's where it's going to put it, as long as I let go of the mouse first, not the Shift key. Mouse has gone. The last name column is now effectively inserted in front of the first name column. So that's a quick way of moving columns about to the right location where you would like them using the mouse. We can use the keyboard as well. It may be that I wish to move the email address up to be the left of the phone. Not a problem. Move around inside your sheet. Make sure the cursor ends up in the column you would like to move. Control spacebar to highlight that column. Control X to cut that column. Then move the cursor into the column that you would like this column to go in front of. I want the email address to go to the left of the phone column. I go into the phone column. I Control and spacebar to highlight the phone column, and then Control plus to effectively insert a new column, but it will then paste in automatically the column that I've cut and is sat on the clipboard. So plus, column is inserted, and the contents that I had on the clipboard, which was the email address, are then placed in that column. Effectively, I've moved the column across. Exactly the same result as if I'd grabbed the selection area, held down the Shift key, and moved it to where I want it to go. Just a different method of effectively doing the same thing. Now you can do exactly the same as that with rows. However, ordinarily you would sort the data in your rows how you would want to see it. But if there is perhaps a couple of rows you want to move, we can do the same. We can highlight the rows, make sure your cursor is on the border with the 4-headed arrow, hold down the Shift key, and then drag those rows and let go of the mouse first so that the rows move to where you want them to go, rather than replacing the cells that you drop them on top of. Now that's okay, not too difficult. Moving rows within the rows and columns within the columns. What about if you want to turn a row into a column or a column into a row? A little bit more difficult, but there is the option. Let's go to this transpose sheet in your working file. Here we're going to transpose these regions here that are stored vertically to store them horizontally there. And we'll do exactly the same with the staff names, which are currently horizontally, and we'll go store them vertically here. Now there are two methods of doing this. One is a little bit more tricky than the other, and one is more permanent than the other. The first option is to use the transpose function. So if I want these 6 values to go across here, I have to highlight the 6 cells where I would like them to go. I then, with the cells highlighted, start typing equals transpose. That's the function I require. Open my round brackets. It requires an array, so a list. This is my list. Close round brackets. Now for this to work, I cannot just simply press return, because that will just put the first value in the first cell. So that will put north into C1. What I need to do is make this function work as an array function. So it takes a list in and it pushes a list out into these 6 cells. So to turn this function to array function, instead of pressing enter, I hold down Control and Shift and then press enter. And as if by magic, the values appear. They are in the same order. They've just been transposed from here to here. Now this transpose function works from vertical to horizontal, but also works from horizontal to vertical. I've got 7 names here. So I highlight the 7 cells I would like them to go into, 4, 5, 6, 7. And then don't click into any cell, start typing the function, which is equals transpose, open brackets. This is my list, control brackets, and then Control Shift Enter to make it act as an array function. And my little members of staff all then appear here. So you can see when you look in any of these, the function looks exactly the same as I typed it in the first of those cells, but it has those squiggly parentheses at the beginning and the end to indicate it's an array function. But having said that, it is still a function. So if I were to get rid of Sally and replace her with Mike, Mike then appears in the transpose list. So the 2 sets of data are still linked to each other, which is fine for the purposes of this. But for a real purpose, you effectively want to turn that horizontal list into a vertical list or vice versa. And then for that to be the values, not to have to retain the horizontal list as we have here, so that this still works. In order to do that, we can take those cells, copy them, and do paste special. I'm just going to do it next door rather than on top of the values. And now these are actual values. These are not a function. So I can get rid of the horizontal line and this set of data will not be affected. Now, if the long-term aim is not to have the function, but just to move the data around, then we can do exactly the same thing using a little bit of paste special. If I take my 7 people there and copy them, and then let's go across here. I don't even need to highlight the correct number of cells, which you do have to do with the transpose function. We then go to paste, paste special, and here's a clever little option called transpose, and that will take my horizontal list and paste it as a vertical list. And there we go. No need for me to tell it how many cells it needs. It figures it out from how many cells it's got copied. And that will work both from horizontal to the vertical and from the vertical to the horizontal. So if I highlight my regions, copy, well, let's go here into my paste and paste special, transpose, OK. Those items are then transposed across. No formula required. These are the actual values. Effectively, what you've done is copied and pasted from each cell, top left, C1, A1 to there, A2 to there, A3 to there, A4 to there. And imagine if the list was 1,000 characters. The paste special transpose would still work for you. So it's a great way of turning data around. If it's come in horizontally and you need it vertically so it sits in your data, fine. We can do paste special transpose to turn it around. And vice versa. If it comes in vertically but you need it to be headings of your columns perhaps, then we can do copy, paste special transpose to bring it along as horizontal headings. So we can move columns to where we want them, we can move rows to where we want them, and even transpose the data if it's vertical and we need it horizontally, or if it's horizontal and we need it vertically. When dealing with imported data, it can be quite useful to be able to compare what you have in one set of data to what you might have in another set of data. Here in our contacts extract F, we have a number of sheets. The first 2 are contacts and contacts 2. And what we'd like to know is if any of the contacts in contacts does not exist in contacts 2 and vice versa. Does anybody in contacts 2 not exist in contacts? Because they're meant to be the same set of data, but we're trying to find out if they're not. Now, the easiest way to do this is to use the unique ID, customer ID, and run a VLOOKUP. So we would look up each of the customer IDs from contacts through the list in contacts 2 and see if they exist there. So in order to do that, there's two little things I would do to start with. That is to name the ranges. So I'd highlight the first set of IDs and give that a sensible name, contact A, and then go to contacts 2 and do the same thing. Highlight just the customer IDs and call that contacts B. No imagination. Don't forget that range names cannot have spaces within them. Now that they're named, it just makes the formulas a little easier to work with. We need a blank column for me to do the lookup within. Call this check 2. What I want to check is equals VLOOKUP. I'm checking if that ID there, comma, exists on the second sheet. So that's contacts B. My lookup column is the first column. I've only got one column in the table, and it must be an exact match. False. Return, and it does exist. If I then replicate that formula, it will check each of them, and the ones that do not exist are NA. Just to make my sheet a little easier to read, I'm going to edit the formula and use if is NA. So if the VLOOKUP itself turns an NA, i.e. the ID does not exist in the other sheet, then what do I want to happen? Put a little message out that says not exist, else. If it does exist, then I don't want anything to happen. It's there, so that's fine. So we'll just put a set of speech marks with nothing in them, close the round bracket for the if, return, and the first one is nothing. Perhaps need a little symbol in there, otherwise it looks like it's an empty cell. Let's replicate that, and where it doesn't exist in the other set of data, I get not exist, and where it does exist, I just get that little hyphen. Then we do exactly the same thing in contacts 2. We insert another column, and we do a little check. This time, I'm checking that ID, comma, exists in contact A. Again, first column, and it's got to be an exact match. So when I replicate, the numbers match up, except when it doesn't exist in the other sheet, I'll get hash NA, and there are a couple of them. Again, what I would do is exactly the same as I did with the other. Put an if is NA in here so that I'm not seeing the number twice. I'm seeing whether it matches or whether it doesn't match. That's one use of this VLOOKUP, just to check comparing two sets of data. Where you might have some linked information, for example here, sales, what I need to know in the sales is if the IDs here exist in my data. Because if they don't, then I'm going to have what effectively are orphan records, some sales for somebody who doesn't exist in the data. So I need to check this 11069 and all the other IDs against both of my lists of people. So I've already created the two little lookup tables, which effectively is the first column of each of those. What I need to do in here is now check both of those. So equals VLOOKUP, the ID against the first one, contact A, and if it's there, it finds it. Then in the second cell there, I do the VLOOKUP for the other one. Really, all I want to know is if they're there or not. I don't want to do all these VLOOKUPs, see the result. I want to be a little bit cleverer with my formula. So equals if is NA of the first lookup. What I'm doing is I'm looking up my 11069 into contact A. If the result is NA, it means the person does not exist. So I need a set of speech marks with missing ID. Otherwise, I would go ahead and look in the second set of data. If is NA VLOOKUP. So I'm looking at the same number, but I'm looking in the second set of information, contacts B. First column match, got to be exact. If is NA of that lookup, then it also doesn't exist because it isn't in the second list either. Missing ID. Otherwise, it's good. Okay. I should be asking this if it isn't found in the first one, not saying it's missing. Let's move the whole of that if portion, cut, to be after that one. And then second set of close brackets there to close the outer if. The first if asks, is A2 in that list? If it's not, so is an A, then we see if it's in the second list. If it's not, then it's missing. Otherwise, we're all okay. And we've got an extra missing, then we don't need it. That's my if, question, true, false. That's my if, question, true, What I haven't got is my false portion, which is going to be just OK, because it exists. So it exists in contacts A, it gets an OK. It exists in contacts B, it gets an OK. If it doesn't exist in contact A, we ask again. But contacts B, if it doesn't exist in contacts B either, then we get missing ID. That sounds better logic. That one's OK. Let's replicate this down the list to find them all. And we have a missing ID. 30,500 is missing. Now I know it is because the IDs actually don't go that high. Are there any others? Nope, that's just the one. So having added this check column, we could again give that a label of check, and we can even sort by that check column. So we perhaps would sort A to Z. That way all the missings, if there are more than one, would appear at the top of the list to save me scrolling down. I know there's not many records in here, but there could be thousands, hundreds of thousands. So that's using the VLOOKUP along with an is an A and an if, just to check both between two sets of data to see if they match, and then to check when you have some more effectively child data to see if there's any orphan records, because this record now, $32, has no match with the contact data we've been given. So we actually have a lost record here that we would need to match up to perhaps somebody else. Welcome to Excel tables. Now, a table in Excel is just a way of grouping a set of data together, and along with that grouping, you get an extra set of tools. So you can turn any set of data, any range of information into a table, and having done that, we then inherit a whole new pack of tools that enable us to work with that table to help speed us up. If we take our contacts extract A, and we think this is a good little candidate to be a table in Excel, there are two ways really of turning that data into a table. You simply place your cursor anywhere within it, go to Insert on the ribbons, and then Table. Now, if Excel has spotted where your data is stored, it will pick up the whole range of the table. And we can see there, where is the data for your table? A1 to AE101, which is correct. My table has headers. Yes, it does. That's method number one, and I would click OK, and that now becomes a table. Now, you can instantly spot it's a table for two reasons. One is each of your columns get little drop-down arrows on the top. Two, when you're in the table, you get your set of table tools. So there's a whole separate ribbon here with a whole lot of options. And if you click outside the table, just to prove it's the table causing that, you'll find that that set of options then disappears. That's how you can spot that you're in a table. Now, if I do undo on that creation, there is a second method, and that is to again click into the data anywhere you like, and you can do Control-T on the keyboard. T for table, nice logical shortcut. And you'll find that that also managed to spot where your data is stored, A1 to A101. Notice it's absolutely saved the table reference with the dollars. My table has headers. Just before I click OK, if it happens to have missed a column, which it can do if you've got a totally blank column before some more data, not a problem. You can click the Browse button and go and then highlight the actual range that you want to become a table. Then click OK. I'm now in a table. I've got a whole set of table tools up here that we're going to explore. I've got automatic drop-down arrows on the top of each of my column headers. And what you'll also find when you scroll up and down is that the top row has already been stuck as well. It's effectively frozen the pane of the header. Now, it might not appear to be immediately super clever, but as we progress through this particular chapter, I'm sure that you too will fall in love with Excel tables. Just before we move on to the first thing, which is formatting, just want to demonstrate a little idea here. Now, your table, when you create them, they're given names in Excel, and the first table you create will be called Table 1, the second Table 2, the next Table 3, etc. From within your table, on the Table Tools ribbon, you can see the table name up here. So this one's currently Table 3. Now, I don't need to stick with that. I can call my table whatever I want. I'm going to delete Table 3. I'm going to call my table Contacts. So I then know what the table contains. Having given my table a sensible name, you could still work with the default name, I can now reference columns within this table for use in other formulas perhaps. If I create a new sheet and I wanted to, let's say for example, count how many customers were here, then in here I can say equals count, open brackets. I can reference the table by putting the table name, and you can see it appears in the drop list because Excel knows I have a table called contacts. But I don't want to count the whole table. I want to count a particular column. So I use square brackets. Just opening the square bracket then gives me a list of all the columns in my table. I want the customer ID. I close the square brackets, I close the round brackets, and when I press return, it will count how many people exist in the contacts table. And it says there are 100, which, if I remember rightly, is the correct number. There we are, it goes to 101, take off that row for the headers, and it is 100. I can do that with any functions. If, for example, I wanted to add up the total purchase YTD, here, say equals sum, open brackets, the name of the table, which it will find as soon as you start typing it, square brackets. I don't even need to know what that column's spelt like, I just need to find it in the list, total purchase YTD, close square brackets, close round brackets, return, and the total purchase YTD is 379,906.7. So that's just a nice little insight and a plus for having tables in Excel. So you create the table from a set of data. That doesn't have to be a large set of data or a small set of data. Any set of data will do. Control T is the keyboard shortcut, or insert and table. That then by default makes your top row, if it is headers, fixed and gives you the little drop down arrows which we've already seen previously as filtering options and sorting options, so we've got those to explore. You then would possibly give the table a sensible name more than table X, where X is a number from 1 to however many tables you've created, which you can then use inside formulas. So I can reference the table and the columns within that table in any other formula in any other sheet, and therefore carry out some mathematical functions on the data contained in my table. So let's get on and look at exploring our tables in a little more depth. Let's use the contacts extract T, where T stands for table. In this working file, we've already turned our contacts data into a table. What we now want to look at is two parts of the Table Tools ribbon, which is the table style options and the table styles themselves. This will allow you to quickly format your table much faster than you could format if they were just a range of normal cells. Now in the drop list, we have a number of styles to choose from. And you can see that as you move your mouse through the styles, they are applied to your data. The first step here in the style options is to choose the color scheme that suits you. I quite like that red and then light red. Once I've chosen the style, I then choose which parts of the style I would like to retain. Now at the moment, we only have the header row with a tick in, so that means my header row is slightly different than the other rows. If I go with banded rows, and all this takes is a tick, then I have alternating background colors on my cells in the whole table. Now to do that manually on a range of sheets does take a little time, but here you have 2 clicks and it's done. It may be that you want banded columns, so tick in the box and you have alternate background colored columns. It doesn't quite work as well if you have both banded rows and banded columns on, but certainly one or the other could work, depending on the effect you're trying to achieve. Banded rows are certainly quite popular, because it makes it easy to follow across the row all the data without slipping into the wrong row. It may be that you wish to have the first column different, and you can see the ID then gets highlighted completely differently, or the last column different. Maybe it's a totaling kind of column. You can see the last column is different. The total row we'll visit shortly. This middle section controls what you would like from the style section. The style section effectively gives you the color scheme. So if you're not keen on the red scheme, we could go for a green one. But you see it retains the same options, banded rows, first column, header row, maybe a purpley option, maybe purple two-tone, maybe one of the darker options. Probably a little bit too dark. Purple's not too bad. This is applying style to the whole table. You're not having to think about formatting, visiting the format cells, the background color, the font color, the alternating background color, which we can achieve. Well, we have some mixed up styles down here. Let's go back with a fairly relaxing purple style. Now we've seen already that each of the headers already get the filter button when you have a table. We can turn that off as well if you're not interested by just removing this tick from the table style options. So then it just looks like a set of formatted data. Bring it back and it remains. Banded rows and they get removed, first column, and that gets removed. So you're completely in charge. Color schemes are in here, and then the choices of what you take from that color scheme are in the table style options. Now, should you not wish to have any of the settings you've chosen, there is a clear option in here, which will take you back to the normal black text on a white background that you would expect from an Excel worksheet. Continuing with our table theme, we're going to make use of the contacts extract T-C, which is our table of contacts data, but in color. And I've kept the banding in place, so we have two-tone purple. So I have a lightish purple and then a lilac purple, and then a very dark purple with white text for the header. Now our next stage is to look at how we could add more columns and rows to our existing table. The addition of rows is very simple. Start anywhere in the table, go to the end, and then go to the end on the right, and we effectively get to the very last cell, and we could get there like this with Control End, or we can tab along, and all you need to do from the very last cell is tab, and a new row is added to your table, and you simply then enter that new person in. I would tab across, adding in the relevant information that I might have or not have, and any information obviously then is calculated. Those calculated columns are just carried through. So if I were to enter somebody's date of birth here, August 2nd, 1976, they are male. As soon as we get towards the calculated column at the end, you'll see it's already calculated. It says that this new person is 39. If I then want to add another record, I simply tab at the last cell, and we're into a new row, and we start inputting. Adding new rows to our table at the end of the table is very simple indeed. Down to the bottom right-hand cell, tab, and off we go. That makes the data entry very, very simple. Now, if we wanted to insert some rows partway through the table, that's still not an issue. Come higher up, let's say, for example, here. On the home ribbon, if we go along to the insert option, you'll see there is an insert table rows above option. And this will insert as many rows as we have highlighted. Well, we're currently in one cell, so if I click insert rows above, it will simply insert one row above and move the rest of the data down. Notice how it retains the banded rows. I've inserted one above, that then becomes the darker purple and the light purple, and everything moves down and gets alternated again. And then I could input a new person here, give them a date of birth, September the 9th, 1981. When we get to the end, we find it's calculated their age as 34. So we can insert rows at the end very simply, or partway through. We can also remove rows at our leisure. It's just the same as a range in that respect. Highlight the rows of information that you would like to get rid of. In this case, I'm just highlighting the row I've just added. Go to delete, delete sheet rows, and you can see it's gone, and the banding is recalculated all the way down, so it's still alternate, light dark, light dark, light dark. Very simple indeed. Inserting a new column, click your cursor where you would like the new column to the left of, so let's go into this suffix column. I don't need to be at the top, I don't need to highlight the column. On the home ribbon, insert, and we see there's an option for insert table columns to the left. One click, and I get a new column to the left of suffix called column 1, which I can then obviously give a much more sensible name. We'll call it award. And then I have a new column of information for all my contacts that I can then write an award in. The only slight drawback really to using tables is if the data isn't as wide as the title and the filter, you do need to widen the column slightly so you can see the whole field name, like email address there, for example. Just needs slightly widening, just so that the filter icon isn't obstructing the column heading. Just as we got rid of the row, we can get rid of the column. We highlight the column we'd like to get rid of, delete and sheet columns, and it's gone. And if I had banded columns, the banded columns would sort themselves out. Now we've seen we can extend the table downwards by simply adding more rows by tabbing out of the bottom right hand corner. We can add further columns to the right, should we wish to, by simply going to the next blank column, typing in a column heading, such as passport number, and then either enter or tab, whatever it is that you usually need to end your entry in that cell, and you'll see that the table is automatically extended to the right to include your new column. I just need to widen it slightly, but it's there. As long as you don't go here, leaving a gap, you actually are the next blank column, then Excel will make the assumption you want to add the new column in. It may be that I would like to add in spouse, again return. Now, if you're not wanting to add this column into your table, that's okay. You've got a little get out of jail drop down here where you can undo table auto expansion, and you can even turn off the automatic expanding of tables. So when you add another column in future, it never expands. Well, I certainly don't want to turn off that option, stop automatically expanding, because I use it. But for this case, I don't actually want spouse to be within my data. I undo the table auto expansion, and spouse remains a column by itself held outside of the table. So it's not affected by any of the formatting that I might apply, any of the sorting that I might apply. any of the actions at all that I carry out to my table. So it is a bit of a little dangerous column sat there, but it means it's not associated with the data in the table. We can add columns and remove columns. We can add columns to the end very easily. We can decide whether that column at the end is part of the table data or not. We can add rows. Bottom right-hand corner tab adds a new row automatically into the table. We can use our table effectively as a little mini storage location, a little mini database in effect. Because we get the little drop-down filter arrows by default in a table, it makes life a lot easier when you then come to sort your data or filter your data. If we wanted to sort by any one of the given columns, perhaps by last name, we would click in the little drop-down arrow and choose Sort A to Z, and my data would then get sorted in alphabetical order of surname. Obviously, the matching rows would stay with it. So the correct first name would stay with the last name, correct middle name would stay with the last name, correct email address would stay with the last name, etc. That's effectively a given. I don't need to highlight the table in order to do that. Once I've then sorted by the last name, I then get this little up arrow there. You can just see that to say it's sorted alphabetically by last name. Perhaps I'd like to go sort Z to A, and you see the arrow changes direction. I could then perhaps choose any one of the other columns, and then that becomes the primary sort column. Now obviously, using the little drop arrows to carry out your sort means that you can only sort by one column at a time. So if I went by city, they're then in city order but not in email order. If I need to do effectively a secondary and a tertiary sort, perhaps I'd like them by province, and then within each province by city. Then I need to go back to the home ribbon, choose sort and filter, and choose custom sort. Now within the custom sort box, it knows I've sorted by city. It spots that little arrow there, but I want to change that to state province and then add a secondary sort, which will be by city. Now it will sort firstly by the province names. Where there is repetition in the province names, it will then sort by city. I say OK. I now see the provinces are in order, and then within the provinces, so I've got quite a lot of California there, for example, the cities are then in order, A to Z still. And I see that there's 2 Los Angeles and 2 Glendale. I could then perhaps think about adding a tertiary sort, so the 2 Glendale people are then in alphabetical order of surname, possibly. That's sort, custom sort. Let's add a tertiary sort by a last name. Notice it's gone in the wrong place, so I need to move that down so it does them in order. State, province, name. Any duplication, then sort those by city. Any duplication of the city, then sort those by last name. These 2 Glendale should now be in last name order. I can find out by going and have a look at the last name. Carter before Simmons. I still know the sort is in place because there's a little up arrow on that filter icon, and on that filter icon, and on that filter icon. So the sorting is made pretty simple and pretty quick. Choose your column, A to Z, Z to A. Multiple columns, you need to go back to the home ribbon and choose the custom sort option from the sort and filter drop-down. And then in there, you can add as many levels of sorting as your data would require. Filtering, again, that's on the little drop-down, so let's go for state, province, name. We have a number of options here. I'm only interested in one province, so I'll take the tick out of select all and place the tick back in California, and I'll then just see Californian people. So the color scheme remains. People's names don't retain the same color, so the person who's in a dark purple won't always be in a dark purple. It will depend on their location in the data. So Bellflower is dark purple here, but once everybody's there, they might be a light purple. The color's not retained, it's just an alternate background color. I know I'm filtered because the row numbers have gone blue, and then down the status bar it says 13 of 100 records found. And there's a little filter icon. So I know I'm filtering by the state province name. So that's a straightforward search. Simply select a single value or multiple. You could have multiple values and you'll see them all from your data. Select all, put everybody back in. Now, alternative to that, you may wish to find those people who've purchased perhaps more than 5,000 in a year. So we go to their drop down, come down to all the individual values. So I could just go through and remove ticks and add ticks to see those that I want, but that could take a while. I've only got 100 records here, but if I had 1,000 or 100,000, instead we go into number filters and say greater than. So the total purchase YTD is greater than 5,000. Okay, that filter is then applied, and I see I've got 44 people have spent more than 5,000. Having applied the filter, I could then add an additional sort, largest to smallest, So then I get them in order of actual spend, but still greater than 5,000. So we see there, somebody in Tasmania spent just over 5,000 to break into this filter. That's a numeric filter, number filters greater than. You can see the little ticks indicate the filter that you've applied, and then I need to click to see what the value is I've entered, just 5,000. Now you will find that the actual filter options vary from data type to data type. If I remove this filter, which I can do by clear filter, that's the quickest way, and then actually choose a country region name filter, you can see that now says text filters. Equals, does not equal, begins with, ends with, contains, does not contain. A lot shorter list of comparisons because it's a text column. If I go for a date column, this one here, we then have a set of date filters. And in here, we get before, after, between. Then we get some clever date-specific filters. Tomorrow, today, yesterday, next week, this week, last week, etc. for month, quarter, and year. Or all dates in a specific period, and you can choose one of the quarters or one of the months. Or we can even go for a custom filter, which then gives us a drop-down list of comparison options. And then on the right, we even have a little calendar date picker option, because we know that this column is all about dates, so it becomes easier if you can then pick dates for a range that you want to see. If I click close here and have a look at the date of birth, which is also a date field, it may be that I'd like to apply a custom filter where the date of birth is after. Now we need to go quite a way back here, so I'm actually going to click and type in rather than choose it, because there's a lot of clicking. I want to go all the way back to 1960. And is before 12/31/1969. Effectively, I'm looking for people who were born in the 60s. Okay, filter is then applied, and actually 22 of my 100 records were born in the 60s. So all of these dates should be in the 60s. I could then sort by oldest to newest, and then I get them effectively in age order. You can see there's a lot of scope when it comes to filtering. A different set of comparisons for each data type. So for a date, for numbers, and for text, you get a slightly different set of comparisons. Once you've applied a filter, you can see which column has the filter on because of the little filter icon. And then you can visit the filter and see that it's a date filter, it's a custom filter. If I want to remove the filter, I simply say clear filter from birth date or the particular column that I'm in. Obviously, you can compound filters as well. Currently, I have everybody from the 60s. I go into marital status. I could then perhaps just choose M for married, and then I'll see everybody who is married and born in the 60s. So these two filters are compounding, and you will find that the more filters you add, the less and less records you get that match the state of those criteria that you've set. But that might be what you're trying to achieve, particularly with hundreds of thousands of records. You would want to filter things down to the actual result. So we know we can sort our records by any of the columns or any of the multiple columns if we go to custom sort, and we can filter the data down based on any of the columns' data values to restrict how many records we're actually looking at one stage. Adding column totals to your data when using an Excel table is probably child's play. And a bit more than that, the formulas that you get to add up or any other calculation you want to carry out on your column are just a little bit cleverer than the norm, as we're about to see. So let's use the contacts extract TC again. That way we retain our nice little purple color scheme. If we look at the bottom of the table, currently the data just ends at Destiny Alexander. What would be quite useful is if we could have a totals row along the bottom of here that did things like count the number of people, added up the total purchase YTD, total number of children at home, total number of cars owned, and worked out the average age. That would be really quite nice. Well, there are two steps. First step is firstly to ask the table if we could have a total row, please. And to do that, we just simply click into the table. On the Table Tools Design ribbon, we choose Total Row. One tick, and that gets us a total row along the bottom. That in itself does nothing. It just gives us a pretty row along the bottom. It has actually dropped in and made an assumption of one formula, but it's made the wrong assumption because it's actually added up all the ages. And that's not what we wanted. So we can go along and visit each of the columns one in turn, and you'll notice that as you go into one of the cells in the total row, it has a drop-down arrow, and that allows you to choose the function that you would like to be carried out on that particular column. So let's go along to a column that I would like a function to be carried out on, and the total purchase YTD would be a good candidate. So in the drop-down, I would like it to sum that column, and then it gives me a grand total of the total purchase YTD. Now you can see the formula that's been used, it's here. It's actually making use of the subtotal formula rather than the sum function. The reason for that is if we were to then hide or filter out some of the rows, the sum function would still return 379,906.68, whereas the subtotal function will only sum up the cells that are visible. And just to prove that that works, let's go underneath this and add a sum function that is going to add up all of these cells. At the moment, that's exactly the same total. It's the same number, obviously it's not the same format. We could just add the dollars on so it looks pretty similar. And then if I go into here and perhaps filter out just so we see married people, then my sum still says 379,906.68 cents because it's still summing the range, whether they're visible or not. The subtotal function, which is the one added by default by the table, I haven't told it to use a subtotal function, doesn't add in the hidden rows, so effectively those that have been filtered out. So that total is now the total for married people with our data, total purchase YTD. There's a much better function to make use of. Although we've chosen sum in the drop list, it's actually using the subtotal function to sum those cells so that it doesn't add in the hidden rows. So if we then go along to the other columns we wanted to add a calculation for, total children, I want to sum those. Number of children at home, I want to sum those. Again, it's using the subtotal, so we're only seeing number of children at home for married people. If I take this filter off, so we get everybody back, then those totals increase. So we have 52 children at home and 173 children altogether. And then the other column we wanted to add up was number of cars owned, sum 180. And then the final calculation was actually the average age, whereas Excel's table has decided we wanted to add the sum. We didn't want the sum, we wanted the average. And then the average age of our 100 is 54.18. Again, if we made a filter out, let's say, for example, we filtered out and only saw people who were born on a Sunday, then our average would only average the people that were left. So there's 13 people born on a Sunday, and their average is 52.69. The subtotal function that is being placed in your totals row is a clever function because it doesn't include any hidden rows, whereas average, sum, max, and min do. Also spot that the function uses the name of the column. We have age there rather than the cell references. Same with this one, number of children at home. Same with this one, total children. So it uses the column name as the reference for the range that it's working on. That way, if we add more data, so if I went to the bottom right-hand cell, tab, we get another row of information, and my total in here will include that information, 5,000. But changes, let's have one child, and it's at home child, and we have 2 cars, born on a Sunday as well. The subtotals, which is the function being used here, is a much better use of functions than the raw functions of sum, average, min, max, etc. You tell the table you would like a total row up here, and you then go along your total row deciding which of the columns you'd like to carry out a calculation, choosing your calculation from the list that is available, or even choosing more functions, and then you can go searching through the function list for a different function that perhaps you would like to use. That's the total row. At any stage you can turn it off by removing the tick, and then it's no longer there. Click again, it comes back. Notice it has retained the settings you had previously. If you didn't want those, you'd have to make sure you went in and changed these back to being none. So that's just a little caveat there. If you turn it off and turn it back on, it does remember what you had in the totals row when you previously used the totals row. We've already seen that we can add in new columns to our Excel tables, but if we want to add in a new calculated column, well, the mechanics isn't any different, but the cleverness is. So let's say we want to add in a new column about here that has the initials. So I'm going to add a calculated column in that figures out the first initial and the last initial. Firstly, I need a new column. Insert table column to the left. Our new column is going to have the title of initials. Now the formula to figure out the initials is equals left, open brackets. Now it's this cell here that I want, but watch when I click on it, I don't get C2, I get at first name, which is the column. But the at symbol means I want the value of first name in the current row that I'm in. I then only want the first character, so it's comma 1, close bracket. But then I want the last name initial. So we're going to ampersand, left, open brackets. Again, I want this cell, so I click on it, and I'm not going to get E2, I'm going to get at last name. It still does the color coding thing. I've got blue at first name and red at last name. And again, I just want the first character. Now, actually, just as a little aside of the left function, if I don't say how many characters, because notice it is an optional parameter, then the assumption is 1 anyway. So I don't need to put the comma 1. Return, and you'll see I get the AC for Amanda Cook, but it also then replicates that formula down the whole table without asking me anything, just goes and does it. So I then see LM, GX, IR, JJ. Now there is a little get out of jail clause here in the drop down. I can undo the calculated column, which means the rest of the column won't have the formula in, or I can stop completely doing it anymore. Well, I don't want to stop it from doing it, because that is the whole point of me having the table in the first place, that it's going to help me out. And it's helped me out, so that's fantastic. I can just leave that alone. And that will happen with any new calculated column you add in. You simply do the formula for the first one, and the rest are just replicated for you automatically. That in itself is enough of a reason in my mind to be using tables instead of just ranges. So if we were to try here to extract the postbox name, so without the at, and we do insert table column, I'm going to call it postbox. Now we have done this previously, but it's going to be slightly different in the formula within the table. It's equals left, open brackets, that cell, which is at email address. So it's the column name with an at the front. Then how many characters do I know to grab? Well, I've got to find the at symbol. So find the at within at email address, close brackets, and close the left bracket, return. And I get Amanda at. So I'm getting the at as well, which is what happened before, but I need to take another one off. So it finds where the at is, but then takes another one off the count of how many characters from the left it's going to recall, return. And although I've made an edit just to this top function, it then replicates that change down the list, so they've all lost their at symbol at the end. There's no copying and pasting or fill handle, double click, drag down, all that kind of stuff. The table automatically replicates the calculated column for you. You do the top cell, it does the rest. No questions asked. That's the basics of adding a calculated column. You insert the blank column, you enter your formula, noticing that it doesn't use cell references, it uses the column reference, so the name of the column with an at the front, press return, and as well as entering the one formula, it then replicates that formula all the way down to the bottom of the table, all the way down here, and it's exactly the same formula replicated for me. Now we've seen tables in action, and we can see how much of an advantage they are to using them, but we have yet to see some of the really big advantages. One of those really big advantages is if you use a table as the basis for a chart, the chart will automatically update when extra data is added. Now that is not always the case when you use a range, because you can add data to a range, but the chart range does not automatically expand to use the new data you've added. Let's take the sales data working file and see this in action. Now at the moment, our sales data isn't actually a table, so we need to just click into the data. Control T was our fastest way of creating a table. Excel will then highlight what it feels is the data cell components, and it's got it right, as usual. Okay, that then gives me a table in the default color scheme with the default name table 1. I'm going to change that and call it sales data. Now that I've got my table, I'm thinking I'd quite like a chart, please. And I'd like a line chart of the sales. The only data I actually need is the date and the sales. So if I highlight those two columns and then create a chart. Well, the quickest way to create a chart is just the same as if it was a normal range, and that's the keyboard shortcut F11. Now you could go ahead and use the alternative method, which is to insert chart from the insert menu. Now the keyboard shortcut does give me a default chart, which is the columns, but I'd like a line chart for sales. So I can go to change chart type, line, and we'll go with one with markers. Okay, and it's quite a busy chart because there's a lot of data to graph between 2009 and 2015. But we get the idea. Probably best actually if I take the markers off. It becomes smoother then. Okay, so I go back to my sales data and I'm thinking, oh, I need some more data. We know how to do that. We go to the bottom right-hand corner, tab, and then tab out of the last cell, and that inserts another row. You can see it's extended the actual table limit. We can see the little corner there. I need a new row of data. I'll make up the ID. I'll give it a date of January 15, 2015, so that it's not too far ahead of the data we already have. We'll go for a large value though. Let's have $350. And then the other data is effectively superfluous, so we'll copy Thirst down and copy United Kingdom down. All I then need to do is go look at my chart, and my new set of data there is $350 on January the 15th, 2015. So it's instantaneous. There was no need for me to check the chart data and extend the range. It just goes and extends the range because the table range has extended. And that goes for whether I add it at the bottom or whether I insert a row in the middle, as we have done previously. But if you were to insert a row in a non-table range, it would extend the chart range anyway. It's these ones at the end that don't normally get extended when the range is a normal Excel range rather than a table range. So as long as the table extends, as it always does when you tab out the bottom right-hand corner, then that data is automatically added in to your chart. Let's go for February 15. Let's go bigger, $400. And then again, the rest of that information is not used in our chart, so we'll just copy it from above. Chart 1, and bang, there's the big high bar, $400 for February the 15th. Now, in a similar vein, adding a pivot table based on chart data is just as easy. We create a new sheet, go to Insert, choose Pivot Table, and in the Pivot Table box, you can see here it says Table/Range. All I need to put is equal the name of the table, which is why I gave it a sensible table name, equals sales data. I don't need to tell Excel that that's a table by prefixing it with table exclamation mark or anything like that. I just put equals sales data, and Excel will go looking for a table or a named range called sales data. In our particular case, it will find the table called sales data, pull in the column headings here for me to then create my pivot table. I could drop the country into the rows, the sales into the values, and I've got myself a pivot table based on the sales data table. Now, although the range self-extends, if I tab again, add another record, go from March the 15th, $400. Now, this time it does matter what we put over here. So we're going for United Kingdom again. So that's $400 extra. The chart will automatically respond, and hey presto, there's another marker. The pivot table does not automatically expand. Although the data range is expanded, the pivot table does not refresh itself. That will still require a right click and refresh. For the new value, and you can see there it's brought it into United Kingdom, has gone up from 62 to 66. Although the data range expands, the sales table expands by itself, which therefore the chart can see and update itself. The pivot table can see that, but it doesn't update itself anyway. It always needs that manual refresh, which can be a right click and refresh, or you can close the file and reopen it, and that will refresh the pivot table as well. So we can create both charts and pivot tables based on our Excel tables. Now we know that if we use a table in Excel, we just need to get to the last bottom right-hand corner, press tab, and we can enter a new record. So here we are in our sales data form. This has a sheet, which is a table, and it has a chart that is responding to changes in that table, but with grouped options by the year. So if I go from the bottom right-hand corner, tab, I insert a new ID, pick a date, go for 2010, add $500, and we know that the chart will respond by adding $500 to 2010. 2010 now shoots up. Let's change that back down to 15, and we go back to a normal relative size. Now that's fine, and it works. The only problem is we have to get to the end of the table. What happens if you're in the middle at the top and you don't want to get to the end? There is another way of entering data, particularly if you want to enter quite a lot of data, and that is by using a form. Now, the form is a tool that exists in Excel and has existed in Excel for quite a few versions. The only thing is, since 2007, they've sort of hidden the functionality away. But we can go get the option and perhaps create a new ribbon and add it to that. Or for the purposes of now, we can just add it to the quick access toolbar up here, because we can add anything we like to here as long as we can find it. So where is the form command? Well, let's go into a little drop down here and choose more commands. From the list of options here, let's go for commands not in the ribbon because the forms command does not exist in the ribbon. And they're all alphabetical, so we're looking for F. F for form. We simply then add that, and it appears over here in our quick access toolbar. And we say OK. There's the form icon. Now what that does is it creates a little mini form for you to make new data inputs. Actually, not just add new data inputs. You can delete records, you can edit records. If I click this form whilst I'm anywhere in the table, I will get a mini form. If I try to click it while I'm not in the data, just to show you, it says this cannot be applied to this range. You have to be in some kind of range that we can understand. Well, our table is a range that it can understand, so form. And what you get is one record on the screen at any one time. And we can scroll through the records manually. We can add a new record without having to get to the end or insert in a row. We just go new and we type in a new data entry. 70,001. What's the date? 12/15/2011. How many cells? 79. Quantity 2. What city? York. What country? UK. And if we want to add another record, we simply tab out of country and you see the new button gets highlighted and we can just press enter and we get a new record. So ID 7002, the date January the 6th, 2015, sales 120, quantity 3, city, let's stick with York in the UK. Tab through. Now, where are these records? Well, they've just been tagged onto the end. If I close the form and go to the end, you see the two new records I've just added have been added onto the end as if I'd gone to the end and tabbed along. Those two new records will be affecting this chart because it's dynamic and we see 2015 is now shot up. So we can access this form at any time. Click in the data, click on the form icon that we've now added to the quick access toolbar. Using it to enter records is fantastically easy. We can use it to delete records. And we can either scroll through to find the record we want to delete manually. Perhaps this one here, delete. This record will be permanently deleted. OK. And the row is removed from your table, and the table is obviously then shrunk by one row. We could use the form to search for someone to get rid of. Let's search criteria. That effectively then brings up a blank form, and it says criteria here so that we know that we're searching rather than adding a new record. And then I can choose which one of the fields I want to search in, perhaps quantity, and I want to look to see if there's anybody in here who sold 4 items. I put a 4 in quantity and go find next. Finds one here, record 52, find next. There's another one, record 66, find next. Record 87, find next. Record 103, or I can go backwards, find previous, or I can choose criteria again, take me back to the search form. Now, these criteria can actually be a bit more complicated than just looking for a straight match. Maybe I'm looking for anybody who's sold more than 4. Find next, and we find record number 40 has sold 12, so that's more than 4. Find next, 6, 8, all these more than 4 in the quantity column. Back to criteria to take me back into here. I can do multiple field searches. So I say, okay, the quantity has to be more than 4 and the city has to be Thirsk. Find next, more than 4, city Thirsk. Find next, there isn't anybody, go previous, and there's just the 2. Criteria is the blank criteria box, and I can put criteria in any of the fields, more than one of the fields, and then multiple criteria come into play. So it has to be and, there's no or option, that's the only drawback. So it has to be quantity greater than 4 and city equal to Thirsk. And I can use comparisons, so more than, less than, equal to, not equal to, and I can even use wildcards. In here, I could put T and a little asterisk wildcard, and that will be any city beginning with T. Let's remove the quantity, see if that finds many. We know about Thirsk, but there's Telford, Thatcham, Tadcaster, Totten, Tarpully, Thorpe Park. All of these begin with T. That's using the wildcard in the search. This form started out as an easy way of adding data. Now actually is a great way of searching through your records, because once you've searched through and find who you want, you could then delete that record. Gone. And effectively that row is removed from the table. So the form, although it's not there easy, it should really be on the data ribbon personally. You have to add it, and we added it to our quick access toolbar. All you then need to do is click inside your table, click the form button, and you get the form built around the number of columns in your particular table. and you see one record of data at a time, so one row at a time, allowing you to scroll through, add new records, delete records, and even use the criteria option to search for records, and then either delete them or edit them as you see fit. A really clever way of filtering your data within a table is to use the data slicer. Now, this isn't available when you just have data in a normal range. As soon as you make it into a table, as well as all the other additional bits we've got and explored, you get the data slicer option. So let's explore the data slicer. We're going to make use of the contacts extract T&C. You simply need to be in your table, and we have a lot of information in our table, so anywhere's fine. Then on the Table Tools Context Sensitive ribbon, there's our Insert Slicer option. If we give that a click, it asks which of our columns, because these are all the column headings, we would like to have as a slicer. Well, let's take the city and the gender. That will create us two slicers. Okay, now if you've not seen these before, what slicers are effectively floating filtering boxes. So this little box here is the gender slicer, and I can move it across, place it where I want, can go up to the top of the sheet and keep on going to the bottom of the data. It's only an object, so I can resize it. There's only ever going to be F and M in here, so this can be resized to be a lot smaller. Now the city, there's a lot of cities, so that has a scroll bar, and I'm not really going to be able to expand that enough to see all of those. With the slicer selected, so either that one or that one, you get a slicer context sensitive ribbon, which allows you to control the color scheme. So maybe I want to change the gender one to a bluey color, or even in the drop down go for a darky purple color. That probably clashes with the actual table color, so let's go for red instead. Now the way that these slicers work is that they filter the data. So in the gender column, we effectively only have two values, F and M. If I now click on M, I see that that filter is applied. So I've got little blue numbers to indicate a filter is applied, and down the status bar it says 52 of 100. And if I have a look at the gender column, see the advantage here is I don't actually have to be looking at the gender column. They're all M's because I've applied the gender slicer. If I click on F, then it filters and only shows me whose values are F, and that's 48 of the 100. If I want both, then I simply Control-click both of them, or choose this little option here that allows you to multiple select without the Control key. Let's put both of these back on, so we've got M and F both in place. Now, the other one will filter by the city. So at the moment, they're all selected. That's the default. If I then click on Sunbury, only Sunbury is selected. I only see 3 records. If then I Control-click St. Leonard's, Springwood, they then get added into my filter list. I can work in conjunction with the gender one and click on M, and I only see males, Springwood, and St. Leonard's. Put the females back, and I get all 3 towns back. So one of those towns dropped out of the filtering when I only chose males because there's only females that live there. So you can work these in conjunction with each other. If at any point you don't want to be filtered by this particular slicer, you can use this little option here to clear the filter, and that will bring all of your towns back. Once you don't want a particular slicer anymore, you can simply click on it and press delete on the keyboard, and it will go. It just leaves me with the gender slicer. They're little filtering options. You can choose any of the columns that you've got, any number of the columns that you've got, and you'll get these floating slicers that show you the unique values within that column to then allow you to filter by. So we click into the table, we insert the slicer, we choose the column or columns we want to have a slicer for. So I could perhaps go for address type. And what about occupation? These two would be much shorter in their list. Occupation only has a few items, so that can be resized much smaller. Address type only has 2 items, so that can be resized a lot smaller. There are other options in the slicer ribbon, as well as changing the color scheme, which we've seen. You can control their 3D layering. So you can see if I move address type over, it obscures gender because it was added previously, or I can make it go behind gender by using these options here, send to back, and then it's behind the gender. So you've got stacking capabilities. You can also change how the columns display. Currently they're listed as 1 column. If I go 2, then you can see how there's only 2, so they get put alongside each other. If I do that with occupation, because there's 4, you get 2, 2, and 2, 2. But then you can't read all of the text because the box isn't big enough. So it's getting the right layout for your particular slicer. These work quite well side by side, and probably the gender one would as well. so just M and F, allows you to make the slices that little bit smaller and place them where you want them on the screen. So that's the slicing options. Nice little floating filter quick selection, which can be quite useful, particularly if the column you're trying to filter by is off the display area. Whereas with the filtering using the drop-down arrows, I need to go to that actual column to make the selection, and then potentially have to scroll back to see the data that I want to see. So it's just another way of applying filters, a nice little clever way. They're saved with the file, so when the file's reopened, you get the same little floating slices. So anyone else opening the same file gets the same little floating slices. So you could help them out by giving them some slices to filter the data that they're interrogating. Now we've been, with our filtering, able to filter our data quite extensively in tables, either by using the data slicer or by using the filtering drop-down options, where we were presented with a variety of filtering parameters, dependent on the data type, greater than, less than, all those kind of things. And with the date ones, it got quite clever with particular date ranges. But none of that cleverness, whether with the data slicer or the filter drop-down, can handle an OR. They're always AND. So as soon as you start to filter by two sets of criteria, then those criteria must be AND. So for example, we could filter by people who had high school education and were skilled manual, and you would get everybody who matched up. But what we couldn't do is an OR query. We couldn't say, okay, let's see everyone who has either made it to graduate degree or is currently employed in clerical. Not AND, but OR. One or other can be true. Both can be true, obviously, so they could be an AND, but it's OR. If one is true or the other is true, then pull them into my result. That cannot be done with the little drop-down arrows. We need to start looking at advanced filtering. Now, Excel has a great tool for advanced filtering, but we just need to do a little bit of setup first. The easiest thing to do is to add a new sheet, which I'm going to call criteria. And then in this criteria sheet, we're going to mimic the headings. So the headings have to be exactly the same as our data table in this case. So we copy those, we go into our criteria sheet, and then we paste. And then we have the same heading columns across the top. Let's just auto fit those so I can read them. Thinking about the OR statement that we were trying to carry out, which was that people had reached a certain educational level of graduate degree. So the criteria would be graduate degree. I don't need to auto-fit, but I'm going to just to make it easier to read. And the occupation is clerical. Now I could put clerical in here, and when we do the advanced filtering, you'll see that that will then get treated as an AND. If I put the clerical in the next row down, then it gets treated as an OR. These are effectively my criteria. Education equals graduate degree, or occupation equals clerical. And the OR is only determined because of the separate row. Now we get to do the clever bit. So we go back to our data, anywhere in the table. We then go up to the data ribbon and come to advanced on the filtering option. One click brings up the advanced filter dialog box. So we're looking to filter the list in place, or we can copy it to another location, but we just want to take our current data and filter it by the set criteria. And the list range has been chosen because we're in the table, and that's the whole table, so that's fine. The tricky bit is then telling Excel where the criteria is. Well, it's not that tricky. We simply browse. We click the browse button, go to our criteria sheet, and we make sure that we highlight all the columns and the three rows. So the row that contains the headings, the row that contains the first of our criteria, and the row that contains our OR criteria. So we need to go right to the beginning. I'll show you shortly how we can make this a little bit faster. And then we can click to go back. So our list range is in here, the criteria is stored in here. We then say OK, and the filtering takes place, and it finds 20 records. Those 20 records, if I look at the two columns concerned, should be, and in fact are, either graduate degree in their education, let's widen that up, so that's those three, or clerical in employment. So if they don't happen to be of graduate degree, then they will be clerical. There we find, in fact, that is the case. You can do anything in this criteria field. If we go back into here, let's say we don't want to do these two options, graduate degree and clerical. Let's remove those. Perhaps what we would like to do is everybody whose name begins with A. So let's go to the first name, A asterisk. So that's the wildcard character. We can use those in here as well, just as we saw in the normal filtering. The first name is going to begin with A, and then because we want to make use of an OR, we come down to the second line, or their total purchase YTD is a greater than, so we can use the more than symbol, 6,000. So we have two criteria in place again, one on each separate line. Go back to the contacts, back to advanced, filter in place. It spots the list range quite happily. We need to then click into the criteria range and again browse to pick that up. I'm still yet to show you the quick way of doing this, but we'll get there. Highlight all three rows because criteria is in both of those rows and the headings are in the top row all the way to the end so that you can match the columns to the criteria, and then OK. A little bit of working and we should find that we only have people whose name begins with A, so we should have everybody whose name begins with A and everybody whose total purchase YTD is greater than 6,000. You see that this is taking a little longer than normal filtering because it's having to visit each row to decide if it meets either one criteria or the other. And in fact, just over half of our records match one or the other. So these two begin with A, then John doesn't, so his year to date must be greater than 6,000. Total purchase YTD, 8,000. All of these down here are over 6. They match the criteria. Someone there isn't, begins with 2. Their name must begin with A, and it does, in fact, Amanda. Obviously, some people's name will begin with A and have sold more than 6,000, so they'll meet the criteria on both accounts, but they still are in the set. Now, I did say I was going to show you how you could speed up the criteria side of things. Well, we can do that with a named range. I come into the criteria and highlight the top 3 rows and then give them a name. Again, no imagination. We'll call the range criteria. Let's make a change to that criteria and say the age is greater than 40. We need to remove the criteria that's already there. More than 6,000 needs to go. And their name, well, let's remove the first name and say their last name begins with S. Again, because they're on separate lines, this is an or. Last name begins with S, or they're over 40. Into the contacts, advanced filtering. This range picks that up fine. It's actually remembered my previous criteria, so I need to delete that. What I want to put in here instead is just equals criteria, because that's my named range. Obviously, there's no little helps here either, though. When you're doing it in the formula, you get a little help. I've got to make sure I spell that named range correctly. So assuming I have, OK, and that filter then gets applied, and in fact finds nobody that matches those requirements. Probably been a little too strict. Let's go back. Let's remove the age. It might be the surname. We might not even be beginning with S. Come back in, advanced filter. This should now pull through everybody, because we've left the S asterisk in, but we removed the age. So it begins with S asterisk or anything, which means that everybody will be in here. But because the advanced filtering is in place, it's having to visit each record. This is not the fastest way to work with filters. If you want ands, then go with the slicers or the filter drop-downs and retain this advanced filtering for the use of essential ors. Everybody is included because they meet one or other of the criteria, so they either have a surname beginning with S or anything. Let's go back to the criteria. We know A asterisk in the first name has some people, so let's do that as our first criteria, and then we can make the age back to what it was, which is greater than 40. That way, when we go back to our contacts and run the advanced filter, OK, we know this time we will find somebody. In fact, we get 79 records match one or other of the criteria, beginning with A or greater than 40. Our last stop here on the table adventure is the ability to use tables that are linked to external data. So the data is not stored in Excel, but you can see it in Excel, you can filter it, you can manipulate it, but obviously you can't make any changes to the raw data underneath the table. That's great, you're protecting the data, but you're allowing yourself or other people to then run filters, sorting, etc. on that data. So let's take the external data working file. It's actually blank, but we're going to link it to 2 external data sources. And the steps to doing this are to go to the data ribbon, get external data, and in the pop-down, you'll see there's a variety of default choices. So we've got from Access, or Microsoft Access, from the web. Now that works if the web page you're linking to actually is formatted correctly. So it's not a brilliant solution, but it does work. From a plain text file, so it may be a CSV file. From other sources, and there's a drop-down of quite a few choices here. SQL Server, Analysis Services, Windows Azure Marketplace, OData Data Feed, XML Data Import. data connection wizard from Microsoft Query, or it may be you've already created one of these connections previously, and therefore it will be listed under existing connections. We don't, so we're going to go through the stages. First one is from Access. There is an Access database within your working folder called Employees. The first step is to navigate to that Access database and then open. From the database, we then get a selection of the tables and the queries that we would like to link to. I'm going to go with TBL Employees, so that's all the employees' data. Okay, how would you like to see that displayed in Excel? And although there are a number of choices, if we go with Table, we actually see the data. If you go with Pivot Table or Pivot Chart, you see a summary of the data. You don't actually see the data underlying, whereas with a table, we will get to see the whole data. So I'd like to go with the table, place it in the existing worksheet starting A1, it's a sensible location to start, and then OK. The data is then pulled in, and we have 99 records of the employees' data from the Access table. Now, although you can make changes here effectively that look like changes, like deleting things, you're not actually changing the underlying data source. And at any stage on your Table Tools ribbon, you can refresh the data. So I click the refresh button, and that data that I thought I'd deleted actually comes running back from the Access database. So we have what is really a one-way connection. We can see the data, we can filter data, we can hide columns, we can change the order of columns. But every time you then ask it to go have a look at the Access database to update itself, any changes you've made to the data are then overridden with the actual data that hasn't been changed. But it's great because it safeguards that data, giving you the tools to then manipulate what you see in the table with all the table tools we've just done. So the filtering, the sorting, the changing of the styles, the total rows, all those kind of things you can add to this table. The data is not stored in Excel, it's stored in an external data source, in fact, in the Access database. Now that's one example. When you do create a connection, you effectively create the connection as well. And we'll see on the data ribbon, connections, there's your employees connection. And if we check the properties, we've got a few options in here for enabling background refresh or refresh every so many minutes. Refresh the data when opening the file. So every time you open this Excel file, this table would refresh itself based on the latest information in the Access table. That's quite a good little option. Okay, let's go to sample 2. In sample 2, we're going to make a connection a little further afield. So it's not to an Access database that is located a little bit further across on the hard drive. We're going to connect from another source from a SQL server that is actually located out on the internet. Now, unfortunately, this isn't a connection that you will be able to carry out, but you'll be able to see what I do. And if you do have access to a SQL Server database, then you'll be able to do the same thing. So we need to know the server name. We also need a login, which we didn't need for the Access. The login is pretty secure. You need to know your username and password. If they're correct, you'll then be connected to the SQL Server, wherever it might be located, in the cloud, on your internal network, even on the same machine. And dependent on the login permissions you're using, you'll then get access to a number of databases and a number of data objects within those databases. We have quite a high permission, so we can choose the database we want to connect to, and then choose the data object that contains the data we want to place in our table. Next. What will then be saved on your machine is an ODC file. You can call it something sensible. Mine's been called the SQL Server name and the view name. I'm going to call it shop data. You could, if you're sure no one else will have access to the file, save the password in the file, but it is a little dangerous. And then finish. Where do we want to place the data? Well, it's the same as Access now. In a table in A1 of this sheet, please. OK. And then that pulls through your data. Exactly the same as the Access connection. You're effectively one-way traffic. You are seeing the data, and totally regardless of the fact that you can appear to delete data and records, as soon as you refresh, it will pull in the latest information from the external database, in this case, SQL Server. But apart from that, you can do everything that you can do with tables that are based on Excel data. So let's take our working file, contacts with samples, and have a look at what a pivot table actually is. Well, in this file, we have a number of sheets, the biggest of which is the contact sheet, and this contains 18,000 and some records of people who have been customers for the current company. What the pivot table allows us to do is effectively summarize that data, because with 18,500 and something rows, that is a lot of information, and we just want to read some of the statistics out of it. So we've created 3 sample pivot tables here, so you can see what a pivot table actually does. So in example 1, on sample 1 sheet, you can see we are summarizing for each city the total purchase YTD. So from our data, what that does is it goes along to the total purchase, this column here, sums every value within that column, but based on a filter of the city, which is here. So it goes through, it sorts them by city, and then groups the cities together to give me a total for each city. So Ballard, or people from Ballard, not the actual town, have spent $181,236 in the year to date. And we can go through and see it's done that for all of the cities. So we've done a summary. Sample 2 is a shorter summary because we're now summing the same information but by country. So again, it looks in the contacts data, finds the country column, which is this one here, groups all of our customers by country, and then adds up their purchases YTD. That way we get a grand total for each country. So the United States, or people from the United States, have spent $37.6 million with us. We're able to summarize data, and in fact able to summarize that data very quickly. Now here, in sample 3, we've gone a little bit different in that we've used 2 of the columns of our data. We've used the yearly income, which has people bracketed by their annual income, and we've used children at home, and you can see here we've got 0 to 5 for the number of children each of our customers has at home. Where the 2 values meet, so somebody, for example, who has no children at home, but falls into the $25,001 to $50,000 annual income bracket, we have sold $23.5 million worth of items. We're able to do crosstabs effectively. We take 2 of the columns, we sort of group the values within those columns, and that gives us our column headings for yearly income and our row headings for children at home. And where they meet, we then sum, in this case, the total purchase YTD. Now in each of these pivot tables, you'll notice that there's a pivot table field option on the right that when we click out of the pivot table is no longer visible. That's only there when we have a pivot table. How do we create a pivot table? Well, we start with the initial data, our contacts information. We then simply click anywhere in the data and go to Insert, Pivot Table. One click. What Excel does then is it highlights the data, so you can see little marching ants are around the data, and it's picked up the data range here. Contact sheet, everything from A1 to AE 18,509. So I therefore have 18,508 records because the first row are just headings. Where do we want to place this pivot table? Well, in a new worksheet, please, rather than an existing one, and OK. Pivot table then appears, but there's nothing in it. It doesn't look like any of the samples we've just looked at, because Excel doesn't know which of the columns we wish to use for either the row headings or the column headings, or the data where they meet. That's all controlled over here in the little pivot table fields dialog box. The upper section here contains all of the column names, so it's important that your data has a column name so that you can spot it in this list a lot easier. We then need to decide which of our columns, so I'm going to go for city, I need in my various parts of the pivot table, which are broken down into 4 sections. The rows, so what values will build the rows for my pivot table. Columns, what values will build the columns for my pivot table. The values, what field contains the numeric values that I wish to calculate. So in our case, sales or perhaps average number of children. We don't know what we want to work out at this moment, but any calculation would go there where there's a match between the row and the column. Now you don't need to put something in both rows and columns or in either. The only field really that is required is the values to tell the pivot table to do some kind of calculation. There is then also an additional option here for filters, but we'll explore those a little later. For the moment, I'm interested in doing my first pivot table. I go up here and grab the field that I want, which is city, and drag it down here until I get to this section I wish to be in, which is rows, and let go. And you can see I then get 1 row for each distinct value in the city column. Although I have 18,500 records, I don't have 18,500 cities. I have in fact 277. I'll actually take away the fact we didn't start at row 277 for 273 cities. I then need to decide what I want in the values. Well, it looked quite good when we use this total purchase YTD, so I take hold of that field, keeping hold, I drag that down to where I want to be, which is the values, and let go. And you can see then it sums the total purchase YTD. Now the pivot table will assume sum if we drop a numeric field into the values, and it will assume count if we drop a text field into the values. For example, I could drag this field out by dragging it into the top section and letting go. I could actually take the city field and drop that into the values, and you'll see it now goes for count of city rather than sum of city. And that way we'll see how many of our customers are in each of the cities. There's quite a few in Beaverton and Bellflower, and then some of the others have a few numbers and then some higher numbers. That was a big one. Paris, 1,544 customers in Paris. Really, we can drop any field in here. It doesn't have to be a numeric field. If we drop a text field in, it assumes count, and it will count how many records are in that particular column. Let's go back to where I was after, which is total purchase YTD. Drop that in here, and then these numbers should be the same as our sample one. 181236. The formatting isn't, but the data is. That's a straightforward, simple pivot table. You start in the data, click into the data, insert pivot table. As long as the data has no blank columns, it will pick all the data up, just as we've seen previously in Excel. OK. This then creates you a new pivot table structure in a new sheet, into which you then decide which of your columns you wish to use. So you wish to summarize. It may be that I wish to take the marital status into the rows, and there's only two, married or single, and I'd like to just count. Let's take the text field, which is marital status, and it will then count the marital status. We have 40,100 that are married, 33,932 that are single, giving us our grand total of 74,032. That gets you started on pivot tables. The next stage is formatting, multiple columns, lots of summaries, drilling down, lots of little things that we can do in our pivot tables to both customize and make the most use of them. This first stage then has been to get you started. Getting to understand pivot tables a little more and experimenting, there is a new feature that has been added to pivot tables within Excel since 2013, and that is the recommended pivot table option. You would take your data as normal, just click within, go to insert, and instead of choosing pivot table, assuming you know what you're doing, you would instead go through recommended pivot tables to see what Excel can offer. Now, even if you know your way around pivot tables, this can still be a quick way of getting in to get yourself a pivot table summary. So we choose the recommended pivot tables option, and it then comes up with a variety of choices. Here on the left, you can see sum of total purchase YTD. That's been split by title, so Mr. and Ms. Sum of total purchase YTD based on the middle name. Strange option, but it's what it's gone for. Sum of total purchase YTD based on the state province. Pretty similar to the one we did in our sample, based on the day of the week that they were born. If you want to do some strange statistics, sum of customer ID. Now that wouldn't be very useful, just adding the customer IDs up based on total purchase YTD. That starts to become a little stranger now. Sum of total children based on the country. Sum of number of children at home. Sum of number of cars owned based on their education. Sum of age and count of email address based on their occupation. Count of email addresses based on their date of birth. So some of the lower ones perhaps are a little strange and would not be ones that you would ordinarily think of, but the ones near the top, perhaps not that one or that one, but certainly that one, are ones that you might want to consider. Now, should you like the look of one of the recommended ones, perhaps this one for example, you simply then click OK. Alternatively, if none of the recommended options here down this left-hand side suit you, you don't actually need to click cancel. You can just go blank pivot table, and that will be the same as going to insert and pivot table because the data is already selected. So you can look through these every time you create a pivot table, decide none are for you and go for blank pivot table, or decide actually I quite like that one and then OK, and that pivot table would then be generated for you. And there you can see the row labels are our region, and we can see here in the pivot table lists which ones have been chosen: state, province, name. That's what these are. Now notice they actually have a plus next to them which can be expanded, and that plus is into the email address, which would be a bit of a strange grouping because email addresses are unique to individuals. Potentially I would remove the email address, leaving me with address type, which we've got there as a grouping of home, and shipping. Again, perhaps the address type we don't need. Even though we've selected and gone with one of the recommended pivot tables, we can then still edit that pivot table by changing the rows or the columns, or even the mathematical calculation in the data section. We can see this recommended option in place on another working file, which is the sales data working file. Here's our data. We click anywhere within it, go to Insert, Recommended Pivot Tables. Now this is a smaller data set, and its recommendations are a lot easier to match what you might choose yourself. We have sum of sales by country, each country and the total sales. Count of ID by country, so that effectively will be number of sales by each country. Sum of quantity, so number of items by each country. And we have a strange one, sum of sales by quantity, how much has been spent based on the number of items purchased. I suppose it's not that strange. Count of ID by quantity, so how many sales were made, physical purchases based on the quantities, and that's the total of our recommended. You might actually go for the sum of sales by country. Okay, and that pivot table is then created for you. Each of the country's unique values within the data, and then the sum of the sales, so of the sales column. There's our two columns in place, country and sales. You can see there with a smaller set of data, the recommended pivots actually get a lot closer to what you might choose yourself. Now we have seen that it's pretty straightforward to create a pivot table. You just take your data, click into it, go to Insert and choose Pivot Table, and Excel spots the data and then you're away. However, sometimes if your data is constantly changing, or maybe there are some spaces within it, or maybe you just prefer this secondary method, I personally would always recommend naming your data range, and then you can create your pivot table at any stage you like in any sheet you like. Here we are in our sales data. To name the range of data, I firstly would need to highlight it all. Click anywhere into the data and Control A will usually suffice. Quick check to make sure, so it's gone right to the bottom, 818 rows, and it's right to the top, including the column headings. I know it's got the right data source. Click into the name box and then give my data a sensible name. Now there is nothing more sensible than calling it data. Don't forget the return so that it accepts your name. You can always check that that's gone in by going to Formula, Name Manager, and checking that we have data in there and it's covering the correct range. It's also in here that you could come in and manually adjust the range so that a different set of data is being fed into wherever you're using it. At the moment, we're not using it. Now that we have a named range, creating a new pivot table using that named range is pretty easy. We go to the sheet that we want to put the information in. So I'm going to sheet 1. I'm even going to rename that sheet as summary. Place my cursor where I might like the pivot table to start. Insert, pivot table. Now I don't go and highlight anything. It hasn't highlighted anything because there's nothing on this sheet. I simply go here where it says table/range and type equals data. I don't want to go in the new worksheet this time. I want to go into the existing worksheet, which is here, and it's going to start at A3 because that's where my cursor is. Fantastic. Okay. There my pivot table structure appears, which effectively is just a rectangle that says to build a report, choose the fields from the right. The pivot table fields then appear on the right, and I can see my column headings. I'm free to go. If I were to choose the country and place that in rows, and then the quantity, place that in values, it adds up how many items have been sold to each country. Now, one thing we also wanted to explore here, as well as the fact that naming the range is going to save you time, effort, and long-term maintenance of your pivot tables, is the fact that the column headings appear like this, row labels. And if I were to put the date here, we get column labels. So that's not ideal. So instead of row labels and column labels and even sum of quantity, I can actually just click into these cells and change what appears there. Where it says row labels, that's actually the country. Where it says column labels, that's actually the year. And sum of quantity is the data within here. I'm just going to call that QTY items. Now I can narrow this up because the word year is much shorter than column name, and I have a much more sensible pivot table. We start in a new sheet, we go to Insert Pivot Table, we use our named range by saying equals data, tell it where to start, which is where the cursor is placed. That's fine if you're happy there, okay. And then select your columns. I could perhaps go for quarters here, and sum of sales within each quarter, but then place the years as the column headings. Now I have sum of sales for each quarter within each year, and the column labels and row labels need changing to year, QTR, sum of sales. I'm just going to change that to sales dollar. Narrow up this column, and we've got ourselves a pretty pivot table. Don't forget, when you click away from the pivot table field list will disappear because you're not within the pivot table. One click in and it comes back again. So it's a context sensitive, just like the ribbons at the top really. You click out, the ribbon at the top disappears and the field list disappears. Click back in, ribbon at the top appears and the field list appears on the right. Making use of a named range for the data that feeds your pivot table will help you manage the pivot table much easier, and if you're using the pivot table over and over again, it's then quicker to then just create a new sheet, equals the name of the range, and then you're away with your pivot table. Let's take the sales data 2016 and experiment with how we can control calculation that takes place where the data crosses. So at the moment we know if we use a numeric field, Excel will choose sum, so it will add up the values. If you choose a text field, it will then choose count. So if we were trying to count the IDs, because they are numeric, the pivot table will actually try to sum them. And we've seen that previously in an example. We need to be able to control what calculation takes place and what other calculations are available. With the sales data 2016, I'm going to create a new sheet and in here insert a pivot table. Now the pivot table is a named range called data. So all I need to put is equals data, tell it where to start the sheet, A1's fine, OK. If I then take my countries and place them in the rows and take the sales and place that in the values, I get sum of sales. Now if I don't want the sum of sales, then I can change that. There's a little drop down arrow here, value field settings, takes me into this separate dialog box. And what you'll find you can do here is a number of things. One is we can change the custom name. So it doesn't have to say sum of sales. You can see it says sum of sales at the top. This is effectively the column heading. And I want to rename that to sales. But you'll find you can't actually call it sales because the source is sales. But I could call it sales and $1. In the bottom section here is where I control the function that takes place. We know it's defaulted to sum because it's a numeric field. And clicking on sums changed the title again. So I'll go back to change that before we come out. I could change to count. So that will count the actual number of sales, or average. So that will be average sales values, the max, highest sales value, the min, lowest sales value, the product, the multiple of the sales value, count nums, and then we're into standard deviation and variance, should you wish those in your pivot table. But ordinarily, we will be sticking with this top section here, sum, count, average, max, min, and possibly product. If actually I don't want to sum the sales, but I want to find the average, then I could choose average. That changes the custom name, which I can amend myself to average, and then OK. And now the label changes, and the totals that we see displayed are the actual average. And because some of the values are bigger and smaller than others, or dividing by bigger and smaller than others, some of the decimal places are quite long, like Belgium, for example, 3.6566666667. And some are quite short, 4.34, 2.99. It would be nice for presentation if we could control that. Well, we can. It's all done through the same dialog box effectively where we change the function. So in the little drop down, value field settings, there's our function. Here's the number format option. So one click in here then allows me to control what this number will look like. Well, it's an average. I want it to be a number, but with 2 decimal places. OK, OK. And then I see 2 decimal places, much tidier, much neater, and more consistent down the whole column. But what I want is actually sum, and to display this number in dollars. So we choose currency, make sure the dollar symbol's chosen, OK, OK, and then we now see the sum of the sales with dollar signs, because I formatted to show dollar signs. This little drop-down value field setting controls 3 things really. One is the decision on which function to use on the numbers or values within that column. The custom name you would then like. Make sure that you change the custom name after you've changed the function, because changing the function changes the custom name. And then we have control over the number format. And this is exactly the same options as you see when you go to format a cell, but just with the number options. We don't have all the other tabs here. We just control the number formatting. So number, general, currency, accountant, date, percentage, etc. OK, and OK leaves me with all those options in place. And because I have the ability to change the function, there's nothing to stop me actually using the same field over and over again in my pivot table, but applying a different function each time. At the moment I'm seeing sum of sales. Let's go in there and change that to total sales. Bring down the sales column again, so I can add this in here as many times as I want. Bring it down a third time. Notice the dialog box then gets a scroll bar. Now they all assume sum. Each time I add them, it assumes sum, but there's no formatting taking place, notice. Let's go for the second one I chose. Change that to average, and then we'll change the heading to average. The number format will go to number with 2 decimal places. OK, OK. And then we get an average column. The third one, I can then change that. Let's say max, highest sales. Number format is going to be currency. OK, OK. And then we get the high sale for each country, because they're still broken down by each country. Don't forget we can change this label here, so the column heading makes sense to anybody reading the pivot table. So each of these columns are drawn from the same data. They're all drawn from the sales data, but we're carrying out a different function on each one. The total sale, average sales, the highest sales. We really ought to count the number of sales, shouldn't we? So let's bring the ID in, drop that in. Notice that because it's a numeric field, it's assumed sum, so we end up some very large numbers in here. What I don't want to do though is sum, I want to count. Go into the drop down, value field, change to count, and then we'll just call that sales, because it's the actual number of sales. Okay, can't do that because sales is already in use. This column here is using sales, so we're going to call it hash sales. Okay, and then we get our quantity of sales. Australia, for example, have made 5 sales. The total value of those sales is $21.70. The average value of those sales is $4.34. That ought to be in dollars as well. We come back down here, average, number format, currency, still to 2 decimal places. Okay, okay. The highest individual sale was $6.99, and that was achieved by carrying out 5 sales. Notice Bangladesh is 1 sale, so effectively the highest, the average, and the total is all exactly the same, which helps you to believe that the numbers are realistic. We can add in the same column multiple times, we can change the function that is being actioned on those columns of data, and we can format the number that appears in our pivot table. We're pretty much in control of what we get. Ordinarily, I'm sure you wouldn't want to, but we need to cover the fact that you can move a pivot table. Having created the pivot table, and we have here a working file, sales data 2016 pivots, that has 2 pivot tables. One in an originally named sheet called Pivot 1, and one in an originally named sheet called Pivot 2. Both of these pivot tables are based on the data in the sales data sheet. Now, having got these pivots, we might decide we want to move them. Perhaps we'd like them in the same sheet, so that we don't have to flip between the two and we can compare what's happening. Well, to move a pivot table, you simply click into the pivot table that we would wish to move, go up to the context-sensitive ribbons up here, Pivot Table Tools, and then the Analyze one, because there are 2, the Design and Analyze, and we have an option for Move Pivot Table. Selecting that option gives us the ability to move the pivot table either into a new worksheet, in which case a new worksheet would be created and that pivot table would be placed in it, or move it to an existing worksheet, and we can choose the existing worksheet by using the Browse option here. I can move it to Pivot 1, and then I need to select a cell, that cell being the starting point for the pivot table. So I place it here, go back with the Browse, and then OK. That pivot table is then moved from Pivot 2, which is now empty, into Pivot 1 and placed here. When you move a pivot table like this and place it in another sheet, what you do have to be careful of is that you're allowing the pivot table enough room to exist. For example, if I'd placed it here, it wouldn't be able to go there because there's already a pivot table there. Or if I placed it a little bit too close to here and I wanted to add another column in here, I wouldn't be able to because there'd be a pivot table in the way. So it's just a little bit of forethought of where you want it to put. But it can exist here, and widening the columns means I can then read it all. It's still connected to the data. It still updates from that data, but we've just moved its location. So you click into the pivot table you wish to move, Move Pivot Table, and you have 2 simple options, into a new worksheet or an existing worksheet. When it's an existing worksheet, you need to use the little Browse icon to tell it not only the worksheet, but effectively the top left-hand cell. So at the point you want the pivot table to start. So if I wanted to go back to pivot 2, I could click there, pivot 2, back up to A1, browse back, OK, and the pivot table moves back to pivot 2. Deleting a pivot table is even easier, and there are two ways. If, like in this particular workbook, we've actually got separate pivot tables in separate sheets, then the easiest way to remove the pivot table is actually just to delete the sheet. I could go to pivot 1, right click, delete, tells me am I sure I want to delete the sheet because it will now be gone, delete, and the sheet's gone. That's option 1. Option 2, I simply click into the pivot table, come back to the pivot table toolbars, so the analyze one again, and we have here select and clear. Well, it's clear that I would want, clear all, or select, and I can select the entire pivot table, and then I can clear. From the analyze ribbon, I can choose clear or select. If I choose clear, there is an option for all, but this is not quite deleting, because watch what happens. It does clear all, but all it does is clear what you've actually chosen, leaving you the pivot table in place ready to go and choose other columns. So that wasn't quite the option that I wanted, so I undo to bring those back. The easiest thing here is to go select entire pivot table, and then you can press delete on the keyboard, which will then remove the entire pivot table. So we either remove the whole sheet that the pivot table is sat within, which is great if it's a pivot table in its own sheet. If it exists in a sheet with other pivot tables or even with the data, then you would need to choose select all to select the entire pivot table from the pivot table ribbon, and then delete on the keyboard. Your two ways of deleting and the single way of moving a pivot table from being in a shared sheet to being in a sheet on its own. There is one area of our pivot tables that we have yet so far to explore, and that is when you click into a pivot table, as we have here in our sales data 2018 pivots, we have 4 little sections. What data is going to make up the rows, what data is going to make up the columns, what data is going to be the calculation in the middle where the rows and the columns meet, but we haven't touched the filter section here. Now this little filter section is sort of a global filter. It works as a pivot table filter. Let's see it in work. We take one of our existing fields and we drop that into here. And what happens is your pivot table is then sort of moved down a little bit and we get a filter above the table. And here we have the sales rep. All the unique values associated with that column are in here. And you can see we have a number of sales reps: Jim, Bob, Harry, Sue, Alice, Jane, and Mike. And what we do is we choose one of our sales reps, OK, and it then filters the pivot table below it. Now we only see the sales that Bob has made, and he's only sold to 3 countries, so only 3 countries are displayed. If we then change Bob to Sue, you can see that we then see Sue's sales. So we're getting a filtered result. Now, cleverly, in this little page level filtering, we can actually choose more than one item. If we click the drop down and put a tick in here, select multiple items, it actually then allows us to pick 2 sales reps or 3 or even 4. So Bob, Sue, and Mike. OK. We then see their total sales split down by country, of course. Now, in the sales rep section here, it then says multiple items. You have to actually click the filter icon to see who has been selected. You can even choose all, in which case you're back to where you started with no filtering taking place whatsoever. So this is the report level filter. Now you can have multiple fields in here. It may be that I wish to bring the country field up into here. So I've then got 2 high level filters, and the data is now just showing me total sales by the sales rep and the country. If I chose not all of them but Harry, and then in the country option, I then chose Germany, it may be that I actually get a 0 result. Harry has sold nothing to Germany. All there, or we can use select multiple and choose individual countries. This page level filtering can be any one of your columns. From here, instead of putting it into columns and creating a column for each unique value, or placing it in the rows and getting a row for each unique value, we can drop it in the filter section and we get a drop down arrow for each unique value, allowing us to filter the pivot table below by those values. So the country, because it doesn't make much sense up in the page filter, I'm going to drop back into the rows, and we see that Harry has actually only sold things to United Kingdom, whereas Mike, but not Harry, has sold things to a few more countries. We can do that with any of our pivot tables. That was pivot 2. We go to pivot 1. To start with, it looks like there's no space, but the pivot table will get moved when we drop things into the filter section. So I could drop the sales rep into there again. The whole pivot table gets moved down, and I can then filter by individual sales reps, Bob, and I just see Bob's total sales, average sales, highest sales, and total number of sales broken down by the countries that Bob has dealt with. Or just like the previous, I can say let's do multiple and see 2 or 3 or 4 sales reps. Total sales broken down by country, their average, their highest, and their actual physical sales. As the report filtering option places itself up here, if we no longer want that page level filtering, we just remove it. Watch, however, that the pivot table leaves space where it was. It doesn't move the pivot table back to the top where it was. It leaves space where you've dropped in page level filtering. For a slight drawback, you can actually delete those 2 rows if you want. Notice also in here we placed 2 filters in. We removed one of them, but it still left the blank line where the filter was inserted. So although it's quite happy to insert the rows to place the filters in above the pivot table, removing the columns from the filtering doesn't then give those rows back. You need to physically then delete. And the same on here. Probably take both back out because I've got no page level filtering at all. Making use of our sales data 2018 with pivots file, we can look at actually sorting the data within our pivot table. Now the data is sorted when you create a pivot table. It's sorted by the columns that you're grouping on. In the case here of pivot 2 that is grouped by country, you'll see that the countries are in alphabetical order. However, that might not be the order you want things to be displayed in. You might like to have the data displayed in descending order of sales, so you can see the country at the top that you've sold the most to. Well, we can achieve that. To control or change the sorting, we go to this little drop down arrow here next to the country, click that, and in here we can see sort A to Z and sort Z to A. Now that will only sort the country, so it'll sort the country alphabetically ascending or alphabetically descending. What we do have though is more sort options. We go to more sort options. In here we can choose to leave things as the default, which is to manually drag items. So you can actually move things around manually, which can actually be quite useful if you want to bring an item to the top, not because of its value or its alphabetical order, but just to highlight it. You can actually grab it and move it. Let's see that in action. So if we click cancel, say I wanted to bring United Kingdom to the top, I would simply click here on United Kingdom, just go just above it until you get the 4-headed arrow there, click and drag, and you can actually move that data value to somewhere else in the list. And I've moved it to the top and everything else just moves down, staying in their current order. I haven't adjusted their order, I've just moved this one value. So you can manually drag them. If, however, you want to control them by their values, we go to more sort options again. We're not going with manual. We can choose ascending or descending. Choosing one of these options, and I'm going with descending, I can then choose from either the field we are grouping by, in this place the country, so I could put them in descending alphabetical order of country, or more importantly, which is what I'm after here, the sales dollar, which is the data column. Descending value of sales dollar. So I'm hoping the country that I've sold the most to will therefore be at the top. Okay, and we see that it is. It was because I manually dragged United Kingdom, but then the others are in descending order as well. So they're now not in alphabetical order of country, but descending order of sales sold. So we have United Kingdom, England, United States, Ireland, Australia, etc., all the way to the lowest selling country, which is Bangladesh. Now we can do that on any pivot table. We could go to pivot 1, click in the little drop down, more sort options. If we went in here for descending, we've got a choice not just of the total sales, but all of the other data columns now. If I don't want them in country order, let's just move this across a little, I could choose to have them descending my total sales, so the country that sold the most will be at the top, and we know that is United Kingdom. Descending of average sales, so the country with the largest average sale will therefore be at the top. That could be quite useful. Highest sales, so the country with the highest single sale will be at the top, the highest value of that single sale, or of total sales, so actually number of sales as opposed to the value of those sales. Well, let's go with that hash sales and say OK. We then see, well, United Kingdom is at the top again with 764 sales, followed by 2 lots of 10, 8, 5, and then a lot of 1s. If we went back into there, more sort options, and change that to be the average descending, then we'll find out which country has the highest average sale. Okay, in fact, it doesn't appear to be United Kingdom. So although they've sold a lot of sales and made a lot of individual sales, they've not been high earners. England, $16.49, has the highest average sale, followed not so far behind by Channel Islands and Spain and the United States. You're completely in control with this sorting. More sort options from the drop-down allows you to then choose manually, ascending, descending. Between the ascending and descending, you can then choose between any of the data values, if you've got more than one, as we have here, to either sort ascending by or descending by. Here we want to look at the best effectively, then we're going with descending, so we get the larger numbers near the top. Now, as well as being able to sort, what you will have noticed, the keen-eyed amongst you, in this little drop-down, not only can I go through this sort option, I can actually remove some of the, in this case, countries from the list. So this is a little bit like the filtering at the level above the pivot table, where we placed a filter above the pivot table. Here you can filter out individual countries from your pivot table if you should not wish to see them. That may be that I don't wish to see United Kingdom. I want to remove that from my list. Better choose England as well, so that I can see the data without these two large values. Okay, those two values are removed. And then I see Channel Islands has the highest average value, or I could even change that to total sales. And we find that United States then has the total sales because I've removed by filtering out United Kingdom and England. So we have that option to filter away individual countries in this case, and then sort by the country or any of the other data values we've been using within our pivot table. Although we've seriously got used to Excel refreshing anything it does by itself, unfortunately with pivot tables this is not the case. Now the reason it's not the case is because the data might not be located just 1 inch to the left in another sheet as we have here in the sales data 2018. It might be located halfway across the world. So refreshing every time it does something is not really ideal, not really a situation you want to live with. So what happens with pivot tables is they only refresh when you tell them to. Now you can trigger them to refresh in a few different ways, but they don't do it automatically. If I went into my sales data here, and let's say, for example, let's go to the top and change a Thailand value here to 200 quantity, 1,600 in the sales. I've gone dramatic so that we can see that it happens. Come back to pivot 2 and look at Thailand, it hasn't changed. So I need to actually refresh the pivot table. Now there are a couple of ways of doing that. We could do that off the right click and you'll see there's a refresh option here. Or we can go to the pivot tables ribbon, analyze and refresh all, and that refreshes your pivot tables. And then Thailand, you can see there, has now responded, 1,604. Pivot table 1, Thailand has got 1,604 and it's updated the other values as well. So we now have 2 sales, the highest sale, and the average is quite high. We actually have to tell the pivot tables to refresh themselves. Now, we can tell the pivot table to do a little bit of automatic refresh in that we can tell it to refresh every time it opens the file. And we do that by going to Options up here on the Analyze Pivot Tables ribbon, and then Options, Data, and here we have Refresh Data when opening the file. So a little tick in there will ensure that every time you open the file, it's using the latest data. So again, you need to balance that up with, okay, I'm connecting to a server on the other side of the world. Do I really want to be updating that every time I open the file? Or do I want to trigger it manually? If you're happy for it to refresh its data when it opens the file, okay. Change refresh on open option. Also change the option for the other pivot table reports based on the same data. So effectively, both pivot tables within this workbook will refresh themselves every time the workbook is opened. Fantastic, okay. Be careful about adding that option in based on where your data is located, but it's a good way of making sure that when you open the file, at least you're looking at the latest pivot table. Other than that, you need to make sure that whatever changes are made in the data, you actually refresh your pivot table, which involves right-clicking or going up to the refresh icon on the pivot tables ribbon. Now we could add a keyboard shortcut to do that refreshing for us, which might make life a little quicker for us. In order to do that, we need to create a macro and then assign a keyboard shortcut to that macro. So we come down to record new macro. I need to make sure the macro's got a sensible name, so I'm going to call it pivot refresh. Save it in the personal macro workbook so that it's then available to me whenever I'm using Excel on this machine. Assign a sensible keyboard shortcut that's not already in use. That's usually the trickiest part of the decision. I'm going to go for Shift Q. So controls are given, you have to have control in your keyboard shortcut, but then I've added Shift and Q, and in here, a little description. refreshes all pivot tables. Got to add in current workbook. Okay, macro then starts recording. I'm not actually going to record doing anything. We're going to edit the macro ourselves. So I'm going to go down and stop. So I've created that macro that actually does nothing. I then need to edit the macro. Because I've stored it in the personal macro workbook, I need firstly to unhide the personal macro workbook. I go to View, Unhide, Personal. Then I can go to Developer Macros, and there's my macro, Pivot Refresh. I go into Edit. I can see the keyboard shortcut I've assigned, Control, Shift, and Q, my description and my name, but it doesn't actually do anything yet. Come down here to the next blank line, and it's a single line command, active workbook dot, and you can see then I've given a list of commands, and if we slowly type in refresh, it comes up with refresh all. That's the one I'm after, and return. And all return does is just add in the correct camel case for your items. So active workbook gets capital A, capital W, refresh all, capital R, capital A. I can then close the developer VBA window, then hide my personal macro workbook by going to View, Hide. I'm then back here. Let's see if this works. Let's go choose another country. Well, actually, let's make that Thailand order quite big as well. 890, 100 items. Have a look at my pivot table. It hasn't responded. But if I then run my keyboard shortcut, Control, Shift, and Q, you'll see that Thailand values then refresh, both in pivot table 2 and in pivot table 1, because the average is now shot up and the total has shot up. As long as you are aware that pivot tables do not automatically refresh themselves, you can then refresh them when you need to, or you can trigger them to refresh every time the workbook opens, or we can do as we've done here, created a little macro that does the refreshing and assigned it a keyboard shortcut so that we can then trigger the refresh very quickly, other than right-clicking or finding the right menu and choosing the right option. Once you've created a pivot table, you can pretty much trust that Excel has done its job properly and summarized or averaged or totaled or counted what you've asked it to. However, sometimes the numbers aren't quite so believable and you perhaps want to find out where the numbers have come from, which would involve going back to the raw data, perhaps applying a few filters and figuring out what Excel has done. Well, it's a little easier than that. For example, in our sales data 2020 pivots, it may be that I'm not too sure how 164.89 has come about as the total sales for England. All I need to do is double click 164.89 and Excel will drill down into the data. And what it does is it effectively filters for me those values that have been used to make up the 164.89. And it makes an extraction from the source data, which here is our sales data. I just need to widen that column. If I highlight the sales values, I can see that they add up to 164.89 down here in the status bar. Because it's effectively made an extraction of the data from the source data, there's nothing to now stop me using this information to create another pivot table, create a chart, or even move the sheet into a new book and email it to someone else for perusal. And this will go for any numbers at all in your pivot tables. So back into here, what about the 2,490? Double click, and the Thailand values are extracted again into another new sheet. So that sheet can be taken somewhere else, deleted when you finish with it, filtered on, create a chart, etc. Even in pivot 1, where we've got lots of different numbers going on, if I were to pick on a number and go, well, what about the United States, 2988, double click, it brings through all the United States data, which has been used to build these numbers in pivot 1. So you choose a number in your pivot table, you're not too sure how it's come about, double click, an extraction is made of the data. So every single column, not just the columns that have been used to do the calculation, into a brand new sheet. So it's an extraction, it's not a filtered result. The sales data itself remains totally untouched. You have a new sheet with the extraction in, so that you're then free to carry out other information. And this goes for any number. So it's any number within the data area and any number in the summary. If I were to double click the total here, I get an extraction. Well, because I've double clicked the total, my extracted data is actually exactly the same as my raw data. I really find these drill downs quite useful if I'm connected to an external data source that I can't read directly. Then all I need to do is from my pivot table, double click a number. It will make an extraction into Excel for me, creating me a new sheet. I've got a few now that I'm then free to manipulate further. That's the drill down capability of Microsoft's pivot tables. Now, if you're creating pivot tables for other people to use, and you don't want them to be able to drill down, or even to drill down accidentally with a double click on the screen, then you can actually turn off, you can disable this drill down capability. So back in the pivot table you want to affect, make sure you are in the pivot table. From the Analyze ribbon, we choose Options and Options. And then from the Data tab, where it has a tick in Enable Show Details, we simply remove that tick. OK. And then when you attempt to double click a number, we cannot. We simply get a message that says we can't change this part of the pivot table. There is no drill down capability now on this particular pivot table because we've disabled it. So if that happens to you and you want to drill down, you can turn it back on by going to Options and Options, Data, make sure the tick is in Enable Show Details, and then you'll be away with each double click on a numeric value within the grid to then pull out an extraction of data for further manipulation. Let's take the working file Sales Data 2018 pivot and have a look at how having a pivot table makes it easy to format the pivot table. That makes some kind of logical sense. A bit like the tables, Excel has already provided the functionality for formatting pivot tables. As long as you click into the pivot table first, on the choice of pivot table tools, we have two sub-ribbons, Analyze, which we've been using, and then Design. Now, the Design sub-ribbon has a section called Pivot Table Styles. Current style applied to your pivot table will actually be highlighted with a grey box. You can see that one there. It's just got a grey box around it. Now we can expand this so we can see more, and we have a number of categories of styles. We have a light category, a medium category, and a dark category. You simply select the style that suits your data, and you can see as you move through them, applies the choice. That blue one's quite nice. Let's go with that one. Now, having made a selection of the style, you can then choose what you would like from that style, and there are 4 options here for removing or applying in the tick boxes. I already have a tick in row header. That's why the row header is different from the other rows. For example, let's go down and find one that is different on the left. These are different. See there that there's a slightly different color to the left-hand side. So let's stick with one of those. So I've chosen to have the row headers, therefore the row headers are different. If I take that off, then they don't get distinguished. The column headers are chosen to be selected, so they're different. Again, if I turn that off, they don't look any different from the rest. I could have both of those on. I also have the option for banded rows, which means each row is a slightly different background. That makes it a little easier to read. So that's in place. And even banded columns, so every other column is a different color. Now that doesn't quite work in this style, so I'm going to turn those off, probably turn off row headers as well, which leaves me with a pivot table looking like that. Now if I change to a different style, like the dark blue one, then it remembers that I wanted banded rows, but this particular style option doesn't have banded rows within it. You can see it's all solid blue. That one does. So I have a light blue, dark blue. It has column headers. Does it have banded columns? Well, they have white lines between, which is quite useful. I'm going to leave that on. If I had row headers, that would probably make no effect. So you've got to look at what the style box offers to see which of the 4 actually will apply. In pretty much all cases, the column headers are different. You can see that they're usually bolder and darker all the way across, regardless of the style you choose. That green one, for example, too green. That one there, banded. Now, banded with a large amount of data does make it easier to follow across a line or down a column. So you make your choice. You choose your style from this drop-down box here, and then you choose what you would like from that style. So choice of row headers, column headers, banded rows or banded columns, assuming they are available in that style, and then you're left with your formatted pivot table. Should it then increase or decrease in size, only the rows used by the pivot table are formatted. You're not left with some green rows here with no data in if the data gets restricted by, for example, filtering. If I were to just choose a number of countries down here, you can see I'm still only presented with the style, but only on the pivot table. It doesn't leave all of these rows here, now no longer used, as alternate greens. So your formatting instructions are to the pivot table, regardless of its size. So you make those changes in design, color scheme chosen, selections chosen from here. If you want a fairly plain one, you can go for the top left-hand side light, which is as plain as you can get. And if you take the ticks off, you're left with just the little borders around the outside. So you're in charge. You're completely in charge of the pivot table, and every single one of your pivot tables, even if they're in the same book, even if they're in the same sheet, can be formatted differently. This isn't a universal setting for all the pivot tables in a workbook. Each pivot table can be formatted differently. Let's take our sales data 2016 working file. It already has some data within it. We've already given that data a name, so we can jump straight into creating pivot tables. Let's create a new sheet, and in here I would like to insert a pivot table. So that's insert pivot table. The pivot table or range is actually my named range called data. Okay, because I've named the range correctly, up on the right hand side appears the column headings for my range. Our aim with this pivot table is to look at adding multiple fields into either the row or the column headings. Now this is achievable, but it makes more sense if the data has a natural breakdown. For example, here in our data, we could have a double heading of country followed by city. And we can see it breaks down into unique countries. So it firstly groups by country and then by city. And you can see naturally breakpoint there, Australia, and the cities that fall within it. Bangladesh has 1, Belgium has 3, Channel Islands has 1. And we can go down the list and see that some countries have more cities than others. But that only logically works because the data has cities within countries. If I were to move these the other way around, which I can do by dragging, then it groups by city first and then by country. Well, each of these cities only belong to one country, so then the data doesn't make sense. When you have multiple columns in your rows or in your columns, you need to make sure that they are in the logical order, so they break down, effectively drilling into further information. And I could do the same with this information in the columns. I could put country there and then city below it. Not quite as easy to read horizontally, but it's still doing the same breakdown. There's Australia, there's the cities within Australia. There's Bangladesh, the cities within Bangladesh. And you'll see that until we control our subtotals, we get a subtotal for each country. If I were to add in a quantity there, see we then get quantity for each of the cities separately, and then a grand total for Australia. And the same for Belgium, Channel Islands, etc. Although they do look and make more sense if they're in the row section. Then you can see things easier. Australia and its cities with the cities' totals of quantity, and then a subtotal quantity for Australia. Right at the bottom of the table, we then get our grand total. That's multiple columns from your data that you can then use in your pivot table if the data makes a logical break. Now, sometimes the pivot table does a bit of work for you. So let's leave the sum of quantity in the middle, but come back to the date field here. Now the date field, if we actually look at the data, contains, naturally, dates. So individual days when particular sales have been made. If we now bring the date field into, let's say, the rows section, you'll see that we don't get an individual row for each date. We actually get some clever grouping going on that I didn't ask for. I'll just move this up slightly. We can see Excel has already grouped things by years, quarters, and then the actual date. So in my pivot table, I see 2009, 143 quantity sold, but I can break that down and see that broken down by quarters, and then I can see that broken down by actual months. So we can see February, March, April, May, and June. Although the actual column contains the date field, Excel has spotted that the pivot table has done some work and created years, quarters, and date. Now, if I don't want the quarters in there, I can drag the quarters out, and it will leave me with years and date. Now, date is actually the month. So I go into the field settings and change date there to say MTH for month. Okay. And then that makes more sense to me over here. Now I have two groupings within the pivot table that I didn't have to create the unique data for. I didn't have to go back into my data set, my sales data here, and create 3 more columns, one for the year, one for the quarter, and one for the month. Pivot table has done that work for me. Once they've been created, what you will then notice up in the upper half here is we have our data, and the quarters and the years and the month have now suddenly appeared even though they do not exist in my raw data. Excel has created those. Just as soon as I use the date field in a grouping, so in the rows or the columns, Excel then says, aha, you don't actually want individual dates because there's a lot of individual dates. With a date field, you probably mean years, months, and quarters potentially. So it creates those groupings for me that I can then use in my pivot tables. That's adding multiple columns into the rows or the columns. If there's a logical breakdown in the data, such as we had country and then city, then it works quite well. If you have some date fields, then Excel will do the work for you and create this grouping by year, by month, and by quarter, so you can make use of those as multiple row headings or multiple column headings. If the breakdown isn't natural and doesn't make sense with the data, then multiple columns in your pivot table will just make it impossible to read. As long as you put some forethought into your planning for multiple rows and columns, then the pivot table will do the work and do the summarizing for each of the subsections within your main field that you're splitting down by. Let's take the working file Sales Data 2016 Pivot that deals with the same 2016 data we've already seen, but actually has a pivot table already in place. Now that pivot table has column headings that are countries. I've applied a filter, you can see the little filter icons on there, just so that we have less columns going across. So we're only seeing the values for Australia, England, Spain, United Kingdom, United States, and USA. Down the left, we are seeing all the years that sales have been made, and that's actually a group that we can then expand out to see the monthly totals within each year. So that's 2009 months. And if we choose on 2013, those are the 2013 months, and they go across and we see totals that each person has spent, or each country. The topic now is grand totals and subtotals. By default, you already get grand totals when you create a pivot table. So you can see here, each of our columns is totaled up at the bottom, and each of our rows is totaled up across. So we can see the total sales for any given year, so 2011 for example, 18.18 and 54 cents, or we can see the totals for any particular country. So we can go for Spain, 12.98, or United Kingdom, 5,528 and 45 cents. Now if you don't actually want totals on any one of your given pivot tables, you can turn them off. So although they're there by default, you can turn them off by making sure you're in the pivot table, doesn't matter where you are. Go to the pivot tables specific ribbon. Over here on the left, we have an options button that if we choose, we then get further options. So if we choose that, in the options for this particular pivot table, we have totals and filters. And here are our two ticks that are already in place. Show grand totals for rows, show grand totals for columns. If we don't want either or of those, we simply remove the ticks. Say I didn't want the grand totals for the rows, I would remove the tick and OK, and then the grand total disappears from the end here. That's options, totals and filters. Let's take the bottom column totals off as well, and then that bottom row goes. So they're all under options, which is in the drop down on options, or just click the options button there and it takes you straight in. Totals and filters, and you can either turn these little ticks off or these little ticks on. Okay. And that's what controls whether you get this grand total at the end or a grand total at the bottom for each of your columns and each of your rows. Now the subtotals is slightly different. That deals with each group. So here we're grouping by the year. And if I wanted, for example, subtotals within here, you'll notice that when it's compressed, I get the subtotals. So I know that in 2009, United Kingdom spent $650. But when I expand, I don't see the subtotals. I just get the individual month totals. If I want to expand all of these in one go, I could just go down and click each of the pluses. Expanding a single year is clicking on the plus. Expanding multiple years, we can use this icon here on the pivot table tools ribbon. I just click plus there for expand, and that expands them all, and the little minus compresses them all. So you have these two icons to do all of the groups and condense all of the groups. But to do them a year at a time, a group at a time, we click the plus. And you can see that only then expands 2011. Now to get subtotals for each of these groupings, I simply select any value within the grouping and then field settings, still on the pivot tables ribbon. In the field settings, we have a section called subtotals and filters. Well, it's the subtotaling we're interested in. Currently it's none. I could choose automatic and effectively allow Excel to decide what summing function to carry out. And usually if it's numerical, it will choose sum. If it's text values, it will choose count. Or you can control it yourself. Let's say actually custom, and I want it to sum, or I want it to count, or average, or max, or min, or product, or count numbers, or standard deviation. Let's go with the straightforward sum. Okay, and then you can see the subtotals now appear even when the group is expanded. So if we choose 2010, 2010 expands, and we get the subtotal, the totals for 2010. Now notice they are at the top. If you want it at the bottom of each group, which is sort of logical because you tend to add downwards, then you would go back to the field settings option, choose layout and print, and remove this little tick here that says display subtotals at the top of each group. And because you've chosen to have subtotals, the only place left for them to go is at the bottom. If I say OK, you can see we have 2010, each of the values, and then a sum for 2010. And if I scroll down, 2011, also at the bottom. If I expand out 2014, for example, it too will be at the bottom. The field setting is for the whole of that grouping, so the whole of the years in effect. If you quite like them at the top, go back into field settings, layout and print, put the tick back in, OK, and they are then back at the top of each grouping. So you see 2014 and the totals, which sort of makes sense that they are on the same line as the actual grouping name, but you don't have to have it that way. You're in charge of grand totals and subtotals. Grand totals are controlled by the options of the pivot table, whether you want them or not, for every single row or every single column. The subtotals are controlled by selecting the grouping that you're in and going to field settings, then controlling what kind of total you want to take place. It may be that I want the average, for example, not the sum. Okay, and then I get the average values at the top here. It is even possible to add more than one summing value. Under the same section, field settings, I could choose sum, I could choose count. So I've got 3 summing values there. Okay, and now they do end up at the bottom rather than the top, because it has to distinguish between them. So I've got 2010 sum, 2010 count, 2010 average, and the same for all the other years, because anything you add to any one of the groupings applies to all of them, because that is the field that you're setting the value for. 2009, for example, a sum, a count, and an average. That's field settings to control the individual grouping sums, calculations. It may be that we perhaps just want the 1. If you have the 1, you can then leave that to display at the top by leaving this tick in, or keep it at the bottom by removing that tick. Bear in mind, if you try for 2 or more calculations, they will always go to the bottom of the grouping anyway. So that's totals and subtotals within your pivot tables. Now, we saw earlier that we can filter the result of our pivot table by adding one of the columns into the filter section here that then appears above the pivot table, so it acts as a top-level filter. Now, you can filter the data within the pivot table without having a top-level filter in place. Let's take the sales data 2018 pivots file, and on the sheet pivot 2, we'll have a look at this pivot table. This is a grouping by country and sum in the sales for each of the countries. Now, for any column that you add in, so for example here the country, you'll get a little drop-down arrow. In that drop-down arrow, as well as being able to sort, which we have here, and we've seen this previously, we can do a quick filter by removing ticks from values we don't wish to see. So I could remove the tick from select all and then go back in and individually select those countries that I would wish to see. Okay, and those are the countries I see, and a little filter icon is in place. Alternatively, let's put all those back. We can do filtering by the label or by the value. And the label is what we're filtering by, so in this case the country. So I could come across to the label filters and choose one of these comparison options: equals, does not equal, begins with, does not begin with, all the way down to between and not between. With my countries, I could say, well, begins with, and put an S. Okay. And then I'll see all countries that begin with S. So I get Scotland, Spain, and Sweden. Again, the little filter icon's in place. If I want to see what's happening, I can hover, and it tells me a label filter has been applied. Country begins with S. In the drop-down filter, I can see here there's a tick next to label filters. So that's the kind of filter is applied. And as I come across, there's then a tick against begins with. So I have indicators all over the place as to what kind of filter is being applied. The filter icon tells me there is a filter. I then come down here and see there's a tick. I then come down here and see there's a tick. So I have a begins with. I could then change that begins with if I want. Let's try D. I'm not sure if I have any countries beginning with a D. I don't, so I get an empty pivot table. So back in, label filters, and then I could choose another. If at any stage I want to remove the filters I have in place, there is a clear filter from country option here, or clear filter option here, and that will clear any label filters I have in place. And then all my countries come back. Now, as well as the label filter, I have a value filter option, and that will filter out rows of my pivot table based on the values within the sales section. Let's go for greater than, and you can see here it's choosing the sales is greater than. Let's choose 1,000. Okay, and I find that only the United Kingdom has spent more than 1,000. Perhaps we ought to change that value filter, greater than, notice where the ticks are, and drop right down to 50. Okay, and then get a few more countries. England and United States now appear. So in my pivot table, I can filter simply by removing ticks from values I don't want, or I can go into the label filters and choose one of the many comparison options to filter by the actual text within the label, or value filter and choose again one of the many filtering comparisons to filter by the actual data that's being used. If I want to clear the filters, I clear the filter there and everything comes swimming back. Now in pivot 1, where there are a number of columns, I then go to the country drop down and choose value filters, and let's say is a greater than. I now have a choice of which of the columns to deal with. So is it the total sales, average sales, the highest sales, or the hash sales, so the number of sales. Let's go with average is greater than 5. Okay, I'm then presented with the country that has an average sale greater than $5. I can see down the average column, they all have values higher than 5. So I know there's a filter in place. I know it's a value filter. I know it's a greater than filter. What I can't see until I click is the actual value that I'm checking. And then I see once I'm in, I'm checking the average value is greater than 5. But you see you can apply filters to any of the column values, any of the data values that you're using within your pivot table. Okay, and into the filter, clear filter to remove them. Now in pivot 3, I just wanted to show you another option. Because we're grouping down this left-hand side on date values, if I go into the filter option here, also notice there's a filter option for the columns because we're using a data field across there. But the date one, come down to date filters. It doesn't say label filters anymore. It says date filters. And notice the pop-out is not the same. We don't have the same less than, greater than, more than, etc. We have lots of date options. Tomorrow, today, yesterday, next week, this week, last week, next month, this month, last month, next quarter, this quarter, last quarter, next year, this year, last year, year to date, all dates in the period, and you can pick a month of the year. So you have a lot of built-in date options if you're dealing with data in your pivot table, which will make life a lot easier and a lot quicker to carry out any kind of filtering that you want to take place. Maybe you're trying to summarize sales data for last month. Well, you can pull all the data into your pivot table and then come and do a filter. Date filter, last month, click, and you'll see all of last month's data. Obviously, none of these filters here will work with our particular data because it's based on years and years in the past, in fact, not just this year and last year. But we could still use the between, the after, before, and the equals. So I could say before is before, and there's a little calendar option here. So any sale that is before, let's go for the end of 2014. Okay. And then we see that 2015 is filtered out. I have my little filter icon as before. I know it's a date filter. I know it's a before date filter. And if I care to hover a little bit here, the pop-up subtitle tells me that it's a date and it's before December 31st, 2014. Just like the others, I can clear the filter and get all my data back. We can filter on any of the column values and any of the data within your pivot table to get exactly what you're trying to achieve in this particular pivot table. So it may be you only want particular countries, or it may be that you only want particular sales above a certain amount or between two values. Or in here, it might be that, like we did, we looked for those whose average sale was greater than $5. All kind of data interrogation that will help you carry out your job to a better degree. There are a number of additional pivot table options that are certainly worth exploring, and we're going to do that with the Sales Data 2018 Pivots working file, and then the actual pivot table located in sheet Pivot 3. Now in here, you can see that we have the years grouped down the left that then expands into months, and then the countries across the top. Now the additional options to explore are actually in the pivot options. So we need to be anywhere in our pivot table. We'd have to be at the top, the bottom, or the middle. Anywhere will be fine. Onto the Pivot Table Tools context-sensitive ribbons. And the Analyze one gives us our extra options here. Now we have visited this dialog box already, change a couple of things, but we're going to explore some more things within here. So we click to activate the Options dialog box. And the first thing to look at here is the ability to add in something. In my case, I'm going to actually add in zeros for empty cells. In this particular example, there are a lot of empty cells because we haven't made any sales to Australia in 2009 or 2010 or 2013 or 2015. I'd like to populate my pivot table with zeros. There is an additional option here for error values also, You could do the same thing. We could enter a 0. I'm not actually going to activate that, but we could. When I say OK, I then get lots of zeros in the cells that have no data. It just helps to complete tables, so to speak. Back in options, that's this little bit here. Another little thing in here is to remove this tick, auto fit column widths on update. Because what tends to happen, let's say OK, every time you refresh this, and that one could be a bit narrower, and that one could be a bit narrower, and then you refresh, as well as bringing the data in, auto fits all the columns again. All the hard work you did in keeping the column widths the same is then undone. But we can make sure that the column widths aren't altered by removing the tick, which is there by default, in the auto fit column widths on update. Also within here, if we go to display, if we're not using these labels here, so years, date and country, for example, we can remove them. If I say OK, they're then taken away. So if I'd not used them as labels, and by default you see that Excel puts in things like sum of sales or count of country, and it might be that you don't want that at all, then you can just say let's not display them. It's obvious that these are countries and it's obvious that they are years. That's in options, display, and I've just removed this tick here. If I place it back in, another one you might want to remove is this top option, expand and collapse buttons. That's these little pluses down here. If I take that away and OK, as well as my field titles coming back, the plus is gone. Now that doesn't mean you can't expand, because I can just click in and use the plus here, and that does the expansion for you, and the minus does the contraction. But you don't get the plus and minus, and it just makes it look a little neater. Perhaps it hides away the ability that you can drill down into another subgrouping. So that's options, display, and this little tick from here was removed. I'm going to put that back in. Another little option that is quite useful is to return to the classic pivot table layout. If I say OK, it makes things look a little clunky, but it does mean that I can move fields from rows to columns, or vice versa, without having to use this little section on the right here. So I can take the country field there, I can just grab the edge of that, drag it along to the left, and you can see how the icon next to the cursor has changed shape. I let go, and then the country becomes a grouping down here, but before the year. I actually want it to the left of the years, so it groups by the country first and then the years. We get a slightly different layout. I can just grab fields and move them into a different section, which is the same as over here, dragging them from columns to rows or rows to columns, or even up into the page filtering section. It means that the pivot table, when you're clicked in it, does look a little clunky, which is why they've taken it off by default, because you've got this option here now where you can just move country into rows there, much quicker, much smoother, and you don't have the clunkiness of over here having to drop it in the right place. But if you want to work on the fly with your data, it is quite useful. So that's options, display, and turn on or off the classic pivot table layout. And then the last couple of little items within here are printing. You want the little plus and minus buttons to actually print. They don't by default. If you do, then you can put a little tick in. That's assuming that you're going to print your pivot table. And then under the alt text, if there are any chance that somebody using your Excel file with a screen reader to tell them what's occurring, then in a pivot table we can add a title and then a description. So the screen reader will read the title out to allow the person to decide whether they want to see the full description. So I could say pivot table of sales summary. So that's what will get read out. And then the description might be, this table contains sales sums for 1, 2, 3, 4, 5, 7 years, or the last 7 years. So those are a few extra little options we've had a look at, all accessed by selecting the pivot table by clicking in with it, and then options on the pivot tables ribbon brings up the options dialog box, allowing you to turn on or off any of these little capabilities that we've just reviewed. One great addition to the pivot table armory is the data slicer. Now how this works is it allows you to have floating filters, really, is probably the best way to describe it. I'm going to take the sales data 2018 pivots as an example, and our pivot 1 sheet here, which has our countries, total sales, average, high sales, and hash sales. Now to actually get yourself a data slicer to start with, we just click into the pivot table, go to pivot tables, tools, and analyze, and then here we have the option for insert slicer. When you want a new slice, it gives you a choice of the existing columns that you have in your data. It may be that I wish to take sales rep, for example. I already have the country within the pivot table. I could perhaps go for city or date, but I think sales rep would make the most sense for what we're about to do. Okay, that then creates this little floaty area, which I can move, so it's not interacting with the data. And what this is it's effectively a filter for this pivot table. For example, I can see all my sales reps, but say I just wanted Sue's data, I would just click on Sue, and now this is being filtered by Sue. If I want to see more than one sales rep, then I can hold down the Control key and pick up Mike and Jim and Bob, and we see all of their data. So in the pivot table, we don't actually see any of this sales rep information, we just see it in the slicer. Now if I activate this little option here, that saves me using the Control key. All I need to do then is click on or click off for any particular salesperson. So Jim's on, click him, turns off, click him again, turns on. So that little option allows me to stay with the mouse, not needing the Control key or the Shift key. I simply click those sales reps I wish to see and click those sales reps I do not wish to see. And then the only other option here is to clear the filter completely, and that brings me back all the sales reps. So the slicer is a filtering tool, but it floats, unlike the filter that we could place at the top, which will also allow you to multiple select, but it doesn't give you this graphical interface, a nice little floaty slicer. And I can add more. So I click into my pivot table and insert slicer. I could choose country, for example, even though I already have it in my pivot table. And that gives me two slices then that are floating around. So it has a scroll bar, but I can resize. I don't know if that'll all fit on the screen. No, they still need a scroll bar. But it works the same way. Let's turn on the multiple select option so I can turn off Belgium, turn off England. Now here with this slicer, you physically see the right lines disappear. So if I don't want Germany, I just turn it off. This time, this particular slicer is instead of going into the filter drop-down and making your choices in here. You're using the slicer to decide what you want to see. Turn off Laos, turn off Australia, turn off Bob, turn off Alice. And graphically, I can see the information that I'm getting. These are the countries I've not filtered out, and these are the people that I've not filtered out, the ones in blue. Now there are some controls over your slicer. If I click on the sales rep, for example, we have a Slicer Tools Options context sensitive ribbon, and we can even change the colors. Maybe that one to bluey one, I want a greeny one or a grey one, or a bright orange one. Ooh, that's nice. Notice how that only affects this slicer. This one remains the default blue. I would need to then click on that one to change that one to a different color scheme, perhaps green. So they're now quite bright, but they're still doing the same effect. They're still filtering. Now at the moment, they're only filtering this pivot table. I could actually get these same slicers affecting my other pivot tables by going up here to Report Connections, which is within the Slicer Tools Context Sensitive ribbon, and it will list all my pivot tables. I've got pivot table 10, 11, and 2. It tells me what sheet they're on if I'm not sure what pivot table is, so it's the one on the other two sheets. Let's activate it. Okay, so this slicer is now filtering the other two. So in pivot 2, although I can't see what the slicer's choosing, if I deliberately only choose Jim, in here I see what Jim's doing. In pivot 2, I can see that that's just Jim. And pivot 3, that's just Jim, because there's only one country, Scotland, and then a little bit of United Kingdom. I've connected the same slicer to more than one pivot table. And we can do the same with the other one. We select Slicer Tools Options, Report Connections. It will list all the pivot tables within this workbook, and you can attach your slicer, your filter, to any one or more than one of those pivot tables, even if you cannot see those pivot tables on this sheet. So this filtering tool is much more powerful than just using the top level filtering within the pivot table itself. We can bring them all back, and then that's affecting these as well, because that one's connected. This one does not affect the others. So with everybody back, although I don't have Australia and Belgium selected here, they are in here, Australia and Belgium, because I didn't make that second data slicer control any of the other pivot tables. So just another option. I really quite like them because you can change the color of them, you can make them control more than one pivot table at a time, and they're just quite quick and pretty. If you no longer wish to have one of the slicers, then you can remove it just by simply selecting it, because it's just an object, and pressing delete on the keyboard, and that particular slicer will disappear. Notice, however, although I've taken it away, the filtering is still in place, and I would need to go back in here, bring all my countries back. So although the slicer was removed, did leave in place any filtering that was taking place due to the slicer. Be a little bit careful when you remove a slicer that you've actually brought all the options back like we have here and not leaving one of the filters in place. So we select, delete, and the slicer is gone. But they're easy to obtain. Make sure you're inside the pivot table, analyze, insert slicer, choose the field you want to act as an additional filter, and then you're away. You can move them, you You can resize them using the handles on the corners. You can attach them to more than one pivot table. Great little tool, fantastic addition to your pivot table armory. We've seen pivot tables in action, how to make use of them, how to group and filter and sort, lots of little useful things that we can do with our pivot tables. But the last very useful thing that you can do with your pivot table is having the ability to connect it to an external data source, such as Microsoft SQL Server. When you're in Excel and you're connecting to data within Excel, you are limited to the number of rows Excel can hold. Now we know that that's 1 million plus, but if you can connect to an external data source that can hold more than 1 million rows of data, then you can increase the capability of your pivot table, interrogating and summarizing that data. So how do we connect to SQL Server? Well, the first thing you need to create is a connection file that Excel can open. We can do that still from within Excel. We go to the Data tab, come along to the very left-hand side where it says Get External Data, and then we have a number of options for where that external data might be. We want from other sources and then from SQL Server. We're going to connect to an external database server. And in order to do this, you will need to have access to an external SQL Server database. If you don't at the moment, then you can watch and we'll cover pitfalls. In the server name goes the actual server name for your SQL Server. So it's web name effectively, which in most cases tends to be an IP address of some description. You will then need to log into that SQL Server. If it's all on the same network, there is a good chance you will use Windows authentication. If you're actually connecting to a SQL Server that's held in the cloud, then you will not use Windows authentication. You will use a SQL Server login, for which you will need to know the username and obviously the password. So the 3 bits of information you need to know to be able to make this connection to the SQL Server in the first place. That is the name of the server, the username you're going to be allowed to use to connect to that server, and then the password. Assuming you have all 3 bits of information correct here, when you click Next, a connection is made. Then we're in the second stage of the wizard. We need to choose which of the databases in the server we will have access to. Now, depending on the login you're given, will depend on what you see here in this list, and then ultimately which of those databases you can actually have access to. For the purposes of our example here, we're going to go with shop. Once you've chosen your database, below there in this section here, you will see all the views and the tables that you can then access. Everything is listed in there. And again, for the purpose of this, I'm just going to go with the top option there, View Purchases Made. So from this list, you can choose any of the views or any of the tables from the selected database here. If you really know this database well and are quite happy, you could enable selection of multiple tables, which will then allow you to pick more than one table for you to provide the data to your pivot table. But I must stress that would require you to really know the database well. So I'm going to remove that and make a choice of View Purchases Made. Then we will save the connection file. This is the file name for it, and all it's done is it's taken the SQL Server name plus the database name plus the view name. So I really ought to give that a much more sensible name and call it My Training Connection. This is just the connection information. The extension for that is ODC. You can even at this stage choose to save the password in the file. Only advisable if you know this file is not going to leave your machine. It's just for you, for your own use, and you want to save the password because it saves typing it in every time you use the file. We could give it a much more friendly name as well. I'll leave the name of the view on and just call it shopdb and then finish. What do I want to do with the data? I want to place it in a pivot table report. Okay, I then get my pivot table area, and this is my list of columns just as we're used to when the data is in Excel. So I could pull in, for example, the date closed into the rows. And as we've seen already, it then gives me the year and then quarters. I'm going to remove the quarters. I have the year and the months, and then simply drop in the basket and change that to count rather than sum, so that it counts the number of baskets. So that's the number of basket purchases made for each year. And we can see that things have been slowly dropping since 2010, which is effectively the peak for this particular company. Now the file we've saved, ODC, is saved on your machine. If you look in your data sources, which is likely to be in your documents area, depending on your version of Windows, and we can see there the ODC file, mytrainingconnection.odc. So should you need this same connection on another machine, you can simply email that across or take it across on a memory stick and then go and open a connection using that connection file and create your pivot table straight away. I will look shortly at how you create a pivot table from an existing ODC file shortly. Just for the moment, there is one other thing to explore here, and that's under options for this pivot table. And if you go to data, then you can choose refresh data when opening the file. So when you open the file, it will automatically try and connect to the SQL server. That might or not want to be an option you have. If you want to keep the size of this Excel file down, then remove the tick that says save source data with file. Otherwise, it will download all the data that's feeding this pivot table and keep it so that it obviously works a lot faster, but it will not be the latest data. You would need to force a refresh using the right click. Keeping the file down by removing this tick, causing it to refresh and therefore connect to the server again every time it opens is this tick. Either or of those can be on or off, it's down to your personal preference, but they're changed in the options for the individual pivot table and then the data tab. So this is connecting to an external SQL Server database. Let's explore creating a pivot table where somebody supplies us with the data connection file, the ODC file. Now that ODC file could be connecting to any external database at all, SQL Server, Oracle, Fox Pro, Access, anything really. All we need to be able to do is open that connection file, pull in the data that we want, and create our pivot table. The mechanics are insert pivot table, same as normal. Use an external data source rather than selecting a table or a range. Then we choose the connection. Now, if your Excel has managed to spot the connection existing on your computer already, which it might do, listed here, mine has in fact, training data, then we're one step ahead. If not, you simply click Browse for more, and it will start in your data sources, but there's nothing to stop you then going through your file system and trying to find the ODC file. Perhaps somebody emailed it to you and you saved it somewhere else instead of my data sources. Not a problem, it will still work. It doesn't have to be in this folder. I'm going to go with my training connection. Then I need to tell it where to put the pivot table. The existing sheet's fine because there's nothing else there. Okay. Now because the password has not been saved in the ODC file, which is highly suggestible and recommended, I need to know the password. But I don't need to know anything else. I don't need to know the username or the actual server address. That can all be created for me in the ODC file. Okay. And then I'm presented with my pivot table layout and the columns from the data that has been set up in the ODC. So whatever the name of this particular view or table is, I don't know, but really I'm not that interested. I'm just interested in making use of the data. So from this particular data, I'm going to pull down the date field, closed, remove the quarters again, drop in the total price to here, which is assumed sum, which is what I want. I want it to add up the total price. We'll just do a little bit of formatting on the number, currency, okay, okay. And there's my total sum of price, the total value of everything sold. So we can see that there's a marked decrease as the years have passed by. Now, if I do another insert pivot table, choose an external data source, choose connection, now it knows this one is a connection within the workbook. So it's already stored within the workbook. If I want to add another one in, fine, I choose it from the list or I browse for it, open, tell it where to put the pivot table, current sheet's fine, okay. And again, password's not been stored in this connection file, so I need to know that. Notice the records are now loading. There's quite a few of them in this one. And we'll have date started again, removing the quarters, total price, assumed count rather than sum. So I need to go in there and change the sum. At the same time, let's change that into dollars. Okay, okay. And there we see in this particular case that the sum of total price actually has been increasing over the years. Now, these two pivot tables are connected to external data sources. They're connected to different external data sources. And I can see what these files are, at least by going to data and connections. And we see the two connection files here. One called shopdb, view purchase made, and one called training data. I can visit that information through properties. And you can see here we have a number of extra options. Enable background refresh. So it will connect to the data in the background. So you're not physically telling it to refresh, it just keeps having a look. Or we could physically tell the pivot table data to refresh every so many minutes, or refresh when opening. Lots of little connections that are possible for this particular connection to your SQL Server. Definition tells you the connection string there, table, and the command text. So the same for the other one. Cancel, I want to make a connection there. Properties, I can do the same thing again about the refresh of the data. and I can visit the definition, so the connection string information. All of this data is now stored with this particular workbook and will stay with this workbook until you remove those data connections. So connections has an option of remove, but it will warn you if I try to remove that. It'll say anything using this data source obviously will no longer work. So my pivot tables won't work. Well, certainly the one connected to this particular data source. So it's not advisable unless you happen to have built up quite a history in here and you don't need some of them anymore. But those connection strings are stored externally anyway. So even if you remove them from this particular workbook, they're still stored as ODC files in your data sources in Windows. Here we've seen how we can use an external data connection, the ODC file, to create a pivot table and connect to that external data source without actually needing to know the structure of the data source or how to get hold of the data source. The only thing we need to know, if it isn't already saved in the ODC file, is the password. And then after that, we are in charge of making our pivot tables look and make sense. Welcome to this chart section. What I'm hoping is that this first lesson is going to feed mainly as a recap on how to create charts and quickly. We have here the sales data working file. It has 3 sets of data. The sales data itself in the first sheet, then 2 effectively summarized bits of country sales, which gives us the total sales by country, and then year sales. Let's take the country sales first. If we want to create a chart, we simply either highlight the data we wish to graph, or if you want all of the data, just click into the data. If you make sure, if we just scroll up, that your data has headings at the top, then those headings will be used in your chart. Here I am in the country sales sheet. I click into the data. I would like a chart. I use the keyboard shortcut F11. Hey presto, I get a chart. That chart is the default chart type of columns, and each of the columns is a relative size to the data. Now, most of the columns are tiny because the data is skewed by this graph here, this massive amount for United Kingdom. Now, your chart will always be linked to the data, so we can go back to the data, and let's seriously reduce the value for United Kingdom down to 350, and then have a look at chart 1, and we can see the bar has dropped to 350, and the others are now come into appearance, because relatively they're not so far apart. They're still quite a way apart, but they're not so far apart. What we could also do to sort of offset this larger value is change the scale. Currently it goes to 400. If I double click here on the scale, I can see the maximum there is 400. If I make that 200, that doesn't change the value of United Kingdom, but what it does do is stops at 200. The rest of the value is still there, it's just not on the chart. But relatively, the other columns can now effectively be extended and they become more visible. That's one way of dealing with these massive offset values, is either reduce the offset value, that would be one way, or change the scale so the offset value is effectively off the scale. And then a third way is you could actually hide that value from the chart. If I go back to my data and select that row and hide it, and then come back to the chart, what you will notice is that column magically disappears. So hidden rows and columns do not appear in the chart, even if the chart area is covering that data. It's just a little point to recall there. That's the country sales. Nice quick chart. We've even hidden one of the columns and looked at how we can deal with this single massive value. With the year sales, again, we can click in, use our keyboard shortcut, F11, creates me a chart. However, it's created me double columns. What it's done is it's tried to chart the year because it's numeric. Excel says, numeric, you want that charting. Actually, I don't. Now we have 2 options here. One is to go back to year sales, change these to text values by putting the little single apostrophe at the front, which we could do, but we'd have to change all of them, and then recreate the chart. Or, back here in chart 2, we tell Excel that the year is not a data series, but actually a set of labels. We go to the Chart Tools Design, select Data. Here we can see the 2 series, year and sales. Well, year is not data, thank you, so I remove it. And then for the sales option, I go to Edit on the category side here, and I tell it where to get the labels from by browsing the label range, which is actually my years. Close the browse, OK on the box. Notice here we now have the years. Notice in the chart we now have the years as labels rather than as data. That's one little thing to watch for if you're trying to chart what effectively is numbers, but you want the numbers to be labels, as we do with years. You either have to change them into text before you create the chart, or subsequently tell the chart that they're not data, they're actually just labels. That's 2 little options that you could encounter when creating charts. Now the sales data sheet has a lot of columns within it. Let's close the dialog box that opened when we looked at the data axes. Now in here, I don't want to chart all of this. I just want to chart the date and the sales. So that's the only information I need to highlight. Date and sales. So both of those columns are highlighted. Then I can go with my keyboard shortcut and a chart is created. Now with sales data over time, probably a better chart than the column one would be the line chart. Okay, and then we get a set of lines that go across our chart. Now at the moment, that's trying to chart each actual value. If I go to the axis here and double click, that will bring up the options on the right. I can tell this axis that it is a date axis, and a little lower down here I can change the base from days to months, and you can see then the month values then get mapped in. One thing that needs changing at the same time really is then the labels here. So they don't show dates, they show months. So we come down to number, and then we come down to format the code. And let's take out the DD in the middle and replace that with 3 M's. So that will give me an abbreviated month, and take off that slash. So I get 3 M's, so Jan, Feb, Mar, and 4 Y's give me the full year. I add that code to my chart, and we then see in the axes, quite small because there's still a lot of data, the month and the year, rather than each of the individual days that we've graphed from our data within that month. So it's quite a clever little way of grouping the data together to still give you this pattern of sales over a set of time. That's been a little recap of how to create charts. If you didn't know F11 before, you do now. Certainly one to recall and retain. And then a couple of little problems that can occur when you're creating charts. For example, charting the labels as data, therefore creating some columns for them, and having single large values that you want to exclude from your chart. Now with charts, we can add to those charts trend lines, which make the understanding of some quite complicated charts a little easier to follow. Let's take our trend lines file as a demonstration. In here we have a number of sales data options. We have sales data, which is the data for a particular year for each month. Sales data 2, which is also a set of data, but slightly different values. And then we have a population data, which shows the decrease in population of a particular country with 10-year gaps. Each of those sets of data are already charted as column charts. So there's our decrease in population. There's our sales for sales data 2, which is higgledy-piggledy. And there's our sales chart for sales data, which isn't so higgledy-piggledy. Now, if we want to add a trend line, that would be the starting point. We select the chart, make sure we're on the Chart Tools Design ribbon, come across to Add Chart Element and Trend Line. Now, there are a number of trend line options. We'll go for the moment with a straightforward linear trend line. And you can see before I even click, the line has appeared on the chart. I can then come in and select that trend line. Now the default is for it to really very faint. And the first thing I want to do is customize that. So if I double click the trend line, that will bring up the properties for the trend line here. The little tin pot is the fill and line color. And we come down here and change the dash type to solid. That will certainly help. And let's change the color so it stands out to red. We can then go back to the trend line options here and explore the different trend line options. So I went for a straightforward linear option here. The linear trend line effectively takes the start point and the end point and draws a straight line between them. So that is useful for giving you an idea of the trend of the sales, which obviously are upwards. Despite the fact we have 2 little drops here in April and June, we're still heading in an upwards direction. The linear is the most basic of the trend lines, simply taking the outer values and drawing a line between them to give you an idea of where things are going. And that could be upwards or downwards if we are losing money. We have a second option here of logarithmic, which actually more closely follows the pattern of the sales. If I were to choose that here now, you can see that there is more of a curve, where here we had a little bit of a boost in sales. The curve goes up, but then it flattens off slightly here. So the trend now is actually a little lower than the linear because it doesn't end up at the top here, which allows for the fact that we had a little bit of dip here, and these two don't quite meet those, so the path is more of a curved option. That's useful if the rate of increase or decrease is inconsistent, so it gives you more of an idea of where you're going, whereas the linear is just straight line from the beginning to the end. We have other options, obviously. We have polynomial, a little bit like logarithmic, in that it's not a straight line, it's a curved line, but it does have a number of options here called order. The default is 2, but if you go up, you'll find that each step upwards makes the line more closely mimic the actual values. So here where we had 2 poor months, the line comes down a little, but then obviously shoots up for our big month at the end of the year. And the push to 5, and the curve follows more closely the data, push to 6, and it follows it even more closely. It's really deciding which is the correct line, and if you're going for polynomial, which is the correct order to choose to get the line that looks how you want it to look. Because effectively that's all you're using the trend line for, to tell a story, to convince other people that this is the way the company is going, or this is the way the statistics are going. Now further line options in here are power. This is useful for values that increase at a predetermined rate. Now our sales don't quite match that because they go a bit haywire in the middle, where the summer affects the sales obviously. Now one thing that you can't do with the power though is you cannot have any 0 or negative values. So if in my sales data I didn't perhaps have any sales in one of the months, let's say July, totally zeroed out, perhaps we closed for refurbishments or something, in the sales chart the line disappears because we cannot have a power line. So I'd have to go back in, choose one of the other trend line options, let's say linear, and it then forgets I changed it to a nice red line. So be careful with power, in that the line will disappear if you try to create a power line where there are 0 values. The same goes for the other option of exponential, and you can see how it's grayed out because we have 0 values. If I go back in and put some sales in for July, then when I come back, my original trend line reappears, which is that one there. So let's remove that one. It's just a simple delete on the keyboard. And then my new trend line, which is here, now allows me to choose exponential. And you can see again, this is one that again has a curve as it tries to follow the pattern, which is quite useful when you have increasing or decreasing values that again are not consistent. The linear one is great if the rate of growth or rate of decrease as well is the same. So there isn't any necessity for a curve there, whereas the exponential works well as a curve, as does the power. Bear in mind both of these options cannot have 0 values, which gives them a little bit of a drawback, which leaves you with the logarithmic as quite a good option for curving lines. Then the last of your possible trend line options is the moving average, and this uses at default 2 of your values to create an average, which means that you don't get one at the beginning because you haven't got 2 values by this stage. But by here you have, so that point there is the average of these 2, that point there is the average of these 2, and all the way up to the top. You can increase the period that it takes the averages from, but bear in mind you now lose the trend line on the first 2 options because it needs 3 to create the moving average. So that's another alternative. Really it depends on what you're trying to sell. Are we trying to sell, well look, the company is growing, here's our growth pattern. But with linear, a growth pattern will look steeper and look like it's traveling in that direction. So hey, we're going up much, much steeper. There are all these different trend line options, but usually it boils down to the story that you're trying to tell or the data you're trying to picture. So for example, here with our sales, things are going up. Whichever way we look at the trend line, it's upwards. All the trend line does is determine the steepness of that increase, and linear makes it look quite steep, because in January we were very low and December we were very high. What this perhaps does not take account of the fact is that next year January will drop again. We'd need to see a trend line over 2 years to get a real pattern. Now with our population, where there's been a marked decrease, we might want to see how that's happening. What's the decrease? Is it steep? Is it not so steep? So we come in here, we add another trend line. If we went with linear, and let's just format that line again, just to make it more visible, that's why I do it. Let's have orange this time. In the linear case, the drop in population really looks quite steep, and if we were to extend that down by the year 3000, there would be nobody left in the country. However, a population doesn't drop like that, and you can see these are not dropping steeply, they're sort of slowing off. So in that case, the trend line we would want to choose may be logarithmic. We can see there is a steep drop, but then it curves away, so that might be more realistic. And if that were to be extended, that's the idea of the trend line. You think, oh, if I extend that a little bit further, and you can see in the next census in 2020, there wouldn't be such a big drop. Same with exponential. See there, the line curves a little, but there is a drop, and the extension there is that the drop would be bigger in 2020 than it is with logarithmic. Polynomial, similar curve to logarithmic. Power, because we have full values, we can use that. Again, there is a dropping curve there, but not quite so steep here. 2020, I think we will be smaller, but not so dramatically smaller. You need to make the correct choice for the data that you're trying to display and the story that you're trying to express. We know how to create charts and add some trend lines. What about having a dynamic range for our chart? We know we can create a chart quite easily. Here we have a dynamic ranges working file. If I wanted to create a chart of this simple data here, I could highlight the data. In fact, I don't even need to highlight the data. I could just click in, do our clever keyboard shortcut of F11 and create a chart. However, I then went back to the sheet where the data is, added in March numbers, had a look back at the chart. It doesn't change. I would need to physically go in and edit the range that the data is feeding the chart with. However, with the dynamic range, we could set the sheet up so that if you added more data, the chart would know about it and just respond itself. So let's delete this chart one, come back to method one, delete our March for the moment, and have a look at the two available methods. Now the first method is the easiest, most simplest, and probably the quickest to do, and that is simply to use tables. Now we've already covered tables earlier, so all I'm going to do here is create a table, which I do by clicking into the data, keyboard shortcut of Ctrl+T. That creates us a table along with all the table abilities we've already seen, so the banding of the rows, the filtering, etc. I'm not going to recover that ground. You can go back and have a look for that. What we're going to do now is we've created the table. So let's create a graph the same way. Just click into the data and F11. That creates me the same chart that I saw previously. Fantastic. The difference now though is if I go back to the method one sheet, we know we can add more data to this table by simply going to the bottom right hand cell and tabbing. I will then add March in. Now we know that March has been added to the table because we just tabbed out of the bottom right hand corner. Has it been added to the chart? Well, there's March's information. And the same would happen if we continued, went to April. We have a set of cells that are contained within a table. Therefore, as the table expands, the chart sees that expansion and graphs accordingly. An extra 43 in there, that's because I typed it in. So that is the easiest method. You can't really get much easier than that. However, sometimes people aren't happy with tables, sometimes the table isn't quite appropriate for your data, and sometimes you're on an old version of Excel, so prior to 2007 when tables were introduced, and you don't have tables as an option. So let's have a look at method number 2. A little bit trickier, to say the least, but still achievable. In here, we need to create some named ranges that are dynamic. Now we need to create a named range for each of our series. So one named range for Bob, one for Jim, one for Sue, and to make life easier, one for the labels also. That's 4 named ranges. So how do we create a named range that will expand when there's more data in that column? Well, fairly straightforward, I suppose. We go to the Formula ribbon and the Name Manager. Now in the Name Manager, because we've just created a table, we already have the table, which is really how that chart is able to respond, because the named range expands with the table expansion. But we need to do this next bit ourselves. We need a new named range. That named range has assumed the name Bob, because that's where I am in the sheet. Now, when I'm naming the range, it has to be different from what effectively will be the column heading for the chart. Otherwise, Excel will get a little confused. I'm going to call it Bob Data. Scope for my named range is the workbook, and then it refers to, at the moment, just cell B1. Well, I don't want it to refer to cell B1. I want it to refer to cell B2 for as much as there is data down here. So effectively, I want it to expand for as many cells as there are data. To do that, I use the offset function. So equals offset, open brackets. Where's the start point for this range that I'm going to select? Well, that's B2. Obviously, I need to tell it which sheet. So that's method 2, exclamation mark, B2, comma. The second value of my offset function requires a rows value. So that's how far to offset the rows. Well, I don't want to go anywhere. I want to stay in B2. And then comma, number of columns offset. Well, again, I want to stay in B2. So let's put a 0. Let's just alter the reference there to B2 to be fixed. So I'm going to place some dollars in there. And then comma. The last part of the offset function is the one that's really going to do the work, because this is the height of the range. How do I determine the height of the range? Well, we could count how many values there are in column B. Count A, method 2, exclamation mark, $B, $B. That's going to count how many more values there are down here. However, that's counting the whole of column B, so it's going to count Bob as well. I don't want it to count Bob, so I put -1. I then close my round brackets for the offset function. OK. That creates Bob data, which is this column, starting from B2 for as long as there are values, really. Then we need to do the same again for Jim. So new, Jim data. Effectively the same information here. I should have copied and pasted, shouldn't I? We will when we do Sue. So offset, method2, exclamation mark, this time C2, $C, $2 is the start point for my range. I don't want to be offset at all on the rows or the columns, so that's 0, 0, and then I need to know how many values there are in column C. Count A, method2 to get the name of the sheet, $C, $C gives me the count of the values in that column. Take away 1 so that it doesn't count the label at the top, so it doesn't count the word Jim. Close the round brackets for the offset function. This time we're going to copy that whole function. OK creates Jim data. We then need to create Sue's data, so new, Sue data. I'm going to paste in the function I have on the clipboard so I can make minimal changes, which is effectively to change all the C's to D's, because we're now looking at column D. By clicking out, I've picked up some extra cell references there, that's OK. We're looking at offset method2 D2, which is the start of Sue's data. No row offset, no column offset, just widen that. Counting how many values there are in column D, take away 1 for Sue at the top. That's Sue data. That's my 3 data dynamic ranges. So you can see this is a little bit more complicated than just using a table. One more dynamic range is needed for the labels. New, let's call that labels. And here we want to offset, starting with the first label, which is in A2, $A, $2, comma, 0, 0, so no row and no column offset, and then count effectively how many labels there are in column A. So method 2, exclamation mark, $A, $A. Now this time I don't need to take away 1, although I could do to finish the formula off, because there's actually no value in A1. But if I'd placed, for example, the word month in there, then I would need to do the take away 1. I've got to watch whether I have a value in there or not. Because I haven't, I don't need to do the take away 1. Close round brackets, OK. And that's my labels set up. So 1 series for the labels, and then 1, 2, 3 dynamic named ranges. Now these are the ones that are going to do the work for us. We then close, done the hard work now. We create our chart as normal. There's our little chart. But then we need to swap the data that Excel has chosen for our named ranges. We're going to select data. I'm going to switch the row and columns around so the data sets are in the same place. And then Bob edit. His label is coming from there, that's fine, the label's good. It's the data that's coming from the wrong place. So we delete the range. We leave method 2 exclamation mark and then put the named range, which is Bob data. OK. Same for Jim. Leave the label selection, that's OK. All the way back to method 2 exclamation mark, Jim data. OK. Sue edit. Leave the label, method 2 exclamation mark, Sue data. So that's replaced Bob, Jim and Sue with their dynamic ranges. We now need to do the same for the months. Now I only need to replace Jan, and dynamic range will sort the rest out. I go to edit. This is coming from method 2, and then it's labels is the name of my named range. OK. And then say OK. Nothing's changed because no data has changed. If I go back into method 2 and simply add more data, such as March, and have a look back at this chart 3, will it have dynamically responded? Yes, it has. There's the March data. So now that I have the offset methods, I don't need the table. I'm using the clever offset named ranges. I can just add more data down here and it will automatically be picked up by the effectively expanding ranges. And then the chart sees the new range and it picks the data up. So I've added 2 more months. Look at chart 3 and April and May now exist. So that's the ability to use a dynamic range within your charts. Either method 1, the easy way using tables, or method 2, let's use our dynamic named range using the clever offset function. Creating a forecast sheet is something new to Excel 2016 and is very helpful. Let's take our forecast working file. You can see here we have some sales for 2016 for each of the months January until October. Now if we wanted to predict, for example, what November and December might be like, or even what next year might be like, then we could do some of our own calculations and experimentations or we could see what Excel could offer us with the forecast sheet. Now, to create the forecast sheet, we simply click into the data that we want to forecast on, go to the data ribbon and come across to forecast sheet. This then opens the create forecast worksheet dialog box, and without changing any of the additional options, we can control how far in the future the forecast should go. So mine has gone for next April, so April 2017, but it might be that I just want to predict to the end of the year. I can change that to the 31st of December. Now you can see it's a line graph. The blue is the values that I've given it, those here. The orange is the predicted forecast with an upper and a higher boundary. So within that is how close they think they can be. This is where the forecast goes, but potentially it could be down here or potentially it could be up there. Now that's seeing things as a line chart. I can change this to a column here. I do quite like the column for forecasting once it's creating it, because the solid chunks of blue, again, blue's the current values, orange are the predictions, and then these vertical bars here are the upper and outer boundaries of the potential range. If I'm happy with that or the line, I simply click Create. Just before we click Create though, let's explore the additional options. In the additional options, I can change where the forecast starts from. Now you can see it starts from the month after where I finished effectively and then goes ahead. I could, if I wanted, go a little bit further back from there to September, and you can see then it projects October as well. So the value that I have in there, 15, is changed when using the forecasting to be a different value. I'm going to change that back to 1st of October. I can control the confidence level. Now I can either remove that completely, which is the up and down bars there, or on the line chart, it's the upper and outer boundary. Maybe I don't wish to see that range of confidence, or I can leave it in and actually amend the value. So I can reduce confidence values, and you can see the lines, effectively the range is smaller and smaller. The smaller this percentage gets, higher that percentage gets, the boundary gets bigger and bigger, so the lower boundary and the upper boundary. If we have seasonality, we can leave this to be detected automatically, or I can set it manually, and that number there determines how many of these periods effectively associate a season. So I'm going to leave it as detect automatically, and it will deal as a whole year. This is my timeline range. This is my value range already selected here. I don't need to amend those. If I have any missing data points, if I'd only provided some of the months and perhaps I didn't have a value for May, I can tell Excel how to deal with the gap. And the choices are interpolation or just put zeros in there. The fact is, in my data, there are no missing points. If I have duplicate values, so if in my data perhaps I had 2 sets of values for May and 2 sets of value for June and 3 for July, I need to tell Excel how to deal with multiple values. And here we have average, so it takes the values and averages them. Or we have median, which might be a preferred choice of your own, or you can actually sum them up. So if you've got 2 values for June, let's add them together to give me a total for June, which might be the preference. It really depends on your own data. So these are the additional options. You can create your forecast without even looking at the additional options, should you wish to, and we can change the confidence. We can adjust how it deals with missing points or with duplicate points. Once you're happy, we can minimize the options and just click Create. Now, when you create a forecast sheet, as this little box tells us, thank you, I've got it, it creates a new sheet. So you've got your original one, which is where my data is, and then it creates a new sheet, which is effectively my data copied over. So there's the months and the sales, and then here are the forecasted values. And this data is then placed in a chart. You can see if I just move the chart slightly over, the upper and lower confidence values are also in there. So the blue is my provided data, the orange is Excel's forecast. So this is a new option introduced in Excel 2016, allows you to take a set of timeline data effectively and forecast ahead. In this case, I've forecasted the rest of the year, but I could have forecasted 2017 as well, simply by clicking in, select, forecast, forecast end. Well, let's go all the way to the end of 2017, shall we, and see what happens. So there's the forecast based on the data that I've already provided for the current year. There's going to be a little bit of up and downy throughout the whole of 2017, according to the forecast. Sometimes when you're creating a chart, as we have here with the page views and the shares, the chart doesn't quite look right, and it would be quite useful if you could map one set of the numbers on a different scale. Let me show you what I mean. So we're taking our web stats data. It has each of the months of a year with the number of views for that month and the number of shares for that month. I don't need to highlight anything, and we're going to use our quick keyboard shortcut. Don't forget F11. Gives me a column chart, and I can see the blue bars are my page views, and then the tiny little orange bars are my shares. Let's just change this chart type to a line chart, and the distinction between the two lines is now even more engrossed. Because the shares are all in the 100,000s, the scale has to work with those hundreds of thousands. Therefore, the share values end up down the bottom here, and you can't see much variance between the months, because compared to the hundreds of thousands of page views, there isn't much variance. However, if I were able to take this particular series by clicking on it, right-clicking and format the data series, that pops up the Format Data Series box on the right, and I can move this series from the primary axis, which is where everything gets graphed, to a secondary axis. Then I can see how the pattern of the shares now works. The scale for the shares is on this right-hand side now. So you can see we've got a second y-axis effectively, showing different values because the values within the shares are obviously of a smaller scale. They're in the tens of thousands rather than hundreds of thousands. But what it does allow you to do graphically is compare much closer the pattern between the page views and the shares. Now each of these scales are totally adjustable yourself. So I could click on that scale, come to the axis options and change the minimum and the maximum boundaries. Currently they've defaulted to 0 and 60,000. Well, I don't have any shares up at the 60,000. So let's drop that down to 50. And really to make this match up, I ought to change the scale on the left hand side as well. So instead of being 700,000, let's make that 500,000. Quite enough. I think 600 might be too much, so we can experiment. 600,000. That brings it in line. So by adjusting the scales of my two axes, I effectively can compare two values that need to be compared. So the page views do need to be compared against the shares, but they don't match together very well because of the disparity in the actual volume of the numbers, with the page views being in the hundreds of thousands and the shares being in the tens of thousands. So if you ever happen to find yourself with two series that need comparing, so they need to be in the same chart, but there's such a disparity in the volume of the numbers, then you can use this option of a secondary axis. So one way of doing that is how we did it. We created the chart with our quick F11. We went in, we selected the data series, and we said plot on a secondary axis. Now there is another way of doing this without having to create the chart and then effectively change the axis. What we can do is click into our data, go to Insert, and choose Recommended Charts. Now there's a number of recommended charts in there you could stick with, but let's go with All Charts and come down to this Combo option right at the bottom. Here we can change, as well as change the fact that the page views and the shares are different graph types. We could make them the same. Here is the option for a secondary axis, so I could take my shares and plot them on a secondary axis. That's through the recommended option, so I don't need to create the chart and then go and change the data series. I can do it through the recommended, choose All Charts, come down to Combo, and as well as this ability to change between one of the values going on the secondary axis, I can actually plot them differently. My page views could be a column, whereas my shares could then be a line. And that might be a way of easily comparing things. And when I click OK, I get a floating chart that represents that information. This is where your two series are needing to be compared, but are so far apart from each other in values that a secondary axis becomes a really very useful way of comparing the items graphically. What is a pivot chart? Well, basically a pivot chart is a chart based on pivot data. If we take some sample data, as we have here in our sales 2015 file, and we wanted to create a pivot table to summarize that data, we could then create a chart based on that summary. Alternatively, we could create a chart straight from the outset. If we know our end result here, our end target is to create a chart on this data, then we can create a pivot chart straight away. The mechanics are go to the Insert ribbon. Make sure you're somewhere in your data. You don't need to highlight it, you just need to be in it, as long as there are no fully blank columns, otherwise Excel won't spot where the end of the data is. And we're interested in pivot chart, so we come all the way across the charts, and then pivot chart has its own little section. Little drop down arrow to choose either pivot chart or pivot chart and pivot table. Now in reality there is very little difference between doing the two, because even if we choose pivot chart, as we're going to, asks me to confirm where the data is, and it's highlighted it all. Fantastic. Okay. We get a pivot table here on the left and our pivot chart in the middle. Whatever we do will happen in both. The chart is pretty much linked to a pivot table. Let's take the date and place that in the axes. And you can see here it then splits into months, which is fine. That works for me. And then let's take the sales and drop that in the values. And then we get the default, obviously again, columns for my chart. Now the difference between a pivot chart and a normal chart is it is linked to the pivot table, therefore linked to the data. So it is a summary chart. You'll see here we have sum of sales because that's what's happening in the middle of the pivot table. It's quite useful to have the pivot table there, isn't it? And we have the grouping that is taking place month and date. And you can see here in the pivot table, if you expand out January, it gives you the individual dates. And carrying out that expansion also expands the chart out. Let's compress that. And these little blocks stay on the chart at all times, except for when we hide them, which is a little bit down the line. But apart from that, it works and behaves just like a normal chart. When I click on here, I get the same chart options. So I've got all these chart styles. I can change the color scheme. I can change the chart type. I might want to change that into line for sales. And I can do any of the formatting that we could do with a normal chart. So the design and the format ribbons are pretty much the same. We just have an extra sub ribbon here, which allows us to interrogate the data, but that's effectively the same as the pivot table. That's method one. It works. You can see here on the right, you still have your pivot chart field, and we can move things around. Perhaps I don't want to do the sum of sales, I want to do the quantities. And the chart responds. Or I want to do sales, I'd like to do average of sales. So June was seriously high average. Or I want to put quantity back in, and perhaps I'd like to put country into the series option. So here in the table, that's the columns, this is the rows in a chart, this is the series, and this is the category. You can see here you now have a separate line for Germany, Scotland, and United Kingdom. But the values for Germany and Scotland are single ones in 2 of the months. They're not getting graphed very visibly. Let's perhaps change this into a column chart, in which case the columns now appear because it's just a single month that you have a value in. There's your German value and there's your Scotland value, and the rest are all United Kingdom. Perhaps if I took the date options out, then just have a bar for each country. So if you bear in mind that this top section is exactly the same as in its pivot table, in that this is the series, or in the table that controls the columns, and here are the categories, so I could move the country into there, and they control the rows. In my chart, they're classed as category and series, and depending on the chart type will depend on how things are then displayed. The middle section here is where the calculations take place, so that controls, in this case, the size of the column, or the relative size of the column, or the height of the line if we're up in a line chart. Now there is an alternative way of creating a pivot chart, and that is simply to start with your data, actually add a pivot table. Don't even think about charts for the moment. That creates me a pivot table into which I can place the options, so perhaps put the countries down here, sales in the middle, and the months across the top. Once I've got my pivot table working as I see fit, I simply then just click into the pivot table and use our magic keyboard shortcut of F11, and that will create me the pivot chart. Notice by doing things this route, we end up with separate sheets. We had a separate sheet that gets inserted for the pivot table, and then a separate sheet that gets inserted for the pivot chart. But they both work together. Be a little bit aware of that. If I take months out of here, which is on my legend, notice that the pivot table also has the months removed. So this pivot table is linked to the base data. The chart is linked to the pivot table. So any changes I make in the pivot chart will affect the pivot table. So just be a little bit aware of that. When you have both in an Excel workbook and you're changing the fields or the columns or the actual values on any one of those, so either on the chart or the pivot table, that the other item will respond to those changes as well because they are inextricably linked to each other. But other than that, as long as you keep that in mind, creating a pivot chart is really very straightforward and very useful as a graphical summary of your data other than just having a table summary. When it comes to customizing your chart when it's a pivot chart, there is actually no difference than customizing your chart when it's not a pivot chart. You click on the chart as normal. This does open up the pivot chart fields, but that's fine, we can ignore that for the moment. And then we have the pivot chart tools where we can access the design ribbon, which gives us access to changing the chart type. I can change to a line. I could change to a pie. Obviously, a pie can only deal with a single series. A bar, an area. So you choose the particular chart type that suits your data. Mine is sales data. I'm going to leave that as a line, but then I can choose sublines, so a stacked line, 100% stacked line, which squishes everything to the top, line with markers, stacked line with markers, that line with markers 100%, or 3D line. Actually, let's go for the line with markers. Okay. Once you've chosen your chart type, you can then control different styles within the style box. So it's whichever one suits, again, your preference. I mean, that's quite thick lines there. Quite like the contrasted one. Or I can change the colours, so I have a different colour scheme, or a single colour scheme with different shades for each line. Bright green there. I can add other options as quick layout here that allows me to place the legend in different places. Even have a data table displayed. No bars, no grid lines, but the values are on each point. It's sort of choosing a style that suits you. That's a pretty plain chart there. No axes, no labels, no nothing. I think I might go with, let's say that one. I do like the lines across there. Everything works the same for formatting as if it were a normal chart. As long as you can ignore these little sum of sales, the country option there, and the other items here in the series. Change your chart type, lots to choose from. Chart styles, lots to choose from. Color schemes, lots to choose from. Quick layout, 12 to choose from. Should you wish to move the chart, so the moment this chart, which is in the sales data 2016 file, is in its own sheet, I can move that to either be an object in the sheet called table, which is where the pivot table is residing, or with the actual data itself. Well, let's move it to go with the table, and it becomes a floating chart, which obviously I can resize within the same sheet as the one that contains the pivot table. Don't forget, the pivot table and the pivot chart are linked together forever. Any changes made in one is reflected in the other. Any changes made in the data is not automatically reflected in a pivot chart, which is in a normal chart. So for example, if I go here into my sales data, let's pick one of the countries that we know has a very low value, about Thailand. Thailand here is really pretty much on 0, 8.98. If I go up one of those values to 200, come back into the table sheet, nothing changes here. Notice Thailand's still on 0. In a normal chart, that would respond immediately. But a pivot chart is based on the pivot table, which is based on the data. Because that data could be held externally to Excel, the update is not automatic. We need to refresh. So on the chart, I go to Analyze, choose Refresh. Refresh All is the safest option. That will check everything. And then we see the Thailand dot move up to the 200 mark. I hope you saw it move because it didn't move very far. But it needs that refresh, unlike a normal chart that will respond immediately to changes in the source data. Pivot chart, like the pivot table, doesn't. It needs to be refreshed, and that refresh option exists on the Analyze sub-ribbon of the pivot chart tools. All the things to do with the chart itself are on Design or Format. So let's move that chart back into its own sheet. Just makes it a little easier to see, and we still have the same options for refresh. So as far as the design goes, anything you can do with a normal chart will work. As far as the data is concerned, that doesn't automatically refresh, just as a pivot table doesn't automatically refresh, and you need to use the refresh option on the pivot chart tools ribbon. Refresh refreshes the data that feeds this chart. Let's take the sales data 2016 working file and look at a feature of pivot charts that really blows away normal charts, because this cannot be done in a normal chart. Let's click on the chart to select it, and that also brings up the pivot chart fields on the right. I'm going to make a slight change to this chart by dragging out the country and moving the years into the category axis, so the x-axis, and let's remove the date out of the series. That way we have a breakdown for each year by quarter. That way we can spot the fourth quarter 2010. Now the bit that cannot be done in a normal chart is if I bring the country into this section here, the filter section. Now we know on a pivot table that that section provides a little filter at the top of the table. Well, it does exactly the same with the chart. Over in the top left, I have country. Click country. I can then choose one of the countries to filter this chart by. So I might choose United States, for example. And then this chart now only shows me the sales by year, broken down by quarter, for the United States. Go back in, choose perhaps Bangladesh. Okay. And they only had sales in one quarter in 2011. Go back in, let's try United Kingdom. 2009, 2010, broken down for 3 of the quarters in 2009 and all of the quarters in 2010. As well as the ability to filter by a single country, within this drop list for the country, I can choose select multiple items, and that way I can just place ticks against multiple countries. And if I say OK, I then see the result for each of those countries, which is great and a fantastic tool. However, what I cannot do once I'm looking at the chart is determine which countries I am previewing. Now, I can give you a result here that will help work, but it still won't help when you choose multiple countries. So let's go back and choose a single country from my little drop list. Let's turn them all on and then all off. That's the easiest way of turning the ticks off. And let's stick with the United Kingdom. Now, if I click off the chart, everything disappears as far as the pivot chart options are concerned over here, but I can't tell I'm just looking at United Kingdom. However, if I go back to the Table tab, I can tell I'm looking at United Kingdom because it's displayed on the screen. So what I'm looking for is a way of displaying that same option that I see there on my chart. Or we can cheat. Let's click on the chart and go to the Format sub-ribbon, and I'm going to display a text box. So I choose this text box tool here, place it wherever I feel fit, probably here. And then what I can do with this text box is click in the formula bar, type an equals, click on the table sheet, click on the cell B1, which is displaying the filtered country, and then return to accept that formula. And hey presto, the text box on the chart says United Kingdom. If I select that text box and perhaps move it into a more prominent position, maybe even center align the text, maybe even make it bold in a different color. Then when I go back to country and choose a different country, okay, finally I've got multiple items selected. That's the drawback. With multiple items, it just says multiple items. But if I make sure I select a single country, it gives me the single country in that text box. Turn off Australia, turn back on France. Okay, it says France, and I know I'm then looking at France's data. So when I click away to deselect the chart field options, I see my chart. Now there is one other thing that potentially you might want to do with a pivot chart, which is effectively to hide these pivot chart giveaways. Now those are controlled on the Pivot Chart Tools Analyze sub-ribbon. Here we see field buttons. If I click the drop down, these are all now visible on my chart. If I choose hide all, for example, then they all disappear. So when I click away, I do not see the little filter option at the top left for the country, the group above the legend, and the group on the axis. This now looks like a normal Excel chart. It doesn't look like a pivot chart. And the only way I would know is to click back on for the field list to appear, and then I can turn back on these field buttons should I so wish by removing the hide all and then turning on or off those that I don't want anymore. It's just like a little extra option that you might want to do before you send someone the pivot chart, because those extra blocks might just serve to confuse people slightly for those people that don't understand a pivot chart. But you can have them back by removing the hide all, and then they come back, allowing you to carry out filtering, allowing you to filter by the quarters over here, filter by the years down here. All those options are available to you just as if this were a pivot table. But effectively the pivot chart is really a pivot table, but in color and pretty, and depending on the chart layout you've chosen. Everything else works the same. The drop arrows from here work the same. Filtering for the page works the same. So we've been a little bit extra clever here by adding in a text box that is linked to the filter from the table, so we know which country we're filtering by. The drawback is when it's multiple countries, it just says multiple items. But other than that, that's an excellent little way of seeing which country we're currently looking at, which filter effectively is in place. Welcome to Power Query. Well, it's not actually called Power Query anymore since Excel 2016. Prior to that, so in 2010 and 2013, it existed as a COM add-in, and you had to download, install, activate, etc. However, now, from 2016, it's built into the Excel interface. It's also been given a slightly different name, which is Get and Transform. Now, if we go to the Data ribbon, now for the moment I'm using this working file, which is actually empty, has 2 sheets, and it's called Sample Query. On the Data ribbon, we have a whole new section here called Get and Transform. So this is the new name in 2016 for what was previously called Power Query and involved a long process of downloading and installing. Well, thank you for telling us that, Guy, but just what is this Get and Transform? As it says, It allows you to get data from an external source, transform that data without amending the original. This is just transforming what is being pulled into Excel, and then save that information in Excel and manipulate it. Charts, pivot tables, filtering, sorting, anything really that you can do with normal data that you would have in Excel. The advantages is that the data can stay in its original source, which might be on a web page, might be in a database of many types of descriptions, might be just in another Excel file or a number of Excel files, because one of the powers of get and transform is to merge data to manipulate it together as a single data source. Let's have a little overview of the mechanics. So to use get and transform, you obviously must have some external data ready that you want to make use of. You then come to New Query on the ribbon, and we come down the list of options. Is the data in a file somewhere? And you can see in the pop-out, those files could be an Excel file, it could be in a CSV file, it could be an XML file, it could be a plain text file, or we even have the ability to get data from a whole folder. Now that's really quite clever and very powerful, and we'll explore that in due course. Or we could be connecting to the information in a database, from a SQL Server database, from a Microsoft Access database, or from SQL Server Analysis Services database. So there are online databases, or perhaps within a corporation, that you might want to connect to. We have other sources. So from the web, we can connect to data that is displayed on a web page and make use of that in Excel. From OData feed, so this is a particular type of data feed from Facebook. There is a third-party plugin that allows you to connect to Facebook data. From any ODBC connection, so Open Database Connectivity, anything that you have the driver for to connect to Excel's get power can do that. Or we can start with a blank query, and you'll see shortly what that means by a blank query when we visit the query editor. We then have further options here for combining queries by either merging them or appending one query to another, or launching again the query editor ourselves. And we have query options and data source settings, which we will explore shortly. For the moment, I just want to demonstrate connecting with the get and transform to an Excel workbook, for example. We need to then find the workbook. Well, it's in your working files, and we'll choose the contacts workbook, and we click import. Now, whenever you connect to an external data source, the first stage is to be presented with the navigator window, which we have here, that allows you to choose which part of the data you want to use. So in the case of an Excel workbook, you get to choose which sheet or which table. In a database, you would get to choose which table or which views, and you can select multiple items. Obviously, we're just connecting to a workbook that only has a single sheet, so there's not much to choose from here, but there could be quite a list if it was a large workbook or a large database. We need to choose which part of the data we are interested in. We then get a small preview of that data on the right here, so I can see some of the information that is in that workbook. And then I have, well, three options really. One is to cancel, one is to edit, and that will take us into the query editor, which we will see shortly. And then one is to load, and there are two load options, load or load to. Load to allows you to choose a particular table or sheet. If it's just going in the current sheet, which is behind us here, you can just simply use load. Now, rather than just use load, I'm going to just quickly choose edit, which will again launch a separate window here called the query editor. Now, you can see here there are a lot of options, and we're going to explore most of these options as we move through this particular lesson. For the moment, I'm happy just to show you the query editor. The data is displayed in the middle, so you can see the data, and on the right we have applied steps. So at the moment we've chosen our source, we've navigated and chosen the data. The headers have been selected for us. You can see the headers have already been chosen, so we didn't have to do that. And we're effectively ready to roll. Now, there are lots we can do in here. We could, for example, just as a demonstration, hide the middle column. So I could choose the middle column there and remove column. The choice is to remove this column or remove all the other columns. So I just want to remove this column. Now, that doesn't remove it from the source data. It still exists in the original Excel file, but it's going to remove it from my result. And once I've finished editing, and you'll see other things we can do in here when we explore it, I simply choose close and load. Again, it has two options. Close and load will place it in this sheet. Close and load to will allow us to choose where we want the result to go to. So it might be a different sheet or a particular table. Let's just say close and load. And the data is then pulled in to a table. Notice the middle name is missing here because I've asked it to be removed from my get control. And because there's quite a bit of data, it's going to take a little while to load it in. there are actually 74,032 rows. Now that they're all loaded, we can see that this is really just an Excel table. We have the Table Tools Design option at the top here, and everything we've done with tables can be done with this data. The only difference is this data is not actually stored in Excel. It's stored in the external data source. You also get another sub-ribbon here, the Query Tools one, which allows you to refresh the data, because if anything happens to the source data, you'd need to refresh this to see if anything's changed. Allows us to delete our query effectively, or we can choose Edit, which will take us back in to the query editor, and I could make further changes. So the steps are, well, fairly straightforward. Step 1 is to choose a sheet, choose the data ribbon, choose new query, choose where you're getting the data from. So what are you connecting to? Let's do a quick one from an Access database. You have an Access database in your working folders called Employees. You're then presented with the Navigator. The Navigator shows available data objects. So in this case, we have tables and queries, tables and views in the database. So I might want to connect to Employees. Preview is shown on the right, and then we can have a load directly into Excel or click Edit, take us into the query editor. In the query editor, we can do a variety of things yet to be explored, and then we close and load to load a copy of the data into Excel, which is loaded into a table to allow us to then do all the table options that we want. We can create charts, we can filter, we can hide, we can query as much as we would like. So now I have two lots of data in my single Excel workbook. On the right, I can see them in this workbook queries little window that's opened up. Two queries, one for Achieved Employees, that's 99 rows, and one for contacts, that's 74,000 rows. You can see when I hover, I get information about each of the queries. So that's the basics of Get and Transform, which effectively is the renamed Power Query from previous versions of Excel. Let's get on and see what else we can do with this tool. Let's use a working file that I've called Query2. Again, it's a blank file, so you could create your own. And we're going to connect to the Access database that we have in your working folder. So Data, New Query, From Database, from Microsoft Access database, Employees. Navigator will then load, and I want the Employees table. And then let's edit. Our steps now are to explore the query editor a little bit more detail. When you start, your data is loaded into this central pane. If there is a lot of data, it only loads a sample of the data. Now, down the left here in the status bar, you'll see what you've got, which is 20 columns and 99 rows. If you had hundreds of thousands of rows, it would only load 1,000 of them. On the home ribbon of your query editor, because effectively here you've got a little mini program of its own, you can see we have quite a few choices. Now, one of those has been done for us, use first row as headers. So if your data comes into here and you find it hasn't taken the first row as a set of headers, then you can turn that on from here. If it does take it and it shouldn't, then we can take that out. So use headers as first row or use first row as headers. On the applied steps section here, this effectively is the history of everything that you've done inside the query editor and is your steps that you can go backwards from. So you can see we've chosen the source, we've gone in through the navigation and chosen the data table that we want, and then we've promoted the headers. Now that's occurred because we've actually made a change, and you can see it's taken my first person as the headers. Well, that's wrong. Use headers as the first row. Use first row as headers. My steps have all gone wrong here, but that's where the applied steps come in. I can go backwards through the steps until I'm at a stage that I'm happy. I can go all the way back to navigation, and you can see the titles then come in. Now I can go forward, so it's a bit like undo and redo, and you can see the steps then get reapplied. But really I don't want any of these steps, so I can right click, and there is an option delete until end, which will be everything from that point forward. Are you sure you want to delete? Yes, I am. And then we're back to where we came in, which is after the navigation stage, the data has been chosen. On the home ribbon of our query editor, we have the close button that we've seen, the close and load that loads the data into our Excel workbook. Refresh the preview, so that's this view here. If you're dealing with pretty live data that is changing all the time, that's a really great option. In our case, the data is not changing all the time because it's on the same machine. We then have properties, which is a simple dialog box allowing you to add a description. And then we have an advanced editor, which we don't do anything with. I'm just going to show you. This is the code that is used by the query editor. And if you really wanted to, you could look up how you could write this yourself. And you can actually write the advanced editor code here that will do all the steps we're going to do with the menu items. So let's cancel because we don't want to make any changes. The first options are to manage the columns. I can choose the columns I want from my data simply by choosing Choose Columns. It gives me a list of all the columns, and then I can either take the ticks out of the ones I don't want, or sometimes it's easier to deselect all the columns and then choose the ones you do want. Title, first name, surname. I would actually take the ID, town, city, salary, email, department, and date added is fine. OK. On the applied steps, I've got another action, removed other columns. And in the preview, I now only have 9 columns instead of the original 20. I can see the data I'm going to get. In fact, the date added looks like a pretty blank column, so there wouldn't be any point in having that. So let's choose the second option here, remove columns. Click into date added, click remove columns, and remove this column. And then that takes the date added column away, now gone, and I have 8 columns in my query editor. There are then other clever options here, keeping rows and removing rows. Number of options in each of those. If your record set that you're connected to is quite large, you might want to only keep so many of the rows. And that's what we have options for here. Keep top rows allows you to pick the top X. So it might be the top 100, the top 1,000, top 10,000, or the bottom rows, or a range of rows. Or we can remove rows. So remove top rows, remove bottom rows, remove alternate rows. All of these, you set the number in the dialog box that pops up. Bear in mind, although we've taken these columns out of our query editor, and you can potentially remove rows from your query editor, it's not altering at all the source data. That remains untouched. All you're doing here is building a set of instructions that is then saved as a query in Excel for you then to refresh. And it will run the same instructions again. It'll say, well, I only want those columns. I only want those rows, please. We have a remove duplicates option. Again, it will only remove them from the result, not from the source data. The source data, if there are any duplicates, will still have those duplicates. The same with errors. We have remove errors option. We have a sort option, A to Z, Z to A. That will sort the column that you have selected, or you can come into a particular columns drop down and choose sort ascending or descending from there. We have a clever split column capability. For example, here where I've got email, I might wish to split that into 2 columns. I select email, split column, by delimiter. What's the delimiter? Well, it's not any of those. It's a custom one, an @ symbol. Each time I see the delimiter, well, there's only one @ in an email address. And then the advanced options, which are actually quite limited. How many columns you want to split into? Well, just the 2 in CSV style. And we then see the email gets split into email 1 and email 2, which is the prefix, and then the post office, so tony@currentbun.com. Over on the right here, we can see the steps are now increasing because I've done something else. We then have a number of other options here, group by, which we will explore separately, the ability to replace values in your data, again, not in the source data, only in the result that you're pulling through into Excel. There's a number of steps we can carry out on the data before you load it into Excel. All of those steps have been on the home ribbon, so they're easy to access. There are other options on the transform ribbon. Some of these are the same as are on the home ribbon, like the split column that use first rows headers, for example. Others aren't. There's a new option here for rename. So I've got email 1 and email 2. Well, that's not very helpful, is it? So I'm going to rename email 1 as postbox and rename email 2 once it's finished renaming the first one. Email 2, rename as post office. A couple of other options on here we'll be exploring in a future lesson, such as add column as well. We will be exploring that. And then view, which has very little choice here. It's whether you want to see the formula bar, that's this bit here that's doing the work. I can actually remove that if I'm not interested. Or I can visit the advanced editor, which is the same window that we saw on the home ribbon. And you can see now that there's a lot more code in here now that we've actually gone ahead and done some work of removing some of the columns, splitting one of the columns and renaming 2 of the columns. Once you're happy with your transformations, so you've got the data, you've made a number of changes here, you can then close and load the result of your query into Excel, and that will then load into a table ready for you to then carry out whatever you want to carry out, any filtering, any charts, any further mathematical calculations. That was an introduction to the query editor's additional commands and options. That can be done at the start when you pull the data in, or it can be done at any stage by going back into the query and edit, pulling back up the query editor with your data source, and going through any of the additional options, such as splitting, renaming, removing some of the rows, removing some of the columns, etc. Everything you do is kept here as an applied step. Any of those steps can be removed at any stage simply by right-click and delete, or single select and delete. Be a little bit careful about deleting a step that is before other steps, because it might make a difference about the add-on, if you see what I mean. So if I take remove columns out and click the cross there, that will remove it. Hiding those columns really will have no effect on these because they weren't there to have any changes made to them. But I have gone back in the history here, and you can see my emails now back together. So at any stage you can go backwards. So it's quite a little experimentation window, and you can come back forwards, and then my column gets split, and my split two columns then get renamed. So the stages that you do here can be done at any stage. It doesn't have to be done when you first attach yourself to the data. It can be done at some future point. Perhaps you're doing some work and you think, oh, I could do with that split. Into the query editor, split the column. Remembering the whole time, this is having no effect on the original source data. Let's take our query 3 working file. Again, it's simply a blank Excel file. We're going to use it to get and transform some data. So from the data ribbon, we could go with new query, but for this step, because we've been connecting to existing data sources, if we go to recent sources, it shows me the recent databases that I've been connecting to. And there's my employees database right at the top. I'm taken straight into the navigator window, from which I can choose the employees table. Now, if your preview is taking a while to load, you can just go straight into edit if you know that's the data that you want. 99 rows are now loading in, and then they'll be starting to be previewed down the central of my query editor. Now, what I wanted to show this time with the query editor is the ability to add a new column, so a calculated column of your own. It may be that I'd like to create a column that takes the title and the surname as a single new column. Not a problem. We go to add column. I'd like to add a custom column, please, and I'd like it to go here. So let's click into title, add custom column. What's my column's new name? I'm going to call it salutation. And then in the lower section, I create the formula that will effectively will calculate my new column. Well, let's go to take title, insert, ampersand, speech marks, space, ampersand, hang on, let's close the speech marks, and then ampersand, surname, insert. So the formula in here effectively is any formulas that you can use in Excel, whether that's text manipulation or numerical manipulation. I'm taking the title, concatenating space, and then concatenating the surname. This will create a new column called salutation. When I say OK, my new column is calculated and inserted at the end here. So you can see I've got Mrs. Parker, Mr. D. Silver, Sir Great, Lord Fauntleroy, all the way down to the last one. So I've been able to add a new column. That new column will now form part of the basis for this query editor. So you can see here the applied step of added column. If I were to then remove some of the columns I don't want, as we've done previously, choose columns, I'll have the ID, first name, the salutation, that's my calculated field, and salary, the town. So I have less columns, but one of the columns I do have is mine, the one I've created, the calculated one. And that calculated column could be a numeric column. It doesn't have to be a text column as we've done here. So I could add a new column, a new custom column. I'm going to call it bonus. Notice that we can only choose from columns that we haven't hidden. So you have to create your custom column before you hide any of the columns you might want to use. In this case, luckily I want to use the salary column, and it's going to be the salary multiplied by 0.2. 20% is going to be the bonus. A new column gets created and added to the end here. If I'm now happy with my two new calculated columns, I can see that they've been added in the applied step. I now simply close and load, and the result of my query work is then loaded into Excel. If I then wanted to create another query based on the same data, I can go to Data, Recent Sources, Employees Data. That takes me straight to the navigator, so I'm not having to go look for the Access database, the employees, and then edit. But this time in the query editor, this is a different query to the last one. The last one has my two calculated columns in and some of the other columns hidden. This time, we're going to look at doing a grouping. So I can choose Group By, which is on the Home ribbon, or the Transform ribbon. No matter which one you choose it from, you'll be taken to the same dialog box. What would I like to group by? Well, I'd like to group by the town city. New column name, well, I'd actually like it to sum the salary. We'll call it salary total. Here I'm adding a grouping to my data based on the town, and I'm summing the salary by each of the unique towns. Okay, a little bit of work takes place, and there's my result. Total for each of the towns that exist in my data. I can then go to close and load, and that will load into a new sheet. You can see here it's a separate query, and in the workbook queries, it's a separate query. I have one query that is using the employees table and loads in 99 rows, and then another using the same TBL employees, but only loads in 9 rows because it's added a grouping to it. So 2 data sources are being fed into my workbook from a single data source, if that makes sense. We can carry out different queries, different groupings, different calculations on the same data, wherever that might be. In this case, it's in an Access database. And that information is then loaded into Excel as different sheets, each of the sets of data being placed inside a table. And we know all about table tools, so we can change the design. We can have a totals row at the bottom. All those kind of things still work with your table. It's just where the data comes from. And the data comes from this external database using the get and transform tool. So we get the data, we transform the data, and we display that data in Excel in a table. Here is my grouped query based on the employees table. Once it's in Excel, we can then do as we see fit. For example, I could create a quick chart on my summary just by doing the F11, which we learned a lot earlier. And then I have column charts. So this data is coming from this table. This table is coming through the query editor where the grouping is taking place. The data is then coming from an Access database. Hopefully, you're starting to see some real power here in the get and transform tools that are built directly into Microsoft Excel from 2016. No additional software required, no additional downloads, no additional add-ins to install and to crash. It's already there, ready to use. We've seen how we can use our Power Query, which is now called Get and Transform, to look at data that we have locally, and how we can use the query editor to decide what we want from that data. Well, how about getting some data from the internet? Well, if we go to Data, New Query, from other sources, we'll find there's actually a few places out on the internet that we can get data. There is directly from a web page, there is data from ODataFeed, or there's data from Facebook. Let's have a look at from ODataFeed. Now, if you want to query the data that is held on one of these OData feeds, then you need to have the URL of the data feed. In your working file, there is a plain text file called urls.txt that has a couple of examples. We have the Northwind data available through an OData feed and the AdventureWorks data available through an OData feed. These data feeds have effectively been set up for you to use, in this case, with Excel and our Power Query. I'm going to take the AdventureWorks address, copy that, come back to Excel and paste that into this URL box here. And then when we say OK, a connection will be made and we'll be presented with the navigator window, just as we were when we connected to our local Excel file. Now we have some choices to make because there are a number of data items available to us. There are company sales, and when I click on company sales, I get a preview of the data on the right, manufacturing instructions, product catalog, territory sales drill down, and work order routing. So this is data that's been made available to us through this particular OData feed. Let's stick with the product catalog and say edit. In the query editor, I can see that there is a lot of data, 999 plus rows of data. I don't want to see all that data, otherwise that's going to slow things down. Let's go to keep rows and keep top rows, and then we'll be given a dialog box, and I just want the top 100 rows. I'm going to say OK. I can then choose close and load, and the data that I've asked for will then be loaded into an Excel table for me to then carry out my manipulations. I only get the top 100 rows because that's what I've asked for. Obviously, if you are doing this for real, you'd want as much of the data as possible for you to then carry out any of your interrogations. So that's an OData feed in action. We can add another one by going back to Data, New Query, from other sources, from OData feed. Using our text file, let's get the Northwind data. So I'm going to copy that address as well, back to Excel, paste that into the URL for the OData feed, OK, and then make a connection to the Northwind data of which there are many more objects to choose from. So I've got customers, employees, invoices, orders, products, etc. Now in here, I'm going to select the order data. So that's orders, and we'll choose edit. I don't want all the data again. There's 830 rows, just really to speed up the extraction. Let's make it 400. Okay, close and load. And in my Excel file, I'm then given another sheet, which is sheet 5, which is going to pull through the orders information. So 400 rows there. Still have access to the 100 rows from the product catalog. That's actually still building, the little working sign there. That's sheet 4 and sheet 5. Let's add another set of data. Now this time, because I'm going to go back to Northwind, I don't need to go through the process of new query, other sources, data feed. I can go straight to recent sources, choose the Northwind option, connect. This time I'm going to choose order details into edit. Here there are a lot of rows of information. So again, let's just keep the top few. Let's go for the top 1000. Okay, close and load. Now the reason I've pulled through two sets of data from the Northwind data, so from the Northwind data feed, is because we're now going to join those two tables together, the orders information and the order details information, using a merge option. So let's start with this data, which is the order details data. Under query tools and query, I can edit. And what I'd like to do is combine this by merging this data, effectively joining it with the orders data. And what I need to do is select the fields that are the linking fields, which effectively is the order ID to the order ID. And then I choose the type of join. Left outer, which is all the records from the first set of data, and then anything that matches from the second. Right outer, everything from the orders information and any matching from the order details. Full outer, all rows from both tables. Inner, only the matching rows. Left anti, rows only in the first. Right anti, rows only in the second. Well, effectively, I want an inner join. I only want to see the data that matches from both tables. Okay. Now, in the query editor, which is here, I still see the order ID, the product ID, the unit price, the quantity, the discount. But from the order table, you can see I don't see anything. I've just got this column that says order. If I then click this little icon here, it allows me to choose which of the columns from the order table I would like to see. I'd like to see the customer. I should deselect all of them. Customer ID, the order date, and the ship date, I think is enough. Okay. That will then pull in those columns, and they'll be added to the existing columns that I already have from the order details table. And you can see in the applied steps, the steps that I've carried out. I've got the data, I've looked in the navigation, I've kept the first so many rows, which is the first 1000. I've merged with one of the other queries, which is the orders query. And then I've expanded the order column here to see another 2 or 3 columns from the orders. And then those selected columns appear in my query editor, which when I then close will load into my Excel document. Just to speed things up slightly, I'm going to choose a smaller keep rows. Let's go for the top 100. Okay, close and load. And that data is then loading into my Excel table, and it includes the new columns, customer ID, order date, and order shipped date. So that's the ability to connect to the external OData feeds, and then not only that, but use 2 queries and merge them into effectively one. Here we've taken the orders and the order details information, linked them together because they are linked in the raw data anyway, and being able to pull through merged elements. Now we could do that with 2 tables as we did here, but it could even be 3 or 4, and you pull that result into Excel for you to then carry out your interrogation with charts and pivot tables and sorting and filtering. We know we can connect to online data sources such as OData Feed, even Google Sheets, to pull data into Excel for us to interrogate. What about simply just pulling data from a web page, hopefully one that gets updated frequently so that it makes sense for you to make a connection to it rather than just copy and paste? Well, we can achieve that also. Here's a web page that is of interest to me. Countries in the world ranked by population. So this is from 2014. Now you can see on here that we have China at the top as being the largest populated country. And then we go down, 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 down. And this effectively little frame here has the top 200. and goes down to Antigua and Barbuda, which has 90,000 citizens. So how could I connect to that information and pull that into Excel? Well, all we need is the URL. Let's copy that. Back in Excel, we go to our data ribbon again, new query, from other sources, from web. All it then wants from me is the URL that I've just copied. Paste. OK. A little pause while it makes the connection. We will then be presented with the navigator, as we are, and we will be presented with whatever data Excel has managed to find on that particular web page. And it's found three lots of information. Table 0, which is my top 200 by the looks of things. So it's from China down to, well, we can see 35, because the preview is only pulling through the top 35. Table 1, which is a second set of data on here, which actually goes from 201 downwards. So we've actually got two lots of information on this same web page. And then we have the document information, which is the metadata, which just tells me that this table sits in an HTML document. Very helpful. Let's take table 0, which is my top 200 countries. I'm going to drop into edit. We have previously gone straight to load, but then noticed, like with the Google Sheets, it hadn't quite picked up the headings and things. So we have headings. Fantastic, we do. And we have 200 rows. Great. Do I want all of these columns? Well, I think for our purposes, we probably don't. Let's say choose columns, and we'll take out the select all, and we'll have the rank, the country, the population, the median age, and let's have the area and the density. Okay, so we've got the country name, so China, population in 2014, median age 35.7, size of the country in square kilometers, and then the density of persons per square kilometer. That looks great. Close and load, and that will load that information into my Excel table as usual. If the data changes on the web page, all I need to do is refresh, and that will update. So as the population increases or decreases, or any change to the stats here, the median age, the square kilometers, and the density, then I can just refresh and I will get that latest information. So that's the top 200. If I then pull in the second lot of 200, so I go to data, recent sources, so I don't need to go through the first few steps. This is the web page I got things from, world ometers. Once the navigator has loaded, I want the second table of information. That's table 1, and we will choose edit again to make sure that that drops into the right columns and rows. Got the headings, great, and we'll do the same as before. We'll choose the columns that we want. We won't have them all. We'll have rank, country, population, area, and density. Okay, and then close and load, and we now have two sheets, one with the top 200 and then sheet 5, which is still loading, which I think has the next 200 countries, or the next however many countries there are. But effectively it's a continuation of the top 200, and they're all ranked, so you can see how far they go down. 32 rows, it thinks. We could have put all those in one table, couldn't we? 200 and 232. Although the web page didn't put them into one table, it went with top 200 and then the rest, which happens to be 32. There's nothing to stop us using our query editor to merge these two sets of results into one. Now that would be quite useful. Let's go back to sheet 4, which contains the 200, into Query Tools Query, and then Edit. Now what we're looking to do is combine numbers of data, which is this query we have in front of us, and then I'd like to append the second set, or the 32 effectively. Select the table to append. Well, that's table 1. It even helps me out. Notice there, it says table 0 is the current one guy, just in case you'd forgotten. Thank you. Table 1 must be the other one. Okay. That then brings in the other 32 records. And I can see there we have population, median age, area, density. We have a slight issue here in that in the first set of data, it was called population 2014. In the second set of data, it was called population. So they now are not the same. So how could I merge those together, or append them effectively, keeping this population information in population 2014? Well, this is how. I need to go back in my applied steps. So here I've appended the query. Let's remove that, delete that step, and that takes me back to before I appended that query. I then need to rename this column. I go into transform, rename, and I need to lose the 2014 there, so that the column I'm bringing in has the same name. Then I can go back to home, combine, append, don't forget it's table 1 guy, okay. and that will then append the 32 records to the 200 records, making sure that the population columns match. Then I can close and load. It will load the 32 extra rows into the 200 rows. It will rename the column to population rather than population 2014. But I now have what effectively is on the web page 2 separate tables now sat in one table, which means I can then carry out other calculations that I might see fit, working out who has the highest median age, for example, because this is sorted by population. I might want to see sorted by median age, and we can see that Japan is at the top there. And if I sort them the other way, we find that Nigeria is at the other end of the scale of a median age of 15, which means there are a lot of people under 15. We could perhaps want to look at the size of the country. Smallest country there, the Holy See. Largest is Russia. The density, the largest density, so the tightest packed country is actually Monaco. And then the smallest, so small is packed that we have Greenland and Falkland Islands on 0 and 0, and then Mongolia on 2. So 2 people for every square kilometre. That is very sparsely populated, compared to the other side of things, where there are 25,548 people for every square kilometre. This is connecting to data that is just on a web page. Now, if that data is not ever going to change, then you don't really need to do get and transform. You can just copy and paste it into Excel and do what you like with it. If the data is likely to change, such as our population data here is, then we can link to it using the get and transform tools as we've just done, where we're even able to merge 2 separate tables together to create one conglomerate whole of the population of 232 countries on the planet Earth. We're starting to get the hang of this get and transform, which replaces the previous Power Query, connecting to local resources and external web-based resources. Let's have a look at a data source that has been added to get and transform in Excel 2016, and that is Facebook. We have the ability to connect to your Facebook account and read some of the data. Let's find out what we have access to. So we go to Data. Here I'm using Query 7, which is blank Excel file. New query from other sources from Facebook. That then warns me that I'm connecting to a third-party service, which effectively is Facebook. If you don't want to see this box again, you can put a little tick in here. Don't warn me again. I'm going to leave it in place. Continue. Specify an object or a connection in the Facebook graph. Now it defaults to me, and in the drop list, we can choose a number of data blocks effectively available to us in Facebook. And we can see here, if you use Facebook, activities, books, comments, feed, friends, games, likes, links, movies, music, permissions, posts, statuses, television. Well, let's go with likes. So what I'm effectively asking it to connect to is me likes, so my likes. Okay, if you're not already signed in, we will now need to sign in to Facebook. Obviously, you will need to know your sign-in credentials, whether you're using an email address or your telephone number, and you will need to know your password. Log in. So we're effectively logging into Microsoft's BI, which is his business interface. Connect. Now we miss out the navigator step because effectively the previous window was that. That was your choice of the data that you wanted, where we had the drop list. In our query editor, I then get to see the selected data, which is my personal likes. And there's been 62 rows. I've only liked 62 things. And we can see the name of the page that I've liked, category of the page. There's further information available in a table there, which I'm not interested in, and the link for the actual page. Same as previously, I don't want to see all these columns, so I'm going to choose the columns. I'm going to keep the name, category, and the ID. Okay, and then close and load, and that information will be loaded as previously into a table in our Excel sheet. So those are my likes. The reason I've kept the ID, and you'll see this now, if, for example, I go with this ID, which is a page called shoeteak.co.uk, I'm going to copy that ID, then go back to my data ribbon, recent sources, which brings up my Facebook, connect. Again, I get the connection to a third-party dialog box, and I'm into the query editor, and it's brought up the same query as before. That's not what I wanted to achieve, so I close that. If you want to keep your changes, no, discard them. What I need to do actually is go back to new query from other sources from Facebook, continue on the connector. So you can see that that box will pop up every time I try to connect to Facebook. So you might want to put the tick in that says, don't show me this again. This is the screen I wanted, effectively replacing the navigator screen on normal data, because I want to put in the ID that I've just copied, which is that page there, shooteek.co.uk, and have a look at Shooteek's feed. Okay, makes the connection, and just like previously when it found my likes, it then pulls up the feed data for Shooteek. Now there's quite a few records here. You see the ID of the actual feed. We received a brilliant photo from Dan Lee Smith, who won our winner, and the rest of that. There is a picture with the feed. There is a link. There's some icons there. There's further data here with options to drill down. When you see table and record, we can actually drill into the further data by clicking on table or record, or clicking this little icon here, which will drill down for all the records. You really do need a good connection to the internet for that. Created time, updated time, it's hidden, it's expired, some more table information for the likes and the comments. There's a lot of data in here that you have access to. So I don't want to see everything here, so let's keep the top 25 rows. This is just to speed up the data extraction. If you're quite happy to pull out more data and have the time, then great. And we'll choose columns. Let's choose columns rather than remove columns. I'll have the ID, the message, date I think is fine, created time. Okay, and then close and load, and that information gets loaded into a new table in Excel. You can see you have serious access to a large amount of data. That data can then be pulled into an Excel table, as we have here. So these are the feed records for Shooteek, and they're in date order, so I can see the date it was posted here. And I could perhaps do some filtering on the date, or I could do some summaries on the date. I could say how many posts do they have on a particular day or in a particular month. That's all achievable once you have access to this data and can pull it in. I made an initial connection using me and likes, so to pull through my likes. That then gave me access to the IDs of the pages that I've liked. And then I went back into the Facebook connection and used that ID to pull through the feed for a particular page effectively. So I could go with this one here, which is a TV program, take the ID, data, new query from Facebook, paste that ID in here, and then what would I like to see for that ID? I'd like to see the like for that ID. Okay, again, that potentially could be quite a bit of data. 20 likes, so that ID has made 20 further likes, giving me access to their IDs. I could close and load that. Another set of data gets pulled in. I could take their ID. These are public figures. There's the pages for these public figures. Data, new query on Facebook. So hopefully you're seeing the potential here for things that you can pull through. I could perhaps pull through the comments for that particular object ID, which is a page about a public figure. Tried accessing non-existing field comments. Okay, let's edit. You do sometimes find that you can't get anything on a particular option. Post is always a big choice as well. You'll definitely be filtering down the result that you get against posts. This third-party additional option here is built into 2016 in the Get and Transform section of your data. So previously that was Power Query. It's now called Get and Transform. It gives you access. Looks like we're retrying on the posts. Sometimes it's worth retrying. It could just be a slow connection that means it hasn't found the data. Sometimes it's worth giving up and choosing either a different idea or a different set of data type. But you can see the serious potential of information that you can extract here into Excel. It's refreshable and updatable. Again, we're going to retry. So it's refreshable data that gets pulled in when you refresh that particular table, and then you can interrogate that data to your heart's content with pivot tables and charts and any other type of filtering or sorting that you want to carry out. Once the table is in Excel, it's yours to play with. The last external resource that I would like to demonstrate a connection to and extraction of data is a web-based database, i.e. SQL Server. So we're going to use Query 8 as our base working file. Just as previously, we go to the data ribbon, new query. There is an option for from database, and we're after a SQL Server database. You need to know your connection information. Now, the information I'm going to put in here is to a personal SQL Server, so there's not anything I could share with you here. Obviously, you'll be able to see what I type. I need to know the server address, so you'll need to find that out from the server you're trying to connect to. That might be a web type domain name, or it might be an IP address, as we have in this case here, although it is a different port number. The database name is optional, but if you know it, it means it will already be filtered in the navigator pane. So when we get to navigator pane, I'm only going to see the options for shop. If I leave that empty, I will see all the databases on this particular SQL server. The SQL statement is also an option, and we will visit this again shortly. For the moment, we're connecting to this server and this database. Okay, I'm then pulled into the navigator where I can see views and tables. Now, a step has been skipped here, and that's the login step. And because we're on the same Windows network, that has automatically been taking place. If, however, your SQL server is not on the same network, you will be presented with a login box where you'll need to know your username and your password. And then you'll proceed to this step. I could choose any particular objects from here, and they will be previewed on the right. That one's actually empty. We've got delivery rates, we've got sales in the basket, we've got a union there of delivery rates. That actually is a union of a number of these tables here. Now I can pick any of this information, choose edit, as we've done previously, and that will take me into the query editor, where I can choose not to see all the data by restricting the rows, or not to see all the columns by just choosing less columns. But there's only a few columns here, so I'm going to say I'm quite happy. Let's close and load, have all that information. So I now have the delivery rate loaded into Excel, visible in a table, but if anything changes online and I refresh, this table will be updated. Now, one really good use of pulling data out of a SQL database is that that is live. It's on the internet, it's perhaps recording sales as this particular shop is, and I want to have in Excel without having to download every time, effectively a working file that I can just refresh and see the latest information. Well, I can do that. Let's go to data and create a new query from SQL Server. Now we're going to connect to the same one, or should I say I'm going to connect to the same one. This time I'm going to supply the SQL statement that will pull out the actual columns that I'm interested in looking at. This will be a lot easier than trying to use the query editor to pick columns from multiple tables. Obviously, you need to either write your own SQL statement, or you need to know a nice person in IT who can write one for you, and then you can just paste it in. So I already have the SQL statement that I need, and it's been tested, so I know it works. All I have to do is paste that into here. And you can see it's pasted in a select statement of a number of columns from actually 4 different tables. Okay, that then gets applied, and into my query editor becomes the result. I can see here the result, quite a few rows, 999 plus, but the columns I've asked for by the SQL statement: date a basket was closed, the country it went to, items sold, the number of each item sold, and the price that they were sold at. What is missing is effectively a line total here that does a multiplication of the quantity by the price. Now I could have added that into my SQL statement, or we can see how we can do it in Query Editor. We go to Add Column. I'd like to add a custom column, please. That brings up the custom column dialog box. I need to give it firstly a sensible name, so I'm going to call that line total, and then my formula goes in here. Now the line total is made up of the current price, so I can select that from here and double click, it will jump in, multiplied by the current quantity. So again I can double click, or this time let's single click and choose insert, and that puts it into here. So this is the formula that is going to calculate the line total. Okay, my new column then appears once it's worked itself out. Looks like we've got a network error because it's timed out, so I go back to home and refresh, ask it to effectively pull the data in again. You can see down here in the bottom it's waiting for the server. Once it then refreshes and loads in, we can see the extra column has been created, and that's simply a calculation of current quantity times current price. I can then load that into Excel, and I've got a table showing me 1,147 rows of sales data. If I then sort that from newest to oldest, I get the latest sale at the top, and then obviously backwards from there. That data is now loaded into Excel. Once another sale is made on the live server, I can then just refresh this using the refresh option here, and it will go reload the data from the SQL server back into my Excel table. And then anything else I've based on this table, perhaps a pivot table, perhaps a chart maybe, would be refreshed as well. So I'm in my table. I could perhaps create a quick pivot table, put the country in the rows and the line total in the value. It will sum the line total for each of the countries. This pivot table is based on the query in here. This query is based on the SQL Server database. We have some external data feeding the table in Excel. That table then feeds got a pivot table, it could quite easily feed a chart. It could quite easily be filtered and altered to suit our needs. There's just another external resource that we can use the get and transform tools for, pulling data from an external resource, which could be on your same machine, could be on the internet, and then you're interrogating that data. Data connection remains valid so that you can refresh at any time and effectively update your charts, your pivot tables, your data in the tables based on any new information that is available in the external data source. We've seen our Power Query that is now called Get and Transform doing some really powerful things. Now is the time to really see how much power it does have. We're going to create and use a blank file. So I've got my query 9 here. It's got nothing in it, so you can just use a blank file if you like. What we're going to do now is we're going to interrogate data from multiple files. Let's go to Data, New Query. From File, but we're not choosing a particular file format. We're going for a folder. So this will allow us to interrogate an existing folder on our system that contains files. Now this works best if those files are in exactly the same format, which the files we have in the working files are. If you browse and pick up your working files, inside the current chapter, we have a folder called Logs, which could quite easily be the logs from a website. In this case, they're just made up logs. Okay. Query editor then starts and it loads in all the files that it's found. And it's found 4 text files. These are their names: 2016-0101, 2016-0102, 2016-0103, 2016-0104, their extension, the last date they were accessed, the date they were modified, the date they were created, and then the actual folder paths. Now, we're not interested in the actual files per se, we're interested in the contents of those files. Now, there is a column at the beginning here of the data, which says content and 2 arrows. What these 2 arrows will do is actually load the content from these 4 text files. So if I give that a click, it loads the content in and we can see the information loaded into columns. Sometimes it doesn't quite spot the columns correctly and you might need to do split column by some kind of delimiter. Now, in this particular case, it's happened for me. So it spotted the delimiter being a tab and it's then separated the data into 3 columns, but that will not always happen. That's when we have the little split column option. First step that I want to carry out here then is to tell it to use the top row as headings for my data. So use first row as headers, and that's great. I now have date, page, IP across the top as my column headings. However, I also have date, page, IP every time it starts the next text file, which is not what I want. So in order to tell it to effectively ignore the subsequent headings in all the data that it imports, I simply filter out any data that has the word date in the first column. I go to the little drop list here, allowing me to filter. So I need to scroll down until I see date, or I can just search for it, DATE. There we are, and I remove the tick. And then click OK. Then there's a filter in place here, the little icon there to indicate that. In my applied steps, I can see what I've done so far. I've filtered out the rows that contain the word date in the date column. I've promoted the headers. I've changed the type, which has been involved in importing of the CSV file. So it's combined the 4 text files of data into one set of data for me. Now, there's one other step that I'd like to carry out, and that's to tell the query editor what data format each of these columns are. Now, we're okay with the IP and the page. They are text, and you can see up here on the ribbon data type text, and for the IP, data type text. However, the date has not been spotted as a date. It says data type text. So I need to click the drop down and say convert that into a date time field. I need the time because there's actually a time that the page was visited. And then we can see the format then changes into a date format. 1/1/2015, 5:59, 6:01, 5:58, 6:02, all the way down we have different dates and times. That's all the steps I wanted to carry out on this. I've gone to a folder. All the text files in that folder are in the same format. They've all been brought into the query editor. I've then expanded the content because it's the content that I'm interested in. Content then gets brought in. I then had to promote the first set of headings to be the header for each of the columns, but then tell it to filter out and effectively exclude all the other column headings. That's my data set. Close and load, and the data then gets loaded into an Excel table as before, and we can then carry out any further interrogation that we might wish to carry out. We might want to do some stats on our visitors by IP address, by pages that they're visiting, by the dates and times that they're visiting. Obviously, I don't have a lot of data here with just 40 rows, but the principle would be the same if you had 4,000 rows, 4,000 pages of 4,000 rows of data in a single folder. Now, the steps that I've carried out are great. It's picked up the files in that single folder, amalgamated the data because of the filtering that I've done and added in the columns, and I then have the data to play with. That in itself is quite good, but the real power now comes. Notice there are 40 rows there just for the moment. Let's go look at the working files. What I want to do is take this working file here, 2016-0105. I'm going to copy that, and I'm going to drop that into my logs folder. I now have another file in my logs folder. So the question is, do I now need to go back into Excel and go through the same process, tell it to look in the logs folder and pull in the additional file? Well, the answer is obviously not. All we need to do is go back to our Excel file. The work has already been done in the query editor to tell it which folders to look at, what to use as the headings, what columns and rows not to see, changing the data type. All that has been done. All those instructions are saved. All I need to do here is refresh this particular table, and look, the number of rows has gone from 40 to 60. So it's imported another 20 rows from the new file that I simply just dropped into that folder. Once you've gone through the process of setting up the Excel file with the get and transform option to interrogate that folder, doing any of the tidying up that's required, so we formatted a column, we hid the rows of data that effectively contained a repeat value of the header, and then everything else is just brought into this table. This is just so powerful, it's hard to comprehend how powerful it can be, because we're only dealing here with 60 rows of data, 5 small text files, but they could be absolutely massive text files, all being brought in for you to then interrogate in Excel and produce your visitor stats if that's what you want to do from the logs that we've got here. The process is pretty straightforward, the same as we've done already with get and transform. New query from file and then from folder. And then you're effectively down the same steps. We have to expand the files to see the contents, and then we have access to that information inside those text files. PowerMap is a new tool available to you in Excel 2016. Pretty easy to use, you just have to make sure you have the right add-ins activated. Now you'll know which they are because as soon as you try to use it, it tells you to activate them. So here we are, we're in a fairly basic file, sample sales, it's in your working folder. We go to the insert ribbon, we choose 3D map, and in the drop down, we select open 3D maps. Please enable the data analysis add-in to use this feature. And we don't have to go find the data analysis add-in, we can just click enable here and it will do the work for us. The map tool then loads and you can see we're in a slightly different window here and we just want a basic map based on the sales data in the file we were just looking at. We can see it's got country and sales. We can then move back to the 3D map at any stage, either going back up to 3D map, open, or because it's open on the taskbar, we can just Alt and Tab to it. And we're back at our map. Now on the map, let's just close the field list. We don't need that for the moment because we've got basic data. It spotted the geographical data being the country. You can see that here, country. Now there is a drop down here to change what I've called the country to a different type of geographical area. If, for example, it hadn't spotted the countries and it had tried to call them cities, I could come in here and change it to country. Or it might be a county or a state or street, a postal code, or even the latitude and longitude. As long as you've got a column that contains geographical information, then the Power Map will be able to map it. You can see on our world view here in the middle, I can scroll round and I can zoom in and out. Each of the countries in my data, I've got a little blob. Now the size of that blob represents the amount of the sales. You can see there, blob for the United States right in the middle, and then the blob for Brazil is right in the middle of Brazil. Now the blob is probably not the best choice of representing the sales information that we've got. Potentially we could change this into any of the other 4 options here, and the one option I do really quite like is the heat map. So if I choose this end option, you can see that the colour now represents the relative size of the sales, and because we're using countries, the whole country gets coloured in that colour. So whereas a bar or a column chart might work well for smaller areas, perhaps cities, perhaps even down to minute postcodes, when we're dealing with countries which are quite a big expanse of the earth, the heat map really does quite well. Now back in the data, we can make any changes we like within this information. We can just move this little label up a little. So let's say, for example, let's make Italy 500,000. So it seriously towers above the rest of the data. Then come back to the 3D map and refresh the data. Then in the heat view that we have here, very little has happened. You cannot really tell that that's gone up. So why don't we change from the heat view to the stacked column? Now at the moment we just have little blobs on each. But if we add a height to the stacked column here that is based on the sales value, so we go plus sales, then you can see the height of the column that appears on Italy is much, much bigger than the heights of the columns you get on the United States and Brazil. So the height of that column is being controlled by the value of the sales field. And then, after following the logic there of the height, if we now change back to the heat view here, we can see that Italy is so much darker blue because the sales value is having a say on the blueness. And then the other countries are much, much lighter. If we then go back to our data, and let's reduce that back down to more than the others, but not so dramatically higher, so 75,000. Back to our map. So we'll look at Italy before we refresh, and then refresh. You can see that the blueness come back a little for Brazil and the United States. It's still a lot darker than England and France, but the other two countries, which are much now closer to it in value, have become a little darker blue. So Brazil must be closer than the United States is, just because of the variance in the blueness. So that's just a little tour of the 3D map. The idea then behind the map is that you would create a small tour that you can then either turn into a video, that you can then put into PowerPoint or out on the web. But the information in the little tour is based on the data you have in Excel. In our case, in our mini little table of information here. Obviously, it can deal with lots more rows of data than we've got, but you have to bear in mind that at least one of the columns of information has to hold a geographical type of information. We can see over in here, types of geographical information it's quite happy to deal with are latitude and longitude, an X and Y coordinate, city, countries or regions, counties, states or provinces, streets, postal codes, or even the full address. And then there are capabilities of dealing with a custom region or a custom region set. But for our purposes, we're dealing with one of the columns of data has to make sense geographically for the Power Map to then be able to chart your data. Before we explore in any more great detail the 3D Map Power Tool, we're just going to have a quick look at an alternative, which is a straightforward 2D map that will sit in your Excel sheet rather than being an external item that you can create a video from. It's not quite as fancy, it's not quite as dynamic, but it can be quite useful if you want to represent geographical information. Now this tool is available from the Office Add-ins store, so unless you already have it, you need to go to Store, which brings up the store section of your Office add-ins. And then if you search for a heat map, this little tool here, the geographic heat map, it's a free add-in to Excel. I will trust it. And we get a little rectangle here that appears. Now, once you've actually installed the tool once, you don't need to keep going to the store each time. You'll find it under My Add-ins. Well, here we are. Welcome to the geographic heat map. Let's get started. Select the data. So then I need to highlight my data that contains the geographic information, so in this case the country, and then the information I want to graph, which in my case is the sales. So OK, choose the map you would like to see. It only has two choices, which is either the USA or the world. Well, I need the world because I've got countries from all around the world. Choose your columns. The regions are controlled by the country and the values are controlled by the sales. We're looking at two-column information. Now, if your data contains 3 or 4 columns, you're only going to be able to use 2 of them. One is your geographic information and one that will be sales, purchases, costs, population, whatever you want to determine it as. Then have a choice of 3 color schemes, red to green, green to red, or grayscale. I'm going to go with grayscale. I'll get variances of grayscale to represent the different sales values. If you went from red to green or green to red, you'd be more green or more red for the higher or the lower values. And then a title for your chart, sales, and then save. And that then produces me the chart here, which I can move. So it creates it within the sheet, so I can see it next to the data. And because I've gone for grayscale, I can see that Brazil is much, much darker than any of the others, so that must be the highest value. And looking at the data, I can see that it is. Now there's a little wheel here for getting in and changing the information. So I could go from green to red, save. So red's the highest and the darkest green, it must be the lowest. with a yellow for in between. That looks a little bit neater, doesn't it? Now, the whole point in exploring this little tool is not to detract from the 3D power map, but just as a straightforward flat alternative that will sit within your worksheet. So it will link to the data in your worksheet and quite happily display that on a geographic map. It does have pretty serious limitations when compared to the 3D power map, but the reason I like it is it's a free add-in and it works by sitting on your sheet rather than being an external application. Now, it only works with countries, as we've done here, or US states. So if we open another working file, which is sample population, which is some made-up populations for a variety of US states, if I highlight the data and go to my add-ins, because I already have it, geographic heat map, we'll then load a new heat map, get started, select the data, and you'll see because I pre-highlight it, the data's already selected. This time I do want a USA map. The regions are controlled by the column called city. The values are controlled by the population. Let's go from red to green and put population 2016. Save. And then you can see that it maps the values against each of the states in the USA. Notice it pulls Alaska down here rather than up there next to Canada. And Hawaii gets pulled up a little bit further north as well. But the idea is it geographically represents with a small chart on your sheet. So it's a free add-in. You get it from the Microsoft Store, accessible here from the Insert ribbon by clicking Store. Then it's installed for all future use under your add-ins, and it will map countries and a value, or US states and a value, onto a geographical map of the world. Well, we've seen how easy it is to create a simple 3D map. What we're going to do now is explore the options available when creating a 3D map, and then we'll come back and actually create those options ourselves. We're going to take the working file 3D map tours. Now, this data file has in the data that we've used previously, which is the population data for the world, which is a great thing to map on a map of the world, and it contains some 3D maps, hence this little dialog box here. Now, you can move this dialog box, it's simply just a label. 3D map tours. This workbook has 3D map tours available. Open 3D maps to edit or play the tours. The 3D map tours are on the Insert ribbon. We come to 3D map, open 3D maps, and it actually contains 2 tours. Now, what we need to explore here are the difference between tours, scenes, and layers. Your Excel file with your data in can contain any number of tours that you would like. They would simply then be listed here, and we can create a new tour from here, which we will do subsequently. So any of these 2 tours can now be opened. And a tour is effectively a mini movie, a tour of the world, shall we say. Let's open Tour 1. When we open Tour 1, we see that it actually contains a number of scenes. Now, scenes are a little bit like a movie or a play in that they are different demonstrations of information. So in our case here, you'll see shortly, they are different demonstrations of the same data. And when the tour is played, they play chronologically. So they play from scene 1 to scene 2 to scene 3. Whatever you do in scene 1 here, and we set that all up over this right-hand side, will play first, and you can see it takes 10 seconds. When I hover, I get a number of options, such as deleting the scene, playing the scene, and then scene options. Scene 2 takes 10 seconds, and scene 3 takes 10 seconds. So a scene is an element of screen space that will occur. Now, within any of your scenes, and if we click on scene 3, so that then loads into the right-hand side, so the data that is building scene 3 loads into the right-hand side. And what we have here are multiple layers. You can see on the right here, we have layer 1 and layer 2. And the difference between the layers is the layer is within a scene, but can contain different sets of information. So my layer 1, for example, contains the country and the median age, and is being displayed here as a color swatch. Let's just close the file list. So the density of this purple determines difference between the median age of all these countries. So if I move around, you can see the purpleness either decreases or increases. And if I hover, I can see there the average age in Canada is 40.3. If I hover here, Mexico, it's a lower average age, therefore it's a lighter purple. Now at the same time, I just minimize layer 1, we have layer 2 that is showing me as a bar chart the actual population. So if I move to these little bars, I've got to make sure I get the cursor in the right place, that one there, I can see the actual population. And the size of that column really is indicative of the relative population compared to the other countries. So if we move around where we have the 2 largest countries, China, which is a really large tower, and then India, which has a really large tower, we can see the relativeness. So we're actually using the world there and displaying two lots of data. By doing that, we've used layers. So on layer 1, we have the median age, and on layer 2, we have the actual population. That, in essence, are the three main components of 3D map. There is the tour, so you can create any number of tours, and a tour is effectively meant to show you something. I'm using this tour to show you about the population of the world. Within that tour, you can then break down into scenes. So we have in ours scene 1, which is actually showing you the population of the world. Again, we've used some colours, but used blue. So you can see the darkest blue is China and India. We're then imagining that this is moving forwards like a little movie. In scene 2, we're showing the area of each country. We're using this colour coding here, but a different colour. And you'll see how we can change colours when we get to changing colours. So the largest country there with the darkest orange is Russia. And then if we were able to find the smallest in the kilometres, which we're unlikely to see without really zooming in, because that's going to be tiny little Monaco around here somewhere. That would be the lightest colour. And then our scene 3, which has multiple layers. So you have a tour, of which you can have multiple ones, but the idea being that a tour is a particular topic of information. Scenes within your tour, again, you can have any number of scenes. The idea being that you progress from one scene to the next, and they go in chronological order. Scene 1, scene 2, scene 3, scene 4, etc. And within a scene, you can have multiple layers of data, should you wish to demonstrate 2, 3, 4 things. Now, you've got to get the balance right between making the map look untidy and messy, and making it be useful to people. Now, in Tour Editor, which we're in at the moment, we can rotate the Earth in any of the directions. We can zoom in using the plus and the minus. We can click on rotate the Earth. There I'm in the middle of the ocean. And where you leave the Earth is how that scene starts. About to start here, for example. Now, once you set your tour up, you can rename a tour just by clicking in here. It doesn't have to be Tour 1, Tour 2, Tour 3. And you can see what it looks like by playing the tour. And you have two options really, play from the beginning or play from the current scene. That would be quite useful if you have a few scenes and you just want to see from here on. We'll play ours from the beginning. And when you play a tour, it plays each of the scenes chronologically. Obviously, there are 10 seconds between each scene. You can see there it's changing from one scene to the next, rotating the Earth to start, in this case, scene 2, in the same place that I left it in the design mode. And then we're changing to scene 3, again rotating to the same place that I left it when I'm in the editing mode. You set up your scenes and you leave the Earth where you want it to start the scene effectively, and between that scene and the next it will rotate the Earth to come round to where you started from, the same zoom, the same position on the screen. Once you've watched the tour, because we're only building the thing at the moment, escape will return you back to editing mode. Back in the 3D Tours editor, you are then free to go ahead and add new scenes, add new layers, and customize both the layers and the scene that you've got. And that's where we're heading next. We have our data, and we want to know how we can go ahead and create a great 3D map for demonstrating that data in a graphical way. So our data is the population data. We have that in a working file already, live population data, and we'd like a map, please. Now, you either highlight all the data, or because our data is actually sat within a table, I just need to be in the table. I don't need to actually highlight it all. I then go to Insert, 3D Map, open 3D Maps. We are then presented with the map editor, which gives me my first tour, which I can rename, Population Earth. It gives me my first scene, because things don't really work without a scene. And then on the right, I can edit that scene. Now, already, my 3D Maps has spotted my location field, which is the country one. So I don't need to do anything more about telling it what the geographical field is because it's spotted country. If it hadn't, I would need to add that in myself. This is my field list, so these are my columns in my Excel table. I've got the area of a country, the name of the country, the density of the country, the median age, population, and then the ranking within the world of that country. So I can add to my chart. I've got the locations marked up, so I've got little dots on all the countries in my list. If there isn't a country in my list, then I don't get a dot. Notice the little dots floating around in the ocean. I'll need to be very close to spot what those dots fall on. There we are. There's an island there, Kiribati. Let's zoom back out again. So I see the larger countries of the world. The little dot in each country is just simply a dot. If I want the size of that dot to be relative to a particular point of data, so within here, I might, for example, choose population. So in the height, let's add a field and choose population. Legend pops up. I actually don't want that for the moment, so I'm going to right click and remove that. And then my little dots now become columns, with the height of the column relative to the amount of population compared to the other countries. So the two biggest ones here, we have China and India, have the highest towers. Now I can change that tower into a clustered column, which, because I'm showing one amount of data, actually doesn't make any difference. If I were to add a second item in, then I would see two columns next to each other. Now, comparing the population to anything else wouldn't really make too much sense because all the other numbers are a lot smaller. Or I can show things as a bubble, then your bubble size is relative. So that's quite a good way of doing things. Or I can show that as a heat map, not so exciting. Or I can color code each country. Now, this is quite a useful one. It is quite resource hungry though. And the color coding is blue. So the dark blue is the highest population. The least populations are obviously lighter blue. Now, if it's not blue that you want to work with, you want a different color, then what you'll find, if you scroll down the right hand side, we can go into layer options. And here we can customize the color. So it doesn't have to be blue. I may want the variances of green, for example, quite bright, or purple. So what you're doing when you choose the color is you're choosing the highest value, and then everything else is a lower shade value of that. This goldy one here is quite good. I quite like that one. So I can control the color there of the countries. So now I've added some data. It spotted the geographical field, which was country. I added a value that I wanted to graph, which is the population. I then chose to view that on a regional basis, so each country gets a particular color, and then we can control that color coming down to the layer options here, so I'm not stuck with the default Microsoft blue. Now, as well as being able to customize the color, I can customize what's referred to as the data card. Data card is what you get when you hover over a country. Let me just close the field list so we can see. So if I hover here, I get the name of the country and the population. If I hover here, I get the name of the country and the population. This is the data card. Over on the layer options here on the right, I can customize the data card. So I'm seeing the word population. I can edit that and say population 2014. Okay. And then when I hover, I see the name of the country and then population 2014 as the label. As well as being able to change the label effectively, I can go into customize, and you can see on the right here, that's what I'm seeing, but I can change that to template 2, template 3, template 4, which doesn't actually have the name of the country if you notice, template 5, template 6, background to 1. If I didn't want the name of the country, perhaps because that was particularly obvious, I can come across to here and just see the population. So OK, and hover, you can see then I don't get the word country, I just get the value. It's China and its population. Change that to a different template value, perhaps 6, which shows things more horizontally, and I get to see China, population, etc. So I can control the data card, I can control the color, and we've seen already that we control what data is displayed on this particular layer within this particular scene. So I'm on layer 1 within scene 1 of what effectively is Tour 1, but I've renamed Tour 1 to be population Earth. I can rename layer 1 to be population 2014, and I can even rename scene 1 over here using the little wheel, scene name population 2014. Whilst I'm in the scene options, you can see that you can make a scene stay on the screen for longer. Its default is 10 seconds, but we can increase that, decrease that. We can change the transition duration. So that's how long it takes to change from scene 1 to scene 2. Obviously at the moment we only have a scene 1, but we can control how long that takes and even add an effect. So how the Earth moves when it moves from one scene to the next. But we can see that in action when we have added an additional scene. That's the scene options, accessible through the little wheel here, allowing you to rename scene names, over here layer names, over here tour names. Once you're happy with your tour, you can watch it as we've seen previously. You will get back to Excel by going to File and Close, and then you're back in Excel. When you save the Excel file, you effectively save the tour as well. The tour is part of the Excel file. There's no separate save option. Re-edit any particular tour, we go back to 3D map, open 3D maps, choose the particular tour you want to edit, then opens. You can then go ahead and make any changes you wish to make. We're going to take our working file, Live Population Data Tour 1, which already has a 3D map within it, and look at how we can add additional layers to our map. So we go to the Insert ribbon, 3D Map, open 3D Maps. We then see listed any tours that we have. We only have one at the moment, Population Earth. So we click to open, and we're then taken into our tour with Scene 1 showing the population for 2014. Now what we'd like to do is display on this same scene additional data. So let's minimize that layer and click Add Layer to add another layer. On this layer, you can see it's already chosen country. It's great that it manages to spot that each time, but I'd like to now show the age. We click Add Field and choose Median Age. I'm going to delete the key for the moment. Now the age is being shown as a column. Unfortunately, it's being shown as a column, if I move the Earth around, in the same color scheme as the full population. So let's come down to Layer Options, which we know about, and change the color for our columns to purple. So now the purple column represents, relatively between all the others, the median age of each country. Now you do have other options within here. You can control the thickness of that column. I can drag that and get really big columns. Again, it all depends on what you're trying to represent. And I can change the relative height. So I can make them a lot taller. They still stay relative to each other. So the really tall ones are really flying up here. Some average age here are quite tall. Or I can bring that down. So again, relatively, they're a lot smaller. Let's just take the thickness down a little bit. So that works for me. This layer is layer 2. And I'm going to rename that to average age. So I know then when I'm looking in the tour what this second layer of data does. Now let's add a third layer. Add a layer. Again, it spotted the country, but we're going to set our data heights based on the density of population. So that's how many people per square kilometre. Again, I'm going to remove the key. Notice that it used the same colour, so I need to come to Layer Options and change the colour. Otherwise, I'm not going to spot the difference between my ages and my density. Now let's go for a bluey colour here. Changing the thickness of our columns and probably the relative height as well, just so I can see them together. So let's move to a country with a high density over here. You can see the column really is quite high there, Macau, and then China where the density is low. But I hover here to get the right information. I can't quite hover, zoom in on the right column because it's so much smaller, 145 people per square kilometre. Now there is a way around this. We know when we hover over a country, which is quite easy to find because they're bigger areas, I get the population. What would be quite good if that data card contained the information that's contained in the other two columns, really. Well, it can. Let's firstly rename layer 3, which is our density. And then we're going back to population 2014, coming down to its layer options and customize the data card. I'd like to add to this data card the other two bits of information. So I can add a field, which is the median age, and I'll rename that to average age. And then we'll add an additional field, which is the density, and we'll edit that, really just to lose that sum at the end, which I can do just by putting a space. If I'm quite happy with density people per square kilometre, a little space will make sure it doesn't put the word sum at the end. Okay, let's lose the field list, and now when I hover over a country, I get all three bits of information. I still get the age when I hover over the purple columns, and if I hover over a blue one, I get the density, but I can lose those as well. Let's condense that layer and look at the density layer, come down to its data card and actually show nothing. I'll just get the country when I hover over now. Let's just leave that as value. So that's the density one. So if I hover over a blue one, I just get the name of the country. And do the same for the average age, down to the data card, delete the median age, and use the template that only shows the value. So I just get the country name. That way all the data is displayed in the data card over the actual country. So I hover, I get all three bits of information where I can see graphically the difference between average ages and density by the two columns on the chart. But depending on the perspective I'm given or where I'm looking, I can see average age and then density. And a hover shows me all three bits of information: population, average age, and density. I've done this by adding three different bits of information to the same scene, but on different layers. That might not be what you're trying to do. You might want to have all the same three bits of information, really, but on different scenes. So they're down here, That way you have to progress through the tour to see all three bits of information. By putting them on the same scene, I see them all at the same time. By adding all three bits of data to the same cue card, I see all three bits of information just on a hover. So I can control the colours and which bits of data get shown where on the actual map. We saw how we could add multiple layers to a 3D map, therefore representing three lots of information, three lots of data. That's quite useful if you want to be able to compare those three lots of data in one place at one time. However, if you want to take those three lots of data and compare them by moving from one to the other, then you need to use scenes. So if we now do exactly the same data options, so the average age and the density, add those in as different scenes and see what difference that makes to our 3D tour. In order to do that, we're taking the working file Live Population Data Tour 2. We go to our 3D map section, don't forget, it's on the Insert menu. We have a single tour, which is Population Earth, and we open that so that we're in the map editing mode. So we have our Scene 1. Let's rename Scene 1. So we go to the little wheel. Scene 1 is the population. I then want an additional scene. So we go to New Scene, and we have options for copying the first scene, so copying the population scene, creating a new scene using the world map, or creating a new scene using a new custom map. Well, let's go with the world map. Our data has already picked up the location field, so we just need to add the height, which is going to be our density. So let's rename the layer, density. Let's rename the scene, density. Let's get rid of the legend and change the data representation to our color mode. And we'll even change the color. So our first scene is in gold. Let's make our second scene in a lightish red color. So the darkness of that red will represent the density. Now, even though we've chosen a brighter color, if we look around the world, there isn't too much variation. Obviously up here we do have some where the density is quite low. Now what we can do to force fuller variation is change the color scale here from 0% right up to 100%. And that way you can see there's much more difference between what effectively is China and then Russia, which is very low density. Only 8 people for every square kilometer. So let's check we've named that layer density. Then we want to add another scene. Do we copy density or do we create a new world map? Let's create a new world map. Copy option is quite useful if you're just taking current map and perhaps changing it a little bit, perhaps rotating it to a different part of the world. So here in our new scene 3, this is going to be the median age. Let's remove the key again, rename the scene, average age. The renaming is just to make life a little easier for me so I know what's happening in each scene and then each layer so I know what data is in each layer. Average age. And again we'll go for the color visualization. Let's remove the field list and let's change the color from the default blue. So we've got a gold, we've got a ready. Let's go with a purple color. Purple now shows the average age relatively. So obviously those darker areas, USA 37.5. Germany here, that's not dark at 45.9, probably the darkest I would have thought. 46.2 for Japan. So that's the median age. So now we have all 3 sections of data that I want to display in my tour in separate scenes. Now they're in separate scenes, I can make them go from one to the other. So from population to density to average age, rather than having all 3 bits of information on top of each other, as we did with the layers. Now that I have scenes, we can look at the animation between scenes. So in the little scene options here, I can control how long this scene remains on screen. Now I'm going to leave it at 10 seconds for display purposes. For a final tour, you might want that to be a lot longer, because as well as being able to control the scene duration, we can control how long it takes to change from this scene to the next scene. Again, the default there is 3, but we could up that or lower that. And we can add an effect to our scene. So if I want to add an effect of fly over, then that will give the impression that we're flying over the Earth for those 10 seconds. Close that. Same for the density settings. So I'm going to leave the times the same so that it's not on screen for so long, but we'll change the effect. Instead of flying over, we'll rotate the globe. And we have a control here of how fast things happen. If we want the rotation to go faster, we increase that. If we want it to go slower, we decrease it. So we'll leave it around the middle. And then the average age seen into its little wheel for settings, and we'll add a different effect there. So we've had fly over, rotate the globe. Let's have push in. So I've added 3 different effects to each of my scenes. Let's play the tour from the beginning, and you'll then see the tour starts, and you can see here the globe is rotating just for 10 seconds before it moves to scene 2. And then you can see it moves within 3 seconds to the next scene, which is now red for my density. And then 3-second change into the next scene, which is the average age. You can see that that's pushing in. So it's like zooming in. And then we're at the end. So escape to come back into the 3D map editor. You're in control of what happens on each scene by adding layers of data, controlling the colors, changing the location, and the zoom controls the start point for the scene, so where the Earth starts from. So if you're trying to emphasize a point for a particular country, we might start from that country. So for example, we might start with India in the middle. Your second scene has its own start point, so I might want to zoom in and start with China. And then the third scene, I might want to start with the other side of the world, with perhaps Canada being at the forefront. So again, I can zoom in. So I go back to the beginning, play tour, play from beginning, and the tour starts, as you can see, from India, but it's got the same effect, that rotating effect. So depending on how long I've given it will depend on how far round the Earth it goes before we then move into scene 2 for the density, which is now rotating roundwards, before it then changes to scene 3, rotating all the way around to Canada, and then moving into Canada for our average age, which is then pushing in to the globe. Escape. Hopefully that's covered the scenes ability here. You can have as many scenes as you like. The movie, the tour, whatever you want to refer to it as, will go from scene 1 onwards. You can change the order of these. Perhaps you'd like average age to happen before the density, no problem. In this left-hand pane here, we just simply grab a scene and move it into its new location, and then they are still numbered 1, 2, 3. But they now happen population, average age, and density. And you've therefore created a 3D tour ready for people to watch about the population of the world. We know how to create a 3D map based on our data, but what we might want to do with the map is actually filter out the amount of data we are seeing. Now you can do that in one of 2 ways. You could filter the data prior to creating the 3D map, so I could take my data as it stands here, the population of the world, and just get rid of some of the data, then create my 3D map. However, sometimes you actually want to do it in the 3D map, because you might have one scene that shows all the data, and then another scene that shows a filtered amount of the data. So we need to be able to do the filtering at the 3D map side of things. So let's take the live population data file and create a new 3D map. So insert 3D map, open 3D maps. We don't already have a tour, so we're straight into the editor. Country has already been chosen as the location. Let's add the population as our height, do it as the visualization option. And for the moment, let's remove the layer. So this is showing all 220 something countries based on their population. Now, if I only wanted to see perhaps the top 30 countries in the world, we could firstly keep this scene because that's got everybody. So let's take a new scene and create a copy of scene 1. And we're just going to edit the name of this one to be top 30. That way you can see the difference between the two. So we're now in scene 2. We don't need the field list because the data's already set up. What I need to do is come down to filters, and then I can add a filter. Now I can do that filtering based on any of the data options, but I want to do it based on the rank. And you can see here we then have a slider. So we have sum of the rank, or the average, count, maximum, minimum. Well, actually there's no aggregation because the rank is simply a number from 1 to 232. And then I can slide this to the left until I get to 30. And then I will only see the top 30 countries based on their population in our scene 2. So in here, I can see the larger countries, China, I can see France, I can see America, I can see Brazil, but I can't see any data for the smaller countries here in Africa or over in Eastern Europe. None of these countries are marked on the map because I've asked to only see the top 30. So that's the ability there to then filter, which can be quite useful when you're creating a tour. As we've done here, we've duplicated a scene to create another scene. This scene shows only the top 30. If I then wanted to duplicate this scene again, view scene, copy of top 30, and let's make this the top 30 by age. Then we can come across here, change the ranking not to be between 1 and 30 of the rank. We need to remove that and add a filter based on the median age. So you can see here, that we don't get an option of 1 to 200 and something because we're dealing with the ages, but we can drag the slider so we get the people, the countries, whose median age falls between a value and a value. Because I'm looking for the top 30, I need to keep the topmost value and then slide the lower value of the average age upwards. Now, I'm not going to know if I've got exactly the top 30 without actually counting the countries that appear. The other option is to change the value, because currently it's looking at population, even though it's doing it based on the median age. Let's remove the population from there, bring back the field list and put the median age in. And then I'm getting the median age, so I can see the countries with the highest average age here. And there is quite a predominance there in Europe, and then Japan over to the east. That appears to be about 30, probably a little less than 30, but I can slide that down a little, bring in a few more, which brings in Canada as well, 40.3. So we have the additional ability here to filter out what you're seeing. And you can see you get these sliders based on the value of the column that you've chosen. When we did the top 30, although that was based on its data with population, so the colouring was based around population, we did the filtering around the ranking. Now the ranking within our original data table is on the population. So going from 1 to 30 in there works fine. Then with the age, we couldn't really do that with the ranking because that's on the population. So we went for filtering by the actual median age itself, dragging the sliders, and you can drag the left hand to just the minimum one or drag the right hand to just the maximum one. And that will work with any of the other data values we have. So it may be that we wanted to do it with the density or with the area, or with the population itself, looking for populations between two set values. You can see here by adding in the filtering capabilities, you would have reasons for possibly having multiple scenes, because each scene would be a different set of filtering that you're trying to demonstrate in your tour of the population data that you have. That's additional filtering which is applicable to the data that you place in any layers that you then place in any scenes. Let's take the Live Population Data Tour 4 working file, which already has a 3D map within it. So we can access that by going to Insert 3D Map, Open 3D Maps. There's our tour, Population Earth. And then we're going to have a look at changing a number of the customizable options. Now, one of those options, if I just zoom out of this first scene, is to change the globe into a flat Earth. And that's done by simply choosing Flat Earth at the top here. Again, I can zoom out and you can see that that becomes a flat Earth. Now, depending on the kind of data that you're trying to represent, here I'm doing the globe, so it works better with a globe. Sometimes you might want a flat map rather than a round one. Now, that option that I've just selected will only affect the scene that you're currently looking at. So if I have a look here at scene 2, which is the density, that remains a globe. But the first one, the population one, remains a flat Earth. And you can turn the flat map off any stages by clicking the icon again, and it becomes a globe. So it's an on-off switch straight up here on the map, and it only affects the current scene that you're in. Another customizable option is the theme. If I go to the drop list here on the themes, there are a number of built-in themes. I'm currently using the default one, but there are others. There's an aerial color. You can see that the color of the water then changes. Again, what you'll notice is that this only affects the current scene. These two scenes completely unaffected the fact that you've changed this theme. That means that you could have a different theme for each scene. That's a white one, grey colour one here, nondescript dark one there. In reality, there aren't too much to choose from here, and most of the time I tend to stick with the default first one, because you can colour your data in anyway. So I've got that control. I might as well leave the colour of the water as blue. Although the only other nice option is this one here, which gives you sort of a nice background colour. But let's leave that as the default. Remember, flat map and the theme only controls the current scene. Other customizable options are to have the map labels on. If you click the map labels, depending on the zoom, will depend on what you see. So at this sort of world view zoom, I'm seeing just about, if I zoom in a little, the names of the country. So I can see India, names of the seas, the Indian Ocean. Now, as you get closer, so if you happen to be mapping some particularly close-up data, you start to see town names. So here I am in India, zooming in, and I'm starting to see the names of towns. As you get even closer, those towns break down and you can start to see villages. And you can see I can start to see river lines and road lines. So the closer you get in, see road numbers. You get more and more map information. So each level of zoom just gives you that bit more breakdown. All the way out at the world view, you just get the names of the countries. So I come back out a bit. Lots of coming out to do there. Towns will disappear, and you get the names of the seas. So that's map labels. Again, just like the flat map and the themes, only affects the current scene. So that's only happening on the population scene. I go to density, and I don't have labels. So the settings are per scene. If we want to bring back the legend, each time we've had a legend, I've deleted it, but you can bring it back at any point. Click legend, and that gives you the legend for this particular scene. Again, it's a scene setting. Now, the actual legend itself can be resized, so it doesn't have to take so much of the screen up. And I can see here on the population one, I'm showed the lowest value and the highest value. Again, a scene setting. When I go to density, it's not there. I need to ask for it back if I want it here as well. And again, it's resizable. I don't need to see all of it. And the density goes from no people per square kilometre up to 25,548 people per square kilometre. That's the legend per scene, just like the other settings. The legends themselves have a little bit of customization within them. If you right click a legend and choose edit, you see that we can change the font of the title and the colour and the fill and the font and the colour of the category. Now we can turn the title off because the label here actually says the same thing as the title, and that would make my legend a little bit smaller as well, so I can resize it down even more. I can also send to back, but obviously that will depend on how many other legends you've got, which in this case is one. I've only got one set of data. But if we were to put layers of data on, you would get a key for each one of those layers, and they would all sit on the map. At that point, you'd want to be able to control which one sits in front of the other, if there's any overlapping. The customization options that we have are the ability to flatten your map, so you get a flat earth, have your map labels on, so we get the names of the countries, or depending on the zoom, you'll get the name of the town, name of the village, the road numbers. We have a number of themes to choose from, although the choice isn't fantastic, and you can decide whether you want to keep your legend or not. So once you've got the legend, you can't turn it off using this box here, you have to right click and remove. Now you can also add in a text box that effectively allows you to add your own content. So title, I'm on the density layer, so I'm going to put density 2014. Description, this shows the number of people per square kilometre within each country. Create, and you can see that then appears in the middle, but we can move it across. We can resize it so it's a different shape so it doesn't encroach on the map. And if you right click and edit, we can even change the font size. We could go down to a lot smaller, 16, and for the description, 12. That gives me a much smaller text box to play with. I could then perhaps stick up here on the top left of my tour. So you can see that you can build tours, scenes, layers within your tour and add your own labels here rather than just having the legend that would help explain what people are seeing on each of the scenes as the Earth rotates before them. Now there are a number of things you can do with your 3D maps once you've created and you're happy with it. One is you can leave it in Excel, you can distribute the Excel file, and anybody who's then got the Excel file, told to look at 3D maps, can watch the tours that you've created. Alternatively, we can take snapshots of the 3D map and place that in another application, or we can create standalone videos from the 3D tours that you can then perhaps upload to the web or place on DVDs. Let's take the live population data tour 5. We'll open our 3D maps. We have our tour in place, which is population Earth. Now it has 3 scenes, it's showing different information. And say, for example, we want to take the average age scene here. Let's lose the field list so we can see we've got a label on here, and I'm displaying Europe as the sort of zoomed in area. What I can do is take a snapshot of the zoomed in area. So you can place it where you want, perhaps move it across a bit, maybe down a little bit, so that my labels are up there and I can see most of Europe. I'm quite happy with that. Once you're happy with what you can see, because that's how the snapshot works, then we go up to the toolbar here and click capture screen. One click, and that takes a screenshot of that central map area, but without these icons, obviously. We then go to our alternative application, so it may be that I'm creating a Word report. We simply then paste. because the snapshot has placed the screenshot of the map on the clipboard. So all I do is Control V, paste into Word, and you can see the map appears. So it doesn't have those navigation keys because we can't navigate. This is simply a screenshot, including any labels, any legends that you might have, and also including the Microsoft copyright symbols here and Bing map. We can't have everything, but that will paste into any application that accepts a graphic as a paste option. So that might be Word, it might be Publisher, it might even be a graphics program for you to then do further elements. Obviously, the color coding here represents the data that is behind the 3D map. So if we go back to our 3D map, maybe I wanted to add the labels to this one and then screenshot again, back into Word, let's come down to a new line and paste, and we get the screenshot with labels. So that's one option. The other option for exporting is to actually create a video of the tour. So exactly as you see when you click play, so that will include all the labels, all the rotation. We can create a video of that, effectively exporting that video to use elsewhere. We click create video. We have a number of choices to make now. Are we going through a top quality video, DVD quality to place on a DVD? Or is it just to be viewed on a computer or a tablet? Or is it just a quick small video that we can perhaps export to YouTube? There is even an additional option here for adding a soundtrack. I can browse for a soundtrack. And if you look in your working folder, you'll find there is one there, royalty-free one called Perspectives, which we can add as a soundtrack. The options for the soundtrack are to loop until the video is finished. So if the soundtrack is shorter than the video, my video is 36 seconds long, then the music will replay. If it's longer, then it won't get to the end. Do we fade it out and do we fade it in? Apply that. I'm going for the short export and create. Where do I want to store my MP4 video? Well, back in the working files. Notice all it's done is call it the same name as the tour, which is fine. Save, and then we have to wait for the export to complete. The video is then exported, created an MP4, so it's now exported outside of Excel. Then you can play that on any device that will be able to play an MP4, be that a mobile phone, computer, or you can perhaps upload it to YouTube for viewing elsewhere. That video has been saved in the working folder, so I simply need to navigate there to see if it exists and if I can play it. There's the video, Population Earth. I'm going to open that with VLC on my machine. It then plays each of the scenes of the tour with the awful theme for the first scene, obviously, but then changing through to the second theme, again rotating the Earth the whole time. And then we have the animation that leads us into the third scene, which is about the age. And then at the end of the movie, it simply finishes. I went for a low quality export there just to speed things up. If you wanted to place that video somewhere on a DVD, perhaps you would probably go for the highest quality one. Bear in mind that the export will take that a little bit longer. Having more scenes and longer duration, more animation will take a little bit longer. But it gets there, and then you've got an external movie that you can then show to people, send to people, burn to DVDs and send out. Totally your choice. You've got your base data here with our 3D maps, turning that base data into 3D map tour, which can then ultimately become a video. Welcome to this chapter on the power pivots. Now, a power pivot is effectively pivot tables, but with some real power. In Power Pivot, we take our data from an external data source. Now, you can do that with normal pivot tables, but within the Power Pivot tool, which is an add-in, and we'll look at how you can add that, you have very little limitation on the quantity of data and on relationships in that data. We can connect to a relational database, be that in Access or SQL Server, and pull through not only the data, but the relationships and as much data as you feel you need. The Power Pivot works in its own memory space, so will work a lot faster than you trying to refresh a normal pivot table. But apart from that, the actual tools within the Power Pivot are pretty similar to the pivot table. You're going to find yourselves fairly comfortable at the pivot table stage. Potentially, the connecting and importing the data stage, things will be a little different. It has a lot in similarity to the Power Query options that we've investigated already. Who can have and use Power Pivot? Well, those people who have 2016 Excel as a standalone copy. If you have the 365 Home Edition or 365 Student Edition, you will not have access to the Power Pivot add-in, I'm afraid. you'll need to make sure that you install the 2016 standalone Excel. Power Pivot did exist, although the interface was slightly different in previous versions of Excel, so in 2013 and in 2010. If you're on those versions still, you'll find everything that we cover will still work. The first stage is, how do we actually get ourselves Power Pivot? Well, as long as you have the right version of Excel, you simply need to go to File, Options, Add-ins, come down to Excel Add-ins and choose COM Add-ins, and then Go, and there's our options, Microsoft Power Pivot for Excel. When we choose that, we'll also need to choose Microsoft Power View for Excel, although it will choose it itself, and then OK. You get a new tab across the top that wasn't there previously called Power Pivot, with its options of managing the data model, section for measures, KPIs, adding to the data model, updating all, detecting relationships or settings. All of these options that we will explore as we proceed through the Power Pivot lesson. Let's have a look at an example file where the Power Pivot has already been created. If you open the sample Power Pivot working file, it's in your working folder, you'll see that it has two tabs, the Pivot tab, which shows a pivot table, as you'd expect, and a Chart tab actually shows two charts. Both of these are pivot charts. So when you click into them, you'll get the pivot chart options on the right. So these look exactly the same as normal pivot charts, and in the case of the pivot table, a normal pivot table with the same options on the right here, selecting the data, rows, columns, filters, and values. The only difference is where the data has come from. The data behind this pivot table is not located in Excel. It hasn't been created using a normal pivot table option. It's been created using the Power Pivot. Now on the Power Pivot ribbon, if we choose Manage, we get taken into the Power Pivot tool, then loads up here. Very similar to the Query Editor window, is a separate window, and you can see behind we have Excel, in front we have this Power Pivot for Excel. It has its own ribbons, File, Home, Design, a number of options on each of these ribbons that we will explore. In the lower half of the screen, you'll see there are multiple sets of data, and in this case we're connected to an Access database, and there is TBL children and TBL employees. There are only 99 records in the employees table and 3 in the children's table, but there could be millions of rows. We will explore the options that we have available to us within the Power Pivot tool. This is just effectively an overview and a little run through. Once you've made any changes here, if you have made any changes at all, we simply choose File and Close, and we're then taken back to Excel, where we see the result of our endeavors in the Power Pivot. So the Power Pivot is the ability to connect to external data, as we've done already with the Power Query, but then carry out interrogations of that data using pivot tables and pivot charts. If we have a quick look inside the Power Pivot, you'll see here's the pivot table option, pivot chart, and then lots of different chart type options, and then a flattened pivot table. So these are our export options of the data, but it's all going to be summarized. We don't actually import 2 million, 3 million rows. We're interrogating that amount of data to get our result in Excel. Interrogation takes place in the Power Pivot. The result is then placed into our pivot table in Excel. File closed takes us back into Excel. Let's take our working file blank and have a look at how we can connect data in through the Power Pivot. So we need to select the Power Pivot ribbon and then manage the data model. Currently I have nothing in here, so I need to create an external connection from database, from an Access database, which we've actually supplied in your working folder. I need to just browse and pick up the employees database. There are no usernames or password required for this particular database, so I can leave that blank. If we're unsure that we've got the correct location, we can click Test Connection. We find that that works. And then next, I can either select manually from the tables that exist, or if I can write some SQL, I could write a query that will specify the actual data I require. Let's go for select from a list for the moment. And next, I can pick the tables that I would like from the data. So I'm going for employees, TBL children, TBL gender. And then down here, I have two options. Select related tables, so then allowing the Power Pivot to decide which tables are required. Or if I take the employees information, for example, I can preview and filter, and that will give me a preview and filter option on that single table. allowing me to either remove any columns I don't want. So I might not want to see, for example, this address line 2. I simply remove that tick. I might not want to see the facts, and that might not be all. Oh, the CV, I don't want to see the CV. So I can choose which columns I don't require. And then if I want to filter out some rows, I can choose any of the drop-down arrows, perhaps the town one, for example, and look at filtering. So this is just the same as we've done previously with the Power Query, the ability to filter the data. For the moment, I'm going to keep as is. So I've taken a few of the columns out, but I've kept all the rows. Okay. Children and gender, they can stay as they are. You can see here it says applied filters, and then I click finish. And then the data that I've selected is then imported into my Power Pivot. So I then close, and I'll see a separate tab for each of the sets of data. So that's my gender table, my employees table, and my children's table. Now there's nothing to stop me importing further data by going back to the same location, even the same database. This time, choosing the employees table, let's do a little preview and filter. And I'm only interested in those people who live in a particular county. There we are, county. Select all to deselect all effectively, and then just North Yorkshire. Okay, and finish. And I'll get a new tab called TBL employees _1. Well, I can rename that. Right click, rename. I don't have to be stuck with TBL employees _1. I'll call that North Yorkshire employees. So these are the objects within my data model effectively. TBL children, TBL employees, TBL gender, and North Yorkshire employees, which is actually a filtered set of the employees table. And the data itself externally can come from any number of sources, and you can see here get external from database can come from SQL Server, from Access, from Analysis Services or Power Pivot, can come from Microsoft Azure Marketplace, suggested related data from an OData data feed. We saw an OData data feed earlier, from other sources, and the list here are a variety of relational databases, from a Microsoft Reporting Services report, from Excel, or from a plain text file. These two are just what we did with the Power Query. If I had some data in Excel I wanted to bring into my Power Pivot, go next. I just need to browse for the file. So let's go for contacts. It's in your working file. Open. Use the first row as column headers. Yes. Next. And then I can preview and filter again, just as I did with the Access data. That way I can see the column headings and the actual data within there. That's okay. Let's not do any filtering for this for the moment. Okay. And then finish. And we get a copy of that data imported into our Power Pivot. That comes into a new little tab called Contacts. I can pull in data from a variety of sources, and they will be stored here in my Power Pivot in the data model. Once I'm happy I've brought everything in, I will just then simply close, and in Excel I'll be able to revisit that data model by going to Manage, and you'll find those 4 sets of data have been remembered. We're bringing data in from a variety of sources. The next stage is look at how we can then use that data in Excel. Let's take our Power Pivot Data 2 working file and explore how we can add in additional data to our data model that actually doesn't come directly via Power Pivot. So in this particular working file, if we go to Power Pivot and Manage, we can see we've got the information we've already added into the data model, which is TBL children, employees and gender, North Yorkshire employees, which is actually a filtered result set of employees, and then contacts, which is a connection to an external Excel file. Now, if I wanted to bring in the population data for every country that I know I can have access to out on the web, I'd think, great, get external data. Unfortunately, one of the options within all of these choices is not to get things from an external data source on the web. We have to trick Excel a little bit. It's not too difficult. Let's close the Power Pivot. What we need to do is bring in that data as we have done previously using our Get and Transform, previously called Power Query. We go back to the data ribbon. We want a new query from other sources from web. However, because we've done it recently, we can go to recent sources and come down to this one here, worldometers.info, the world population, and connect. And what we'll do is what we did previously, effectively create a connection to that external data source inside an Excel table. So it was table 0, that is the top 200 countries in the world. We load that information in. Give that a little time to load in. We see we have our top 200 countries. So they're now sat in an Excel table. One thing I do need to do, because of the mismatch in the data, is actually to remove any duplicates. So if I go to Data, Remove Duplicates, unselect all of these and just have a look at the country names, and then OK, one duplicate value has been found, therefore removed. We actually have 199 countries. What I then want to do is add those countries, so this set of data, into my data model so that I can use this in conjunction with my other information in my Power Pivots. So we go to Power Pivot. There is an option here on the ribbon called Add to Data Model. So that only wants to work on tables, which is what I have here. It doesn't matter that this table is hooked up to an external source out on the web. So I add to the data model. We find that that then gets brought in as a table 02. Well, I can rename that as world population. And now I have access to that data within my Power Pivot. The next stage that we need to look at is actually linking these non-linked bits of information. These three tables have come from the same database, and what I'll find is that the Power Pivot has spotted that they are linked together and has created the relationships for me. I will see that if I go to Diagram View, available here on the Home ribbon. We can see there's my TBL children, there's my TBL employees, and down a little bit is TBL gender. So I've done nothing to tell the Power Pivot about these three tables relationships. It's picked them up from the external database, so from the Access database. It's linked through the gender ID through to gender in here, and the children have been linked through in a one-to-many relationship from the employee's ID to the parent. Now my other tables are in this view. If I scroll across a bit, I can see there's my North Yorkshire employees, which is actually a filtered result set of the employees. There's my contacts, which is the Excel file, and there's my world population, which is my Excel table based on a web page. Now, if I wanted to create a relationship between, for example, these two bits of information so that I could use population, density, whatever information I've got here about each country, fertility rate, the area, along with my contact information, then I would need to join the country name here to the country region name here. This is the one side, so each country appears in this population table once. So I can actually grab that field, drag across to country region name and let go, and a relationship is created. You see that in the status bar. And then you'll see the join one to many. So the country name links up to the country region name. Obviously, there is a caveat there that we're using the exact same spelling for the countries in our contacts data as we are in our world population data, but that might need a little bit of editing of the actual data. Now I've linked two completely different data sources together in my data model so that I can use both of them in my pivot tables and my pivot charts that are yet to come. Now I did that in Diagram View. If I want to go back to Data View, I don't need to do that in Diagram View. I can do that under Design and Create Relationship. Well, already exists, so let's go into Manage Relationships, and I get a straightforward text box. Here I have the relationship between employees sex field and employees gender, and children parent field and children linked to TBL employees ID. And then there's the one I created at the top. The country region name in the contacts table links through to the country field in the population table. It doesn't matter that this data has come from two completely different sources. If there is a match on the data, I can make use of it. So if the population data has the country names in the same exact spelling as my contacts data, I can link the two together, which I've done now, and then pull matching data through into a pivot table or a result of any kind that I want, a chart or anything really. So that's pulling in additional data that isn't available under the straightforward get external data within the Power Pivot. I hesitate there to use the word cheat, but I've used one of the other tools in Excel to create a table linked to an external resource and then added that table to the data model so that in my Power Pivot, I can then make use of that data as well, which I've done by creating a relationship between this world population data and my contacts data. Two different sources now joined together so that I can make use of both of them in my upcoming Power Pivots. Once you have pulled in your data, so to speak, into your data model, it's then time to start to use the real power of your Power Pivot to create pivot tables. So the steps creating a pivot table, well, a Power Pivot, is to go to the Power Pivot ribbon, back into your Power Pivot application effectively by managing the data model, and in here we can choose pivot table. Now there is a drop down because you might want to choose pivot table, pivot chart, chart and a table together, or chart and a table vertically. 2 charts horizontally, 2 charts vertically, 4 charts, or even a flattened pivot table. If we were to start with a straightforward pivot table, we'd be asked where to place it, in a new sheet or an existing sheet. Well, let's go with a new sheet. And then on the right, you're now into fairly familiar territory in that this is my choice of data to choose from. It just so happens that that choice of data comes from the Power Pivot data model. I can see all of the table options in here. So I've got contacts, table 02, North Yorkshire employees, TBL children, TBL employees, and TBL gender. The table 02 is the population information. And then I have my 4 sections of the pivot table. If I were to start with my employees and pick on county as the row option, and then the ID as the value, but change it from sum to a count, then I would get the number of employees that belong to each of the counties. I could then add in from the gender table, so you can see here I can just jump from one table to another because we've already set up the relationships inside our data model. Or, in the case of this access data, the Power Pivot import tool spotted the relationships and created them already for me. I can then take gender and drop that into the columns, and I see I get a count of each employee broken down by their gender. Instead of column labels, let's place the word gender in there, and then I've got female, male, and the grand total. Count of IDs, let's change that to employees. So that's my pivot table. Once you're in this mode, you're in normal pivot table mode. It just so happens that the data behind this pivot table has come from the data models that we've built in Power Pivot. If I then wanted a different pivot table, I would simply go back to managing the data model, pivot table, new pivot table please, in a new worksheet, and then I could try bringing in information from the population data, so that brings in the countries. Because I've created a link between the countries and the contacts, I could then bring in related data from the contacts table. For example, I could bring in the customer ID. Again, let's change that from sum to count. And because of the join between those 2 tables, or 2 sets of data in this case, I only see joins where the data matches. So I only see a number of countries that have managed to match up the country name from my contacts and the country name from the population data. We have Australia, Canada, France, and Germany, and then number of blank data entries that don't have a country give me the total number of customers in each of the countries that I have. If I then wanted to break that down, perhaps by adding further data in, wouldn't make much sense, many of those actually, then I could have brought those in, perhaps as a column or as another sum down here. But you can see there that we've managed to use 2 completely unconnected pieces of data, brought them into the data model, and then use them together in a pivot table. Now, if I wanted a chart back into the data model, let's not have a pivot table, let's have a pivot chart. Let's go with these clever options of 2 charts. 2 charts horizontally in a new worksheet. And what I then get are 2 rectangular areas, chart 1 and chart 2. There are 2 separate pivot charts. So in this one, I could perhaps demonstrate the gender and a count of employees again. And in the second one, I could show again the gender. This time, I want to use the salary to show the average salary. So change the sum to average per gender. And then I can see those 2 charts side by side. So that's the total number of employees, female and male, and then female and male average salaries. So you can see there's quite a difference there. Now these charts work the same as any normal pivot chart. You select, you've got your pivot chart tools options up here for analyze, design, and format. So you can change the chart type, you can add in keys, we can add different color schemes. The choice really is endless. Perhaps change this chart type into a pie because there's only 2 values, so that we can see the split between female and male much more dramatically in a pie chart, that there is a dominance of male employees in this particular company. So it's all the same as if you were working with pivot tables and pivot charts, which we effectively have already explored. The only difference is where the data comes from. And we've got that through Power Pivot, Manage, and then here's our pivot table options for creating pivot tables. The clever bits I like in here are that you can pick 2 charts immediately, rather than inserting one and then inserting another. You could even choose 4 chart option. Let's have that on a new worksheet, and that will create you 4 charts. Chart 1, 2, 3, 4, all of which could have a different set of data. The layout's already in place. You just need to pick which parts of your data model you want to use in those particular charts. And off you go. You've got 4 charts. 4 charts that are linked to the data model. The data model's ever update, which we can click by updating all. That will tell it to refresh all the data, which depending on where your data is coming from might take a little time. In this case, we've got 1 sheet looking at an external Excel file, 3 sets of the data, 4 actually, with our little North Yorkshire employees looking at an Access database, and then a table looking at an external web source. So once those update, your chart updates. You're also not restricted by the quantity of data in that external data when bringing it in through the data model of the Power Pivot. Taking the working file Power Pivot Data 4, we're going to have a look at how we can add some calculated fields into our Power Pivot data. This sheet contains the population table that we've hooked up using Get and Transform to an external web page. And then on the empty pivots sheet, we want to place some pivot tables. But before we place those pivot tables, we want to add some calculated fields into our pivot data. Now, in order to do that, we need to go to Power Pivot ribbon, Manage to take us into the Power Pivot interface. And in here, you'll see we have the TBL children, TBL employees, TBL gender, North Yorkshire employees that we created earlier, contacts, and our world population table of data. Now we can add in a calculated field very much in a similar way to which we can add in formulas to Excel. In fact, sometimes it seems a little easier. Let's take the employees table, for example. In here we have our employees information, and what I'd like to do is at the end here, add a new column. By clicking to add column, then I want to give that column a sensible name. So we double click to enter that column heading cell, and I'm going to call it bonus. I then come to the first record, which happens to be our favorite Wendy Parker. You'll also spot that in the Excel side of things, say the data model has changed. And when we move back from the Power Pivot interface, it will update itself. We have a new column, but it doesn't have any data in it. I want to place a formula in here, so I go to the first record, into the cell there, and then into here, which effectively is the formula bar. Very similar to Excel, really. And then the bonus is actually a proportion of the salary. To use the salary field, I can actually just start typing the name, and it will appear in a list. You can see there, salary. Now, you'll see that all the column names have square brackets around them to indicate that they are column names, and then functions that you can use don't have the square brackets. So if I only want column names, and instead of just typing S, let's go back. If I type a square bracket, it will then give me the column names, along with a couple of summing functions there. And then I can type S, and I only get the column names that begin with S. There I can see salary. So I could continue to type it all, or I can just pick it from the list. What do I need to do to the salary to work out the bonus? Well, everybody's going to get 20%. So I need to multiply the bonus by 0.2. So we do exactly the same formula, really, as if you're in Excel. The difference now is, once I finish the formula, I can either click the little tick or just press return, and that is automatically then calculated for every record in my set. I happen to have 99 employees, they all now have a bonus calculated for them. So I just do the formula in the first record, and the Power Pivot data creates the rest for me. So that's the formula. It now exists not in the original data set, which has come from an Access table, but in my Power Pivot interface, and I can make use of that column in pivot tables. I could add a new column that I want to calculate the age of my employees. So we'll give the column a name, come down to the first record, which again is Wendy, and to work out the age, I need to take the current date, so that's a function of today, and I've just started typing, today appears, so I can choose it. Take away the field of data, so a square bracket, and it's the DOB field, and then I need to divide by 365.25. Now, because of BODMAS, it will do the divide 365.25 into the date of birth, not into today's date, take away the date of birth. So I need to use a set of brackets around there to say subtraction first, then divide by 365.25. Because of the 0.25, which I've added to allow for leap years, I'm going to end up with decimal value with lots of decimal places. So as well as doing this calculation, I then feed the whole of that into another function to give me the whole number. And that function is the same as Excel, int, open brackets, close brackets, and there's the function for working out the age of each person. I then just press return to accept that function, and then that's replicated down all the rows. and we find out that actually somebody at the top here is 116 years old, and they're still employed. Very good. And then the rest are all sensible ages. Now, Wendy is 116 because she doesn't actually have a date of birth. But we've been able to add the calculated field. That calculated field can then be used in a pivot table. If I do a save, that will update the data model, saving my Excel file at the same time, and allow me to insert a pivot table into here. So if I then go back to Manage, Pivot Table, we'll put it in the existing worksheet since I've created it for that reason. And then in my list, QBL employees, I will be able to see my two new calculated fields. So I could drop the age into hash values, change the sum to average. So the average age of my employees is 50.919. And then I could group that by department by bringing the department into the rows. And we then get an average age for each department. Obviously, because of the decimal places there, I may just want to additionally format to a number with 2 decimal places. And then that looks a little tidier. So it's managing the data model, adding new columns, simply go to the end, add a column, give the column a name, and then add the function in. Now, we're not restricted to doing that solely here in our employees or children or gender. I can do it in the world population data. Any data that you can pull into Power Pivot, you can add calculated columns to, regardless of the source. So in here, it may be that I would like to work out a sort of prediction for future population. So this data is currently a population in 2014, so I'd like to add a new column, give that column heading 2015 population, and then the formula. Again, I just do it for the first row. I don't need to do it for whole 200. The Power Pivot does that for me. So I know population 2014, the 1 year change has been 0.59. If we assume the same change from 2014 to 2015, then we can work out the calculation. It's going to be equals field, that field being the population 2014. We multiply that by another field, which is the 1 year change, and then we add back on another field, which is the population 2014. So we're working out the change of 2014 and then adding that back on the original 2014 to get our prediction for 2015. Return, and then we again get errors. The reason we get errors is because the field that contains the percentage, which is here, 0.59, is actually a text field. Because of the percentage value, that is not formatting, that is a text field. So we need to be a little bit cleverer in our function. We go back in, and what we do is instead of saying multiply by the 1 year change, we need to use the left function. We're still looking at the 1 year change, comma, but we're taking the first 4 characters, which will give me the 0, the decimal place, and then 2 digits. So it won't give me the percentage sign. And then the result of that left, I'm going to multiply by 1, which effectively forces it to become a number. And then return, it now works out. So this is now our prediction for 2015, based on the previous year's growth. Save that. Let's add a new sheet. Back to the data model. Insert a pivot table in the existing worksheet. And we're going to look at our population information, which is table 02. We can place the country in the rows, and then we should have our new column there. There we are, population. Drops in, and that's now the population for 2015, based on the previous year's growth, using our formula. So it's very simple to do these calculated fields, very similar to Excel. We go to the next column, we give the column a name, we then click in to do the formula for the first row, which you would do if it was in Excel. We click into the formula bar here, equals, and you start typing effectively. So all the column names have square brackets. So if you put a square bracket, you'll be given the list of column names. If it's a function you require, you can try out the Excel functions. Left works, right works, all the normal operators, plus, subtract, times and divide, all work in these calculated columns. They are then stored in the Power Pivot's data set. If the data ever gets refreshed from your Access table, your web page, then the calculated column recalculates itself, therefore updating any pivot tables or any pivot charts that the Power Pivot is feeding. Our last section here for the Power Pivot, and by no means is this all that the Power Pivots can do, we've just effectively got you started in the Power Pivot process, but now we're going to look at measures and KPIs, so key performance indicators. These both work together. You can't have a KPI without a measure, effectively. So how do we go about creating these? Well, let's take our Power Pivot data file Number 6, this contains our population table that we're getting from elsewhere. It also contains 2 other sheets, which sort of gives you an indication of the kind of thing we're going to be working out. We've got a sheet called age pivots and one called country populations, both of which, by the end of this lesson, will contain some great pivot tables. Now, in this particular version of Excel, so Excel 2016, if we go to the Power Pivot ribbon, we'll see measures and KPIs are 2 little drop-down options. So we have measures, new measure and manage measures. So if you already have some, they'll be in here. And then KPIs, new KPI and manage KPIs. This is a much simpler process than had been previously to create measures and KPIs. We're now dealing with a straightforward graphical interface. So the first measure I'd like to create, if we go to measures and new, is a measure based on, and here we choose the tables from our data model. So you can see the children, the employees, the gender, the North Yorkshire employees, the contacts, and our world population information. Well, this particular measure is based on the employees table. It defaults to being called measure 1, which if you have no imagination will be fine. I'm going to call mine age check. I could add an optional description if I so wished, and then I place a formula in here that will calculate something. And actually what I would like to calculate is the average. So it's a straightforward Excel function, open brackets, of the age, the calculated field that we added to the employees table. Don't forget to close your round brackets. Unlike Excel, that will do the close bracket for you, this little formula window will not. I can then format the result of my average age by going to number, a little decimal and 2 decimal places will be fine for the average of ages, and then OK. That then creates your measure. Obviously you can't see it because we're not using it, it just creates it. If we go to measures and manage measures, we'll see in the list there age check, and we can either delete or edit. If we click edit, we get taken back to the same window. So we'll cancel and we'll close, and we have our measure in place. That's in our heads. We've got a little measure that's measuring the average age. What I'd then like to do is create a KPI, a key performance indicator. A KPI can only use a measure that you already have, so you have to create the measure to start with. We go to KPIs, new KPI. In the drop list at the top, we'll see the measures, and there's only one. So it's the age check that we're looking at. And we'd like to check the average age against a target value. Now that can be another measure. Well, I don't have another measure, or it can be an absolute value. I want to make mine an absolute value. I want to check average age against the target of 50. What then happens in here with the thresholds, if I click in, I can move these markers. And you'll see that the values change. That's changed to 20 and that's changed to 40 because it's part of the 50. So if the average age is but 20 or below, I'll get a red status symbol. If it's between 20 and 40, I'll get a yellow one. If it's 40 or above, I'll get green, with that green getting darker and darker, the more above the target we get, because the target is set there at 50. These are slidable. I can drag them about. What I'm going to do is I'm going to drag that to 50 itself. So below 50 will be yellow. Move this one up to 35. Below 35 will be red, and 50 or above will be green, because I'm looking for at least an average age of 50 for my employees. If their average age is below 35, then that's not so good, and we get a little red marker. Now, those markers can be controlled here, so we don't need to stick with red, amber and green. We could have symbols within them, we could have traffic light shapes, we could have diamonds and triangles and circles, or we can have proportions of a circle in black and grey. That's not very exciting, is it? Let's stick with the straightforward. So that's OK, and that creates the KPI. Again, we see nothing. If I go to KPIs and manage KPIs, I can see my KPI, age check, and I can edit or I can delete. So that's creating my measure, and I'm measuring the average age. I've then got a key performance indicator that measures the average age against my target, which is a set target of 50. What I then need to do is insert a pivot table in here. So we go to insert. Notice this time I'm not going into managing my data. What I'll do is I'll go straight to pivot table, and you see there's an option to say use this workbook's data model. I don't need to go in to manage the data to get myself a pivot table. I can go for a pivot table in the normal method. Tell it to get the data from the data model anyway. Okay, pivot table appears here. My list of data appears on the left. We're looking at the employees, and what I'd like to do is look at a group by county, and I'd like to bring in their age. Let's just change the formatting of that slightly. Just too many decimal places for my liking. 2's fine. Okay. If I then carry on down scrolling past the list of data fields, what I'll notice is, look, there is my KPI. If I click the expansion, what I get within the KPI is the actual value, so that is in fact the average age, the goal, which I know is 50 anyway, and the status. These are 3 extra fields that I can bring into my pivot table. If I bring the status in here, I get the status symbols. So over 50, there's green, yellow is over 35, and there's no county with an average lower than that. Now I can change the grouping here. I can remove county, and I see the average age then for the whole company is 50.92, which gives me a green indicator. If I bring in gender, I find that 52.23 for males, they're green, but females 48.73 is in yellow. I could remove that and bring in any other sensible field for grouping, perhaps department. Again, I can see I'm yellow and green. So we don't have any average age, regardless of the breakdown, department, county, gender, that pulls us into having a red indicator. So no average age is below 35. You see, this could be quite useful. You have to create a measure. You then create a KPI to compare that measure, in our case the average age, against a target of 50. And then you get 3 values, effectively green, amber and red, as to where that value sits against the measure, where the average age sits against the targeted 50 in this case. Let's have a look at another example. We have a sheet ready, country populations. In this case, we're going to have 2 measures. So measures, new measure, based on the world population, POP 2015, and our formula is going to be the sum of 2015 population, close the round brackets, and we'll have that as a number with no decimal places, but a 1,000 separator. We then create a second measure, same set of data, POP 2014, sum. We need to look for the population 2014. Now I can start typing. There we are, population 2014. Close the round brackets, number, 1,000 separator, but 0 decimal places. So that creates me 2 measures. I then would like a KPI, which takes a base measure based on population 2015, but measures it as a target of population 2014. So we're comparing population 2015 against population 2014. What I'd then like to do is drag my sliders it's up to 100%. So if the population 2015 is exactly the same as 2014, we'll be green. And we'll take this one to about 30%. If it's 30% less, it will be red. If it's between 30 and 100%, it will be yellow. We'll keep the same indicators. That's just a matter of choosing which icons you want, and then OK. In our country population sheet, we then need a new pivot table. Again, using the workbook's data model. OK, we're using that table there, which is our population data, and we want the country. Now, I could bring in the population 2014, population 2015, and then continue scrolling until I get to the KPI, and let's just bring the status in. Gives me lots of green ones because populations are bigger, so more than 100% than the previous year, and then a couple of yellows where the population has dropped a little bit, and nobody in the red where the population has seriously dropped to 30% of its previous value. Hopefully, that's introduced measures and KPIs. KPI needs at least 1 measure to work. 2, if you want to measure 2 separate values. If you're going against a fixed target, then a single measure is fine for your KPI. Time now to consider some what-ifs. So what-if has a number of options in Excel, including scenarios, goal seek, and solver. Our first point of call is goal seek, which is very basic and very simple tool in Excel to help you force a value. Let's see it in action here on Sam's Cafe, but on the simple sheet. And we're going to go very simple to start with. In the top left here, we have 2 cells multiplied by each other, give this value. I've even used the new formula text field here to show the formula. Now, the way that goal seek works is we go to the data ribbon, come across the what if, and choose goal seek. It's a simple 3-option dialog box. We can set the value of a given cell. So I could set the value of this cell here, which is the result, C1, to a set value. Now this has to be a specific typed in value. So I could set that to, let's say, 600 by changing one other cell. Now the cell I ought to change is one of these 2, which is the cells that make up the formula. So let's go for A1. And then when I click OK, it will try to make C1 equal to 600 by changing the value of A1. Okay, and hey presto, it manages it. The value we get for A1 has to be 23.07692 in order to make that happen, but it does get there. So I say OK, And we could do another example and set a different option. But let's just make it a little bit more complicated by using this little shopping list that we have here. Perhaps I have a budget. I only have $50. So I need to make sure that my items only add up to $50. That would be a good little example for my goal seek. We go to what if analysis, goal seek, set cell G11. Now it knows it's this cell that I want to set because that's the cell I was on when I went to the goal seek box. So by default, it chooses the cell you're on. That's fine. The fixed value I want to try and set it to is 50. So I don't need to put dollar signs in or decimal places. It's a specific value. So 50 by changing. Now, what could I change? I could change the quantity of things. I can't affect the price because that's the price in the shop. But I can change the quantity. So let's go and try change the number of jars of coffee. So I'm allowing Excel to change the number of jars of coffee, so F9, which will then affect the multiplication across to here, which will then affect the addition down to here. I say OK, and it does manage it. It gets to the value 50, so I'm only going to spend $50 in the supermarket. However, what it's not aware of is the real case situation in that I can only buy full jars of coffee. It's just looked at the solution mathematically and told me if I buy 4.040301 jars of coffee, I will spend exactly $50. Now that's not too bad actually, because I'll just buy 4 and have a little bit of change. I can accept the value from goal seek, go back into my little table, replace the quantity with 4, and watch the result change to 49.76. So I'll have a few cents change. That's goal seek. Now, if we try to do something a little bit more complicated with it, as we might in our costs table, in here, I'd like to only spend $14,000 on my staff. If I try to use goal seek for this, I'd go to data again, choose what if, goal seek. It knows I want to change the total staff cost cell. Great. My fixed target is 14,000. And what would I like to change? Well, I'd like to change sort of all the staff costs. Now, just as an example, I'll show you that you can't highlight more than one cell. So I give it a range like that and say, OK, this reference must be to a single cell. OK, sorry. If I also try and change, let's say, the head chef's costs, okay, I've not broken anything here. I've got one changing cell, set value. That's the cell I want to change. OK. I still have a problem because I'm now trying to change the result of a formula. If I cancel that and have a look, this 3,500 is actually made up of all of these cells added up, multiplied by the costs of a head chef from this table here. I could change these feeding values, the ones, or I could change the head chef's actual shift cost, 500. That would be the easiest thing to do with a goal seek. Let's go back to what if analysis, goal seek. I'm still trying to change I11, still trying to get it to go to 14,000. This time I'm going to get it to change the head chef's costs per shift, because whatever change will affect there will feed into this value, which will then feed into my total staff cost at the bottom. We go OK. It manages the result of 14,000, but you can see the head chef's costs have dropped from $500 per shift to 414.2857. I'm not sure your head chef will go for that change. So goal seek is good, it just has its limitations in that you can only have one changing cell. So you've got to pick your changing cell really very carefully if you're going to make use of goal seek. What would be great is if you could actually allow Excel to change a number of cells within certain parameters. Well, that's Solver, and that's where we're going to go next. So goal seek is great. One quick solution. You want to change this value, this cell to this. That cell that you're changing would normally be the result of a formula, but then you could change one of the values that feeds the formula, and Excel will then attempt to reach your target. We've seen goal seek in action, and we've seen that it has limitations. Using our simple file, we found that it wasn't really appropriate for reducing our shopping list down to 50 because it could only change the quantity, but it changed it in decimals, and you can't buy decimal portions of packets and jars. We saw it in costs, and it could only change a single value, so we ended up reducing our head chef's salary right down to 414. So it does have its limitations. Single value changed to produce a single result. However, there is a way of altering things in more than one scenario. So for example, if we wanted to spread the costs of our reduction, so our target would still be potentially 14,000, but we might want to spread that reduction either by reducing everybody's salary just by a portion, or by reducing the number of staff that we have in place for any particular shift. all of that is controllable. We can supply all these parameters to get our end target. And in order to do that, we would need Solver. Now, Solver is free, it's applied to Excel, but it's not activated at installation. So how do we activate Solver? Well, we go to File, come down to Options, come down to Add-ins, come down to Excel add-ins at the bottom here, and then Go. And that will give you a little list of optional add-ins. There's our Solver at the bottom. Not at the bottom because it's the worst option, because it's alphabetically chosen. So we choose Solver and OK. That then installs Solver into our Excel, and you'll notice on the data ribbon right on the right hand side, we now have a new group called Analyze. Within that group, we have Solver. So it doesn't place the Solver under the What If, which is where the goal seek is. It has its own little section. What you'll then notice if you have a look in the dialog box for Solver is that suddenly there are a lot more options. We do have a target cell, and we need to set that to a value. Now we can set that to a specific value, or a minimum value, or a maximum value. Notice here by changing variable cells, so unlike goal seek where you can only change one cell, here we can change a number of cells. And then we can even add in constraints. So although we can say yes, you're allowed to change any of those 4 cells, however, you can only change those cells within these given parameters. Otherwise, it will make the solution, but it might not make a very realistic solution. Very similar to our goal seek jars of coffee scenario. All of these options we're going to explore. For the moment, we're going to close and just have a look at how we deactivate Solver should you no longer wish to have it. It doesn't really make any difference whether you leave it on or off, but if you do turn it off, it means Excel will start up just a bit faster because it doesn't have to load Solver add-in. So if you want to turn it off because you're never going to use it, you might just want to have a look at it and then never see it again. We go back to File and Options, Add-ins, down to Excel add-ins and Go, bringing up this little dialog box again, and you simply remove the tick and click OK, and you'll notice that it then disappears from the data ribbon. That's how to activate the Solver add-in and how to turn it off should you no longer wish to have it. Our next step is to look at how we can make use of Solver. Now it's time to see Solver in action. We're going to make use of Sam's Cafe 2016 working file, pretty much the same as Sam's Cafe, except it's only got the cost sheet, we've lost the simple sheet. So the first thing I'm going to do before I even attempt any solving is to actually save this again with another name, and that's just in case I overwrite my original values. I'm going to call it Sam's Cafe _working. That way we've still got Sam's Cafe 2016 to go back to should anything go completely wrong. So we're going to make use of our Solver on the data ribbon, across to Analyze and Solver. Now with Solver, we still have an objective to set. And just like goal seek, it's chosen the cell that I had selected. So that's this cell here. And now I can choose to set that cell to either a maximum value, as in the maximum value it can make it, or the minimum value, or a specific value. Now in our case, we're going to go for a specific value of 14,000. That was our original aim when we started with goal seek, but that wasn't very helpful. We're now going to use the same aim with Solver. Set our staff costs down to $14,000. Now here I can use changing cells, as in number of cells, and we're going to go with the 4 salary prices. So the head chef's price, the assistant chef's price, the head waiter's price, and the waiter's price. So I'm going to let Solver amend all, some, or none of those to make my target 14,000. Constraint section we will cover shortly. In the bottom we have different solving methods, and there are 3 main methods. Really it's experimentation to decide which is your best method. But you'll see as you choose a method, we have an option here. Select the GRG nonlinear engine for solver problems that are smooth and nonlinear. Select the LP simplex engine for linear solver problems, and select the evolutionary engine for solver problems that are non-smooth. So you would need to decide whether your changes are smooth or linear. I'm going to stick with the default. We could try different options to see what solutions we get. For purposes of showing how it works, we'll stick with GRG non-linear. So I've set my target 14,000. I'm allowing it to change one of these 4 values or all of these 4 values, and I click Solve. Solution is then found. I just move the dialog box over. I can see the total staff cost has been changed to 14,000. All of the individual salaries have been changed. They've all been reduced, obviously, to get to 14,000. Which has therefore had a knock-on effect to the costs for each individual role, which then adds up to 14,000. And my choices in the dialog box are to either keep the solution, I'm happy, let's go with that, go back to the original values, return to the solver parameters dialog box, so take me back to the previous box effectively, produce a set of outline reports, which we'll see shortly, and is even an option to save a scenario of these new values. For the moment, I want to restore the original values and go back to the solver parameters dialog box. OK, takes me back in and you can see everything gets returned. Now, although that reached my solution, it spread out the loss of salary, unlike the goal seat, which just took it all off the head chef, it still is a hard thing to sell to have a salary cut. What if we tried changing different cells? Let's not change the salary. Let's change the number of waiters that we have on shift each day. Now, we know that's going to involve a reduction, because that is the only way you're going to get this 14,600 down to 14,000. But what kind of reduction? Well, let's find out. Back to the dialog box. That's my target, 14,000. I'm going to allow it to change any or all of these values, which is the waiters available, and then solve. I get my same solution. Let's just move the box up a little so I can see what it's done. We can see that it's adjusted the waiters on staff. It's reduced them, which gives me a total waiter cost of 1,800. It hasn't involved reducing anybody's salary though. So everyone still gets the same per shift. It's just that the waiters are working shorter shifts, which means everyone else who's there for the day will have to work a little harder, which they might or might not go for. So let's go back to the original values and return to the solver parameters box. What if we allowed it to amend all the staffing? So let's go for changing cells being these. So that's all 7 days of the week, all 4 roles that we have in play. I'm going to allow it to adjust all of those to reach my target of 14,000. Solve, and you'll see this time it hasn't been quite so nice. When it did it with the waiters, we were in halves and 2.5, which is easy to manage. Somebody does half a shift, somebody does 2.5 shifts, which is 2 people doing a full shift and a person doing a half shift. Now we've got 0.94 and 0.92 of a shift. What does that mean? They go an hour early, they start an hour later. A little bit more difficult to manage. So I'm not too happy with that solution. Let's go back to restore, back to the dialog box. Now, we've got 3 different options there we've just played with. Our target is still being to get to 14,000. But we've seen we could adjust the staffing costs, we could adjust the number of people on shift, so the manning hours. We saw that if we try to adjust too many manning hours, the percentage of the original values just got a little bit awry. Now, there is another option, which is something you certainly couldn't have done with GoalSeek at all, is to actually change cells that contain formulas. So I could say, let's make these the changeable cells, please. Solve. And you can see that it actually does it. It changes these total values without changing the values that feed the cells. So it hasn't changed the salaries. It hasn't changed the manning hours. It's just changed these values. Now, that's not really accurate, because what's happened is it's replaced the formulas with physical values, which isn't adjusting anything. The people will still work the same amount of hours. People will still get paid the same money, but the maths in the sheet has now gone to pieces. That's certainly not an appropriate solution, but Solver lets you do it, because sometimes you might want to do that kind of experimentation where you wipe the formulas out and replace them with the target values. So definitely I would need to restore the original values and go back to the dialog box. Now, ideally, what we really want, we can't adjust people's salaries because that will upset people. We can adjust the manning hours, but when we try to adjust everybody's manning hours to spread out the reduction, the percentages of the day just didn't really work. Ideally, we would want to do that. We would want to make the reductions to everybody's manning hours, but add in some constraints so that you would always have a head chef or a head waiter there, and no one would work 0.75 a shift. They could work half a shift, but not 0.8s and 0.9s. Those are the kind of constraints we would want to add in, and then run the solver again and see if it can come up with a solution, because it can handle those kind of constraints. We've seen the solver blow GoalSeek out of the water in its ability to calculate a target based on changing multiple cells, different multiple cells, and not going completely crazy. Adding in some constraints, as we're about to do in the next lesson, will show how you can really control solver to get you a more appropriate and realistic solution. Let's take Sam's Cafe 2017 as our working file and explore how scenarios are going to help us and how Solver can work with scenarios. First thing to explain really is what a scenario is. Basically, a scenario is a set of cell values that you can save, and you can have a number of these sets of cell values and you can swap them about. If that doesn't help with the explanation, let's have a look at it in action. With our Sam's Cafe 2017, The scenario manager is under the data ribbon and what if, because the idea of a scenario is it's a set of what if numbers. Now, if we have a look at the scenario manager, we can see we currently have no scenarios defined. That's fine. We close that. The cells I would like to experiment with different sets of numbers of are the actual staff costs per shift. So these 4 cells here. If I highlight these first and then go to what if analysis, scenario manager, then go add, we'll see that it already knows those are the cells that I'm going to class as my changing cells. So when you're dealing with the scenario manager, the best thing to do is save your original values before you accidentally overwrite them. I'm going to highlight those cells. I'm in the scenario manager. Let's call this set of numbers original values. And then at any stage, I can always go back. Those are the changing cells. They've been selected for me. And then the comment is simply created by your login and today's date. Okay. It then shows me the cells. Fine, thank you. Okay. So that's the only value currently in my scenario manager. So let's close that. Let's experiment now with a different set of numbers because we're trying to save some money here. Let's see if we experiment with reducing the staff costs per shift. Let's reduce everybody's staff shift costs by $100. Assistants down to 200, head waiter down to 500, and the waiter down to 100. That's probably a big drop percentage-wise. So let's go down to 150 for our waiter. We then highlight the same 4 cells, back to what if analysis, scenario manager, add. Same changing cells. This one is where I've reduced the salaries. So let's call it salary drop. Okay, those are the values. That's fine. Okay. Now we have 2 sets of values in here, and I can swap between them by simply choosing, say, for example, the original values, show, they are then placed in the cells, salary drop, show, they then get placed in the cells. What you will notice is when you click show, the values get placed in the cell, and if that has any knock-on effect to the formulas within the sheet, for example, these here for the staff costs per person, well, per role, shall we say, and then the total staff cost. So when I put the original values back in, we go back to our original staff cost of 14,600. When I put my salary drop in, we can see we get the staff cost right down to 11,000. That is a big drop. If I want to add in another set of numbers, I could do it by the same process by closing, changing these numbers, coming back round, or I can do it while I've got the scenario manager open. I go add, what's my scenario name? We'll call this salary increase. Same changing cells. Okay. This time when I'm presented with the cell values, I'm going to change them. I need to increase the head chef to, let's go right up to 650, the assistant to 350, the head waiter to 675, and the waiter to 250. Those are higher than the original values. Okay, and they get added in, salary increase. When I click show, the numbers then get placed in the file, and my staff costs go up and up and up. I now have 3 different scenarios. I can choose any one of them from here, click show, close the scenario manager, and then I'm away with playing with the worksheet. If I want to try a different set of numbers, what if, scenario manager, salary drop, show, close, and then back and playing with the numbers. So how does this work with the solver? Well, at the moment, we're having to experiment with a different set of numbers and save them as different scenarios, and then choose them to see what happens. What we can do using our solver is to get solver to work out a set of values that reach a particular target. For example, our 14,000 that we keep trying to reach. So let's use solver, also from the data ribbon. The objective is we're trying to change the cell I11. That remains the same. The target is 14,000. By changing L3 to L6, that's the same set of cells. When we click solve, we'll find that solver does make it to 14,000 by adjusting the actual staff costs for each of our job roles. Previously, we've restored and returned. What we can also do, there's a button over here, is save the result as a scenario. So we click Save Scenario, think of a sensible name. What about Solver 1? Then OK. That then brings me back to the Solver Results dialog box where I can say Restore the original values. OK, everything goes back to the values that were just currently in there. But what I now have in the Scenario Manager is another set of values that I've called Solver 1 that I can then use. I just show, and I can see I can reach this 14,000 by getting salaries reduced this much. Or we can experiment with our own scenarios that we created ourselves. So what the solver does is it creates a scenario as we did, but with this target in mind. So it gets to the target by changing those values. We can then save those values as a scenario so that we can go back to them, perhaps for an explanation or perhaps for testing as we see fit. Now we can get solver to create as many scenarios as we see fit. So we can go back to solver. We could try for the min, so the lowest value that solver can make this staff cost by amending these values. However, until we get to constraints, this is not really very viable because all it will do is make them all 0. Watch. Oh look, the best way to get your staff cost down to the lowest possible value is to make the actual staff wages 0. So that's not an appropriate solution at this time. So restore the original values, return to the solver parameters dialog box. Going for the max as well isn't going to work. We're just going to get one big number and a massive set of costs. In our particular case, we're always aiming for a set value. So let's see what would happen if we tried to aim for 13,500 just to bring the salary cost down that little bit more. Let's see what would happen. Solve. Another set of numbers are placed in here that actually reach our target. We could save that as a scenario. Solver 2. Okay. Restore the original values, return to the solver's parameters dialog box. We could even use our scenarios for saving different solving methods. So let's say simplex LP, just for an example. Same target, solve, save as a scenario. You can already see what's happened here just by looking at the results. It's not really spread out the reduction. It's taken 3 down to 0. So it's not quite the solution we're after, but we're going to save it so we've got it within our scenarios. Solver simplex. Okay. Turn to parameters dialog box and restore the original values. And we might as well try out the third option, evolutionary. Solve. This one's taking a lot longer. See down the bottom left there how it's working away. Finally finds a solution, and in fact it's exactly the same solution as the simplex. Let's save that. Solver evolu. Okay. Restore the original values. Let's not return back to the solver parameters dialog box. And OK will bring us back out. So each of those potential solver styles are saved, solver evolve, solver simplex, and then our 2 solvers that work quite well for us really, because they distribute the loss amongst each of the roles, and then the ones that we created ourselves. The scenario manager stores sets of values for the changing cells in this case. Those changing cells we either enter ourselves or we ask solver to create them for us. Once you finally finish with potential scenarios, you might, for example, end up going back to the original values. Each of those values can then be deleted simply by clicking delete. Notice there's no are you sure option. They just go close and you're finished and back to where you started from. We've seen how we can use scenarios to store different solutions from the solver, and we've seen our solver in action trying to reach our target staff cost of 14,000. Now let's go with the Sam's Cafe 2016 and have a look at one of our solutions, which is to get I11 down to 14,000 by changing the staff cost. Now we know that that works. Let's just see what it does. And it reduces the staff cost here. However, reducing the staff cost is not something that you could do very easily or sell to the staff. So we need to look at other ways of reducing these costs. Let's restore the original values and return to the solver parameters box. Okay, our changing cells are not going to be the staff costs anymore. Let's have a look at actually changing the man hours available. Now we did try this before, if you recall. We set these cells as our changing cells, and when we clicked solve previously, we saw that it did manage to change things, but they weren't integers. They were parts of whole numbers. Now that isn't ideal because it would mean trying to manage people coming in an hour later or going an hour earlier. So instead of doing that, let's return back to our dialog box and have a look at adding constraints in. Now one of the constraints I would want to add in is that each of these values here, so let's highlight them in our cell references, are whole numbers. And luckily, one of the operators in here is int, and it places the constraint integer in the right hand side. So OK, and then try solving with that constraint holding the staffing to at least whole numbers, so 1 or 2 or 3, no part shifts. Solve. We see that it manages it fine, and we reach our target of 14,000, and it hasn't changed any of the staff costs. However, what it has done is meant that we have no head chef on Monday and Tuesday, which isn't too bad. We're quite quiet. The assistant could manage. But if you look at Monday, we have no chefs at all. No head chef, no assistant chef. Therefore, nobody to cook the meals. That's not quite working for us. We're partway there because we've got whole numbers, but we haven't got whole numbers on some days that we would need them. So let's go return to the solver parameters dialog box. We need to add another constraint in. Now that constraint is that these cells here, the head chefs, must be greater than or equal to 1. So there has to be at least one head chef on shift each day. Whilst we're thinking about it, we ought to really have a head waiter on shift every day as well. So far, the solutions have allowed that, but you don't know with these other constraints that we're adding in whether that will go out the window. So we'll physically claim it that the head waiter's value must be greater than or equal to 1. Okay, so we now have 3 constraints. One is that our shift patterns must be whole numbers, so people have to work a whole shift. We also have to have at least one head chef and one head waiter on each shift. Let's see what that gives us. Solve. That too manages to find a solution. It does mean that we have less assistant chefs here at the beginning of the week, but that's fine. We're fairly quiet. The head chef can manage to cook everything. There is only a single head waiter and no other waiters to help out on Monday, but again, it's a quiet day. The head waiter can manage. We still managed to reach our target of 14,000. So that's quite a good solution. However, there is one other constraint I would like to add, and that's to try and control how many waiters we actually have on staff to try and maintain the customer service element. If we drop the waiters down too much just to save money, then that could actually have a negative effect on the sales. People will stop coming because they're not being served. I want to keep the original values and not return to the solver parameters dialog box. Okay. Notice how the original values is actually just 2 steps back where we had no head chef. This would have been a good point to keep the totally original values as a scenario. But that's how you live and learn. The constraint I want to add though is going to require another line, and that is for the number of minimum waiters. Min waiters. If we're thinking we need to have at least one waiter for every 10 tables, then our minimum number of waiters has to be equal to the expected covers divided by 10. So on Monday, I would need 0.6 of a waiter, but we know we're only working in integers. That would require a single waiter. So let's replicate that across to Sunday, and that shows me, based on my expected covers, the minimum number of waiters I must have. We then go back into our solver to add in our final constraint. And our final constraint is that the number of waiters must be greater than or equal to the minimum requirement for waiters. Okay. That then gives me my 4 constraints. These effectively are the 4 that I need, keeping the shifts to a whole number, making sure I at least have one head chef and one head waiter, and making sure that I meet the minimum requirements for waiters on staff. Solve. We then see the solution still makes 14,000. I now have a waiter on Monday, which I didn't have previously, which has meant reducing the chefing cover even further. However, it's the customer service that is important because that's what brings the people back to this particular restaurant. In which case, it does mean the head chef would have to work a little bit harder on Monday, Tuesday, and Wednesday until extra staff are involved for the rest of the week. Now, if at this point, once you've added all your constraints, you're actually happy with the solution, we can choose to keep the solver solution. Okay, and this is now your final working file with your target reached to 14,000 and how you're going to amend your shifts to reach that target. Our last chapter in Excel Big Data is exploring the data analysis tools. Now, in order to use the data analysis tools, we firstly have to activate them because they don't come directly out of the box, so to speak. It's a little bit like Solver. We need to just activate the add-in. And we do that by going to File, Options, Add-ins, Excel Add-ins, 1 tick in the Analysis Toolpack option, OK, and what you'll find then on the Data ribbon, where we've already added Solver to the Analysis group, you now have got Data Analysis in the Analysis group. Now, if we click the Data Analysis option, it will give us a dialog box with a lot of data analysis tools. Now, most of these are statistical and mean nothing except to the person that's using them. We're not going to explore every single tool in here. We're just going to have a look at a couple of them. The first of those is the descriptive statistics. And if we click OK, we're currently in the sales data working file. For the descriptive statistics, we have to give it a range of numerical values. So my input range is actually going to be the sales values. You can highlight all the sales from the top to the bottom. Are there labels in the first row? Yes, there are. Is my data in a column or a row? Well, the fact that I've highlighted most of a column indicates they're in a column. Do I want to put the data in an output range or a new worksheet or a new workbook? I'll put it into a new worksheet, and I would like the summary statistics, please. So this is only applicable to a row or a column of numerical data. And when I say OK, in a new sheet, I will get a set of the descriptive statistics for the sales column. And the descriptive statistics give you a number of statistical values. We get the mean, so that's the mean of my sales values, 7.280257038. The standard error, the median, the middle value, the mode, most frequently occurring, standard deviation, so that's the gap between one section and the next. Then follow a number of distribution statistics, sample variance, kurtosis, and skewness. Those of you that deal with variance, you'll understand these. The range, so that's the difference between the smallest and the largest number, and then it gives us the smallest and the largest number. For minus 2.49 to 79.74 is 82.23. The total, so the sum, and then the count of the number of values in that range. So you get all of this statistical information, the number of functions that are carried out for you in effectively 1, 2, 3 clicks. Now you can do that with any numerical information. If I want to do that with another working file, my results file, then in the results file, we do the same process. Data, data analysis, descriptive statistics. Okay. The input range is not the same range now, so I need to highlight the new range. Group by column, there are labels in the first row. Output range, well, I want the information in this sheet, so let's do output range and say start here with the summary statistics as well. Okay. And that way I get the statistics in the same sheet. I get the same set of statistics. Mean, error, median, mode, variation numbers, the range, then the smallest, the largest, the total, and the count of numbers. So that's under the data analysis. And then under data analysis, you simply choose descriptive statistics, but it only works on a range of numerical values. If you try to do it on a range of text values, you'll get an error. Any set of numerical values, you can get this summary of mathematical information. Now that we have our data analysis tools activated, we're going to have a look at another quite commonly used one, the moving average. So let's take our sales data working file, go to the data ribbon, data analysis, and we come down the list of many analysis tools and choose moving average. Now what the moving average will do will allow us to create a chart based on a moving average. So it will look at the values as they change going along and calculate the average as it moves, effectively as the data moves. This will be better explained in action, really. The moving average requires an input range. My input range are these sales values. This is on the month sales tab of my sales data file. Are there labels in the first row? Well, that will depend if I highlighted the first row, which I did. So yes, there are labels. The interval is how many values you want to work out the moving average on. If you went 1, then it would just look at one value and assume that's the average. Well, that's not going to create much of a variance. Obviously, the higher the number, the more accurate the moving average will be because we're looking at more values. I'm going to plumb for something like 4. So we're going to look at 4 values, work out the average and plot that. Then the next 4 and plot that, and the next 4 and plot that. And it's a good way of giving you a pattern, a sort of trend. Where do you want the moving average values to be placed? Well, let's just place them next to the sales values. And do we want a chart? Yes, we would, please. And what about standard errors? No, thank you. So when I say OK, it takes my set of input sales values, works out the moving averages, and we'll place them here, which is why we've got an output column selected, and then it will create me a chart. If I say OK, very quickly done. Let's just scroll upwards and move the chart upwards. You can see here it's created the moving averages. So the first 3 are not applicable because it needs 4 to work out the moving average. And then this value here is actually the average of those 4. This one's the average of those 4. And you can see that's a moving average. So you could have actually done this yourself if you'd put some thought into it, but Excel had beaten you to it and added the moving average option into the data analysis tool. It then creates a chart based on these 2 columns, which is your sales data. So the blue is your actual sales data. And then the moving average is taken as your forecast, as your trend, really, because it's taking the average of 4 values moving along, therefore creating you a chart. So this is the forecast for your sales. So they are going upwards, but without all these peaks and troughs because we've used the moving average to iron those out. The higher the moving average number you use, the more those peaks and troughs will be ironed out. You've got to pick the right number for your data. We've done it here with the sales value. We could do it with the results that we have in our results file as well. We do the same thing. We go to data, data analysis, moving average. Okay. It remembers the columns and rows and everything, but obviously we're in a different sheet and it's remembering the wrong columns and rows. So my input range is now actually these results. The interval I will reduce to 3 because I don't have many values anyway. And the output needs to go here next to my result. And then I'd like a chart again, please. Okay. It calculates the moving averages based on 3 and then charts both the results, which is the blue, and then the forecast, which is my moving average. You can see the trend is up, down a bit, and then a general upwards, but the chart is much more abrupt because of the big drop here at 0.6 before then moving upwards. That's how to make use of the data analysis tool, moving average. One of the other really very useful tools available to you from the analysis tool pack is the histogram. The histogram will show you a distribution of your values across a data set. So we're going to take the large results file. It has the scores for some exams for 100 people. Now it's effectively quite a small result set. That 100 could soon become 1,000, 10,000, 100,000 or 1,000,000, at which point it becomes very difficult to do things manually. If I were to take these 10 scores and try to figure out the distribution, I would first sort them by score so they're in the right order, and then look at how many I have in each particular band. And those bands might be, for example, 0 to 20, 21 to 40, 41 to 60, 61 to 80, and 81 to 100. So I would have 5 buckets, 5 bins is the correct word really for histograms, and count how many were in each. I could do that manually with 100. Once it starts to get bigger numbers than that, then we need Excel to help us out. So let's assume we have more than 100 and we want Excel to help us. The first stage is for us to define the bins. Now it's good if you have an odd number of bins, because then you always have 2 above and 2 below the middle point, or 3 above or 3 below the middle point. So my original bin suggestion size here was for 20 in each bin, and that would give me an odd number when the scores are out of 100. So I'm going to stick with those. Let's enter our bin sizes. So the maximum bin value for each really 20, 40, 60, 80, and then 100. That is then enough information for us to go to Excel and ask it to work out the distribution. So we go to data, data analysis. In the list of data analysis tools, we want the histogram. Okay. Now the histogram requires 2 inputs. One is the actual data, so the input range, which are my 100 scores. It then needs to know the bin range, which is the 5 values I've entered here. There are no labels. I haven't highlighted the labels, so that's fine. And then I just need to choose where I want the histogram to appear. If I want it in this sheet, then I could choose output range and select where I would like it to go, or into a new worksheet or into a new workbook. I also have an option to add on a chart. Well, I'd quite like that option, please. So I'm having a chart as well as the distribution of the data. That's my input values, and they are 100 cells, but they could easily be 100,000 cells, and my bin range, so it knows where it's looking for the scores to fall effectively. Okay, let's see what we get. Well, we get the new sheet. There's my bin and frequency. There are 21 scores fall in the 20 and under bracket, 16 in the 40 and under, 25 in the 60 and under, 25 in the 80 and under, and 13 in the 100 and under. Now, I could make my graph look a little more user-friendly by renaming the bin names here. We could say 1 to 20, and you can see the graph responds immediately, 21 to 40, 41 to 60. Also notice I'm putting a little single apostrophe in so that Excel doesn't turn this into a takeaway sum, 61 to 80 and 81 to 100. And then the bin labels look more appropriate. If I click on the chart, I can then resize this area so that I'm not getting the more section, because there isn't anybody gaining more than 100, and it starts to look a little bit more accurate. And then the last thing possibly will be to lose the series. So that's my distribution of the scores, and we can see just from the chart that the bulk of people are in this sort of bracket here between 41 and 80. Now I could turn my columns into what people generally consider is a histogram, which is a bell curve, and that's done by changing the chart type. We go to design, change chart type, and we change from a column to an XY scatter, but that XY scatter to have a smoothed out line. Okay, and then we get our bell curve, which shows as a sort of peak in the same place as our columns because it's the same data. We do lose the bin labels along the bottom, we just get the bin numbers, but that's something we can probably live with. Now that's what we would call method number 1, really. If we go back to our data, let's rename this, let's call it histogram 1. Back in the results, we could get Excel to do a little bit more work for us. We could get it to calculate the most appropriate bin size. So instead of me saying, well, let's do bin size of 20 and divide the values up, we could get Excel to work out the most accurate bin size for the data values that we've got. So let's move a little bit across. Now, the first thing we need to work out is the average of our values. Now, that average can either be the mean or the median, and you can experiment with both. I'm going to actually go with the median to get the middlemost value of my 100 scores, but again, it could be 100,000 scores. I then need to calculate the standard deviation. If any of you can remember from school, that effectively is the distribution of your results here. So the standard deviation for my 100, the same range as the median's worked out on. And it tells me the standard deviation is actually 29.36. So that's the actual size of my bins, whereas I was plumbing for 20, being a nice, neat 1/5 of 100 possible scored. I then need to supply the bin count. Well, that's still going to be 5. And then a clever little thing here that's going to make our bin sizes work themselves out is what we'll refer to as a half count. Now, a half count is half of the bin count, but the integer value. So I'm going to say equals int of the bin count divided by 2, and I get the result, therefore, of 2. The reason I've made that a formula rather than entering the number 2 is if I wanted to experiment with a larger bin count, I could go for 7, and then it would give me a half count of 3. Let's leave things at 5 for now. We then need it to work out the 5 bin sizes. So let's create those over here. We'll have 5 cells where the 5 bin sizes will go into. I'm just going to give them a different background color. Need a border as well so we can see the separate cells. These are going to be my bin sizes that are calculated by Excel rather than me assuming they're all 20. So the tricky bit is to work out the first bin size, so the starting point, that equals the median value minus the half count multiplied by the standard deviation, which gives my first bin a start point of -9. All of the other bins subsequently are very easy to work out. They are simply the previous bin plus the standard deviation. If I make the standard deviation absolute, which we can do with our F4, for those of you that recall that, I can then replicate that downwards. So these are now effectively my bins. But instead of them being evenly spread 20, 40, 60, 80, 100, I'm going from lower than 1 to higher than 100. Now that I have my new bin parameters, I can create a new histogram. So we go to data, data analysis, histogram. It's the same input range, so that's fine, but my bin range is different. It's now these 5, no labels still. I'd still like a chart, and we'll go into new worksheet again. Okay. And then I have a different sheet here now, and let's change this chart into a scatter graph with a line, and that way we can see our bell curve look more like you would expect a bell curve to look. It has a peak point and then a bottom and a top. Now I don't need the more value that we have here as well. Got rid of this on the manual histogram, we'll get rid of it on this one, and now we can remove the legend also. That's now the histogram bell curve generated by using Excel's method for calculating the bin sizes rather than me manually stating the bin sizes. Either method works well. Both methods give you a histogram and then a bell curve, as we've seen here with our generated one and here with our manual one. No doubt, once you've been dealing with the big data that we've been dealing with within this particular title, you'll want to share some of those files with other people. Now, we have to be a little bit careful when sharing files with big data, because if the data has links, those links might not be valid when you then share that file with someone else. So let's take the histogram file. This doesn't have any links to any other files, and look at the sharing options. Well, if you go to File, there is a share option. And the share option effectively is a choice of either sharing with people by saving to the cloud. So I would need to save my document into my OneDrive location. If you're signed up for Office, you get a certain amount of OneDrive location. Now that is changing all the time as the quantity you get. Currently, I have access to 1 GB of storage. I could do that, and we'll do that shortly. The other option is to email the file. Now we could send this directly as an attachment. So it's an Excel file, they get the Excel file and they can then manipulate things, or I can send as a PDF. So it will convert the Excel file into a PDF and send them the PDF. Most people can open PDF files. Send as an XPS file, it will convert the document into XPS file. Both the XPS and the PDF file are not editable by the recipient. They effectively can see what you've done, but they can't make any changes, so they can't experiment. Whereas if you send them an attachment, they can. There is an option here for send as a link, but it says workbook must be saved in a shared location. So this is grayed out currently. If the file, however, is saved on a network drive, then you'll be able to send them a link internally to your corporation, or once we save it into my OneDrive, I'll be able to send them a link. So then they'll have access to the file. Let's go to share with people and save to cloud. I don't want to save to this PC, I want to save to OneDrive. There's my OneDrive. Now, things will tend to go a little slower now because you're now trying to save the file onto the internet, into the cloud. You'll need your login information. You can ask Excel to remember that for future use. And then once you're in, you can save your file in an appropriate location. I'm going to save mine into Excel 2016 and we'll keep the name histogram. Save. That file effectively is then uploaded to the internet. It says here, we can't share this document until it's finished uploading. Please come back in a few moments once we finish the upload. Once the file is uploaded, back at Share with People, we have a Share with People button that allows you to send invitations and get sharing links. You'll also notice on the email option, send a link is now available because the file is actually on the internet. So if I went with send a link, it then generates an email, so I just need to type in the address. But this is the address of the file that they will get so that they can view that file. If I therefore look at that on the internet, Excel 2016, there's the histogram file. Unfortunately, it needs to be closed because it's locked, because I've still got it open in Excel. But it's opened it as read-only, and I can see exactly what I can see at the receiving end. Obviously, working online, I don't quite get the same actions. I can close that and go back to Excel. Now, in Excel, if I then try the same thing with another working file, this one's Power Pivot Data 4, this has external links. It has links to this web-based data. If I now try and share this one, again, I'll need to save it to the cloud. OneDrive, Excel 2016. Let's keep the same name. And once the file is uploaded, we have the same option, share with people and email send a link. If I this time choose share with people rather than send a link, you'll find it opens up your address book to try and find people that you've got already in your Office account. So that's going to find people that I know. So let's actually close that and go back with share with a link, because then I can send that by email to people. That's the link for the file. So let's take a copy of that and go directly to that address this time rather than looking through. So you can see that that has pivots, that has the population data, and up here on the ribbon I have a data option, and you can see I have an option to refresh the selected connection or refresh all connections. Well, let's go with refresh selected, which is this one, getting the population data from a web page. And you'll see that we cannot do that. Let's go back to the pivot and try in there. Refresh. This workbook contains external connections or BI, business intelligence, that are not supported. Although they can see the result of the pivot and they can see the population table, they don't have access to the Power Pivot data behind the sheet. Although we have, and it's on our machine, as soon as we share that online, the online version cannot then hold that connection. So you've got to be a bit careful about how you share your data. Ideally, I would need to go back to Excel, close the email, and not share it online, leave it on my machine, but send them a copy of the file. So it would be file, share, email, send as an attachment. At the receiving end, they would still need to have access to the same data entries to be able to refresh those objects, but at least they're not having the restriction of online. So it's just a little bit of a caveat, really. If everything is contained inside the Excel file, as it is with our histogram one, all the data is within here, the charts within here, we can share this online or we can send them a copy and it will work. Unfortunately, with our Power Pivot one, even if we send them a copy of the file, they don't have access to the source data, then they won't be able to refresh or run any new reports or pivot tables of their own. So it's just to bear those things in mind when you're thinking of sharing your big data. Here you are at the end. You've made it. You've completed this Excel Big Data title. Well, just as a quick recap, just to make sure that you haven't forgotten anything, we'll have a run through of the things that we have covered. We covered at the start basic data manipulation. So being able to fix the screen and the print headers, which are two different items. So we were up to freeze panes and also repeat headers on the print side of things. We looked at the ability to sort quickly and then using multiple column sorts. We used the ability to filter. So when you don't want all the data, we need to filter some away. And we looked at the very quick way of creating a chart in a second. Well, if we timed it, it was probably actually quicker than a second. And don't forget that the keyboard shortcut there is F11. Then we went through a variety of stages of data cleansing. If your data is coming from an external source, even if that external source is just somebody typing in a box, there is likely to be the need for data cleansing at some point. So we looked at how to remove duplicates, text replacement tricks, where we used some of the text functions like left and right and mid to change text around, removing the non-printing and special characters that can be imported sometimes from external sources, the ability to change case to give a bit of consistency to your data so that perhaps all surnames are in uppercase or all surnames are in title case. We saw how we could rearrange the columns and the rows that have been imported so that they're in the order that you want them to be in. And we looked at the ability to split cell contents into multiple cells or to merge multiple cells into a single cell. That data cleansing then led us into tables and how to use tables in Excel, and probably primarily why to even bother with tables in Excel. And once we'd run through the whole chapter, hopefully you could see that there was a good reason for using tables, the ability to format the table very quickly, add totaling rows and columns, adding calculating columns, sorting and filtering. Even the data entry becomes a lot simpler if you convert your data into a table. And of course, adding a chart. Well, we know that that's F11. From tables, we moved to pivot tables, so the ability to summarize some section of data. We explored the recommended pivot table option, and we looked at how we could change the rows and the columns and change what the data is doing in the middle. So it doesn't have to sum numbers and count text. We can change the function and ask it to do other calculations such as average, min, max. We explored drill down and the ability to have grand totals and subtotals where you had multiple columns. We also saw pivot charts and how they differ from normal charts in Excel, and we saw the introduction of the data slicer to allow you to filter a pivot table very, very quickly. Finally, we explored connecting your SQL server to a pivot table in Excel, so that you're effectively pulling your data from an external resource. You never need to see that data in Excel, you just have the summary pivot chart and pivot table in your Excel file. We then did a little bit on non-pivot charts, looking at a few tips and tricks, adding trend lines and managing your trend lines, even looking at a dynamic chart range so that you don't have to adjust that every time the range changes so that your chart responds. And then we explored the new forecast worksheet, which is new to Excel 2016. We then started to explore some of the serious data power available in Excel, starting firstly with the Get and Transform tool, previously called Power Query. And we saw that we could connect to many different types of external data, either local resources like Excel and Access and even text files, and even folders. So we could connect to a folder and any update to that folder would be imported into your Get and Transform data tools. We even explored the ability of connecting to a data source held out on the web, in our case, the population data. This led us nicely into the 3D map, and we looked at how we could use the 3D map with data that we perhaps had brought in using Get and Transform, adding layers to the map, adding scenes to the map, so that you could create what effectively is a little mini movie that runs through your geographical data. And then once you've created that little mini movie, looking at exporting that movie so that you can send that to somebody outside of Excel where it has got its data from. Then came Power Pivot. Power Pivot is pivot tables on speed. Now Power Pivot is not available to every version of Excel, so you need to make sure that your version of Excel has the ability to install Power Pivot. In 2016, that means buying the standalone version of Excel. However, once you've got your Power Pivot installed, you can then generate some seriously powerful connections to external resources. You remove the limitation of 1 million rows that you have in Excel, and you can connect to a series of external data, whether that's an external database such as SQL Server or Oracle, or even a number of external Excel files, or even as we did, connect to one of your data sources that you can use with Power Query, and then pull that into Power Pivot. So you can then create some pivot tables and pivot charts using that same external data. Then we sort of let our hair down a little and explored GoalSeek and Solver. GoalSeek being the little baby of Solver, really, having very minimal configuration. You simply say, I'd like to set the value of that cell by changing this cell, please. Whereas with Solver, we can set the value of a cell, but change a number of other cells, even the ability to give Solver some constraints to work within so that it can try and target what you're effectively trying to achieve. And our final section was introducing the data analysis tools. Now, there are many tools in this pack, so we looked at installing the pack and then just effectively looked at a number of those tools being the descriptive statistics, the ability to create a moving average, and then a histogram with bell curve. This section is certainly one that is worth exploring if you're into statistics, because most of those data analysis commands are statistical analysis and are worth it if they're the kind of thing you need to explore, so you can take your knowledge that little bit further down the line. Hopefully you've enjoyed this title and you've learned something and you're going to make use of it every day. If you do have any queries, questions or comments at all, then please direct them straight to me, Guy VACCARO, using my email address training@nybytes.co.uk. And thank you.